Bhushan, can you hear me?
Yes, sir.
But Judge sir, your voice is echoing, huh?
Namaskar, Mohan sir.
Now is it okay, sir?
Yeah, it's okay now. Ajit More sir is trying to speak something. Sir, are you on mute? Ajit More sir, you are on mute.
Yeah, good morning, Kaju sir.
Good morning. Good morning, sir. Nice to see you.
Nice to see you after a long time. Yeah.
Yes.
Sheikh madam. Yeah.
More sir, good morning.
Yeah, good morning, sir. Acharya sir. Good morning.
नमस्कार सर.
Namaskar, namaskar. Sheikh madam, namaskar.
Uh, Let me check if Dr. Sanjay Kadam has joined.
सर कदम सर ने ज्वाइन कर लिया है. He has already joined in.
अच्छा.
संजय कदम सर, लेकिन I guess he is not visible here.
Bhushan, confirm whether all the participants are in, and then we can start.
Kadam sir, your microphone, it is very much stable.
Okay. Hello.
Sir, yes, you have unmuted it. Sir, can you just on your camera also? Kadam sir.
Okay, I'll just see. Can you hear me? Yeah.
हो गए 100. YouTube पे अभी स्विच होंगे ना सब.
Bhushan, do we need to open another group since 100 people have joined now?
नहीं सर, YouTube पे ऑलरेडी लाइव चल रहा है सर. सो दे कैन गो देयर. YouTube पे ऑलरेडी 40 प्लस है, तो ऑलरेडी लाइव वहां पे चल रहा है सर. सो दे कैन गो ओवर देयर एंड दे कैन मींस सी टू इट.
And how many we can accommodate in this Google Meet?
सर 100.
हो गया.
100. Okay.
हाँ, बिकॉज सर इन आउट हो रहे हैं अभी भी इन आउट हो रहे हैं, तो वील हैव अ फाइनल कॉल. एक बार सिर्फ कदम सर के लिए रुके हुए.
Okay.
सो वंस कदम सर का एक बार सही से हो गया तो देन वील स्टार्ट.
Yeah, Kadam sir's session is immediately after inaugural program. That is at 10:30. So I think within 2-3 minutes we can start now. Yeah, Kadam sir is available. I think they are setting his video camera and all.
अरशद भाई.
Bhushan, one suggestion only.
हेलो.
Bhushan,
हाँ सर.
one suggestion before vote of thanks, we will be showing this NCDM proceeding.
सर वो सब हो गया है ऑलरेडी सर. इट इज इन द.
Everybody got the copy. Hard copy है सबके पास.
कुठं जायचं?
कशाला डोकं खातं उगाच आहे. हार्ड कॉपी आणि हे आणि ते. गप बस ना.
Bhushan, mute your voice.
Hello?
Mute your voice, Bhushan.
Javed sir,
Yes, sir.
I think so. The proceedings release function of the proceedings is already taken care of, and it's a part of entire inaugural ceremony that they have. That's scheduled.
Yes.
Okay? So I think so. That will be taken care of. Okay, are we ready? Sanjay Kadam sir, welcome and good morning.
Good morning.
Sanjay Kadam, sir, good morning.
Good morning. Can you hear me?
Yes. I hope you can hear us.
Yes, sure. Can you hear me?
Yes, sir.
Yeah, okay.
You're audible.
Okay.
We have Dr. Haridasa Acharya also with us, and Dr. Roshan Kazi is also with us.
Dr.
Dr. Ajit More is also.
Dr. Ajit More पण आपल्या बरोबर आहेत.
Good morning, sir. Kadam sir.
Good morning.
Roshan sir, can we start?
Yes. If we are ready, all under control.
Kadam sir, Acharya sir, with your due permission, can we start?
Yeah, sure.
Yes, we can start.
Okay, sir. Just a moment. Aisha,
Yes, sir.
please go ahead.
Good morning to all dignitaries, guests, delegates, and students with great joy and immense exultation who are attending this seminar online. I, Aisha Haq,
And I, Noreen Tikuna,
feel privileged to extend a warm welcome to all presented here for NCDM 2021, a two-day national e-conference on data mining and ICT in bioinformatics, agroinformatics, business management, healthcare management, and medical informatics.
many feelings may come and go, but that feeling when we hear our national anthem that raises goosebumps is irreplaceably magical. With these words of Miss Shreya Shukla, we request everyone to kindly stand up for our national anthem. We request our tech support team to kindly project the same.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I request everyone to please settle down. Our program will start in a few moments. Thank you.
Winston S. Churchill once said, "Success is not final, failure is not fatal. It is the courage to continue that counts." And keeping the same thing in mind, I request my tech support team to relay a movie celebrating the glorious journey of Alana Institute of Management Sciences. Ladies and gentlemen, this is Alana Institute for you.
Now keep quiet, huh, Dada. Please, if someone comes. Before I request Professor Dr. Roshan Kazi, Director in charge of AIMS, to deliver the welcome address, I request Ms. Sobia Khan to introduce our Chief Convener, Professor Dr. Roshan Kazi, to our audience.
Thank you, Nuri. It's a great honor for me to introduce our director, Professor Dr. Roshan Kazi. Sir is a professor and in charge director at Alana Institute of Management Sciences, Pune. Sir specializes in applied statistics and has taught business statistics over several years. Sir is a sought after trainer in statistical software SPSS. Sir has a PhD in Business Administration from the University of Pune and postdoctoral fellow in management from Indian Institute of Management, Indore. Sir has national and international publication to his credit, and his papers have been published in referred journals like Journal of Marketing and Communication, Indian Journal of Management Prabandhan, International Journal of Management Cases, Darwin, Lancashire, UK, Global Business and Management Research International Journal. Sir is known for his workshops on data analysis using SPSS. He has channeled his interest and energy into a successful career in teaching. He is a research guide for doctoral students under University of Pune. We are blessed to have you as our director, sir.
Thank you, Sobia. Now I would like Dr. Roshan Kazi, sir, to deliver the welcome address.
Thank you, Noorin. Thank you, Sabia. I'm audible?
Yes, sir.
Okay. Uh, Dr. Sachin Kadam, Senior Director, CDAC Pune. Dr. H.S. Acharya, IT wizard, IT genius, IT expert. Professor Javed Khan, Assistant Professor, MCA Department, Alana Institute of Management Sciences, Ms. Tabassum Sheikh, Coordinator MCA Department, Professor Muzaffar Sheikh, Professor Irfan Sheikh, CDC members of AIMS, invited guests, participants, faculty members, research scholars, and all my dear students. Good morning. I have been given this wonderful opportunity of welcoming all the guests and participants for this wonderful program, NCDM. So I'm both delighted and honored to do this task. So I take this opportunity to greet you all to this marvelous NCDM program that has been organized by Alana Institute of Management Sciences. Welcome all of you. Let me also keep you informed that there's a message from Inamdar sir and Inamdar ma'am that unfortunately due to some eventful engagement, they could not be a part of this program, but they have conveyed their best wishes and regards to us. NCDM is one of the flagship events of Alana Institute of Management Sciences, like Anveshak, Checkmate, and Happenings. And it's a very electrifying kind of sessions, and we are very excited about the planning and execution of this session. I feel very happy to state that in the past, we had 4 editions of NCDM, and they were quite successful. We were very lucky that these editions were witnessed by scholars, eminent personalities, and noticeable speakers. This event, I mean, I feel happy to say this event has been instrumental in building that pool of knowledge. It has always strived to create a platform for both the for scholars from both academia and the corporate to come together to discuss, to debate on several issues related to information technology. So all the past events that we have conducted for NCDM, we had research scholars, we had consultants, we had professionals, both from academia and corporates, to discuss current issues, recent trends, and the emphasis was on information technology. We are very blessed and lucky that even for this NCDM, we have quite a few distinguished speakers with us today. And they are going to take you on a wonderful journey of what data mining and information technology is all about. So I'll take this opportunity to acknowledge their presence in this August gathering. Dr. Sanjay Kadam, he's the Senior Director at CDAC, and he'll be talking on machine learning, and he's going to give an overview of machine learning. He'll be also he's going to also cover deep learning and its applications. We have Dr. Ajit More, Director MCA at Bharati Vidyapeeth Deemed University, Pune, and the topic of his interest is artificial intelligence, rough set theory. Our programming, it's a workshop that is conducted by Mr. Titus Newton, Technical Trainer, Seven Mentor Private Limited. We also very happy to have with us Dr. Baljit Kaur, Assistant Professor at Bharati Vidyapeeth Deemed University, Pune. And she is going to have an introduction to web scraping in research. Dr. Sonal Khosla, Data Science Consultant Trainer, Infinity Global from all the way from Germany. And the topic of her interest is natural language processing. Mr. Munawar Sheikh, I think so he's also be a part of this event. Besides this, I feel very proud to state that since this is a conference, we had invited some competent research papers, and we are lucky to have enough research papers which were been initially scrutinized by a team of experts. And very soon we're going to have presentations of these papers during the 2 days program that we have. And these papers will be assessed and evaluated by Dr. H.S. Acharya, Professor Ames, he's a session chair. Dr. Junaid Faruqi, he'll be joining us all the way from Dhofar University, Oman. And towards the end, we'll be announcing the winners of our paper presentation competitions. We have 2 tracks, one is for students and the other is for faculty members. Achha, just to keep you in perspective about the theme of NCDM, it is quite exciting. It's data mining and ICT, information and communication technology. I'm sure most of you, you're not alien to these terms, but definitely you will be wanting to know the scope and magnitude and the importance of these ideas. It won't be wrong if I say that today, data science lab, data science, data mining, machine learning, information retrieving, analytics, multivariate data analysis, Python, R, programming, SAS, SPSS, Minitab, Vecca. These are all become buzzwords, and students have become today crazy about these courses because they have realized these are in high demand and they are job guaranteed courses. So that's the reason why we have a theme for our NCDM as data mining and ICT. Actually, let me also add that as far as businesses are concerned, data science has today become a new strategy for business excellence. And it's the best practices for the 21st century. Research has shown that Today, companies are struggling with the huge amount of data that they collect on routine and daily basis. They are wondering how is it possible to extract meaningful information from this data that has been collected. Also, let me keep you informed that the benefits of data science, data mining, ICT is twofold. It is going to be advantageous to both the sellers and the buyers. How it is going to benefit the business community? A proper application of all these tools and techniques is definitely going to ensure that companies come out with better forecast. They are in a better position to understand relationship between variables. They will be doing proper predictions. It is going to help them in decision making and also in generalization. So that's the first benefit to the corporates. It won't be, once again, an exaggeration if I say that the knowledge of data science these companies have is going to decide who is going to be the loser and who's going to be the winner in the corporate world. And if companies are desirous of incremental growth, then it is extremely important that their strategies and policies are data driven. There are three major problems that companies today face with reference to data that they've collected. Number one, a huge amount of data is collected on daily routine basis. Why? Because the world is gone online today. Customers are not feared of making purchases online. They are paying online, their bills are online, their transactions are online. So a huge amount of data is collected on a very daily and routine basis. And this data relates to what? This data relates to consumer profiling. This data relates to consumer transactions, consumer purchasings. This data relates to employee performance. This data relates to supply chain, which will definitely in the long run help understand and enable the companies to better manage their policies, better manage their channel members, and have a deep insight into the psyche of the consumers. Okay, the problem is when so much of data is available, what data should be used for processing and interpretation purpose? Number one. Number two, what are the right tools and techniques for processing purpose? What statistical mathematical tools should be applied so that a meaningful information can be derived from the raw data that has been gathered? And the third most important challenge these companies face is how do you interpret these data for informed decision making and for strategy formulation? And I'm sure the two-day national e-conference that has been organized by Alana Institute of Management Sciences is going to throw light on these important questions. Achha, let me also give you all the students who are joined this program this morning that today data science, data mining, or Tableau, or for that matter, bioinformatics, machine learning, all the algorithms, they have created new avenues of opportunities. And students who have sound knowledge of all this, the so-called courses and jargons that are used, are always in demand. So these 2 days are definitely going to be a fruitful learning to all of you. Make the maximum use of these 2 days and sessions that we'll be covering in these 2 days. You'll be definitely benefited out of this. I once again welcome all our speakers, all our distinguished speakers. I say thank you from the bottom of our heart that you spared your valuable time for our students and participants. And I'm very sure that your ideas and thoughts is going to be a lot of encouragement and motivation to our students, and it's going to be propelling in their future career. So welcome all of you. Stay curious, stay blessed, and happy learning to all. Thank you.
Thank you, sir.
Before I request Acharya sir to give his opening remarks, I request Ms. Sobia Khan to introduce our Professor Dr. Haridas Acharya to our audience.
Thank you, Aisha. Professor Dr. H.S. Acharya. Sir is currently associated with Alana Institute of Management Sciences, Pune, as professor in MCA department. Sir is also the visiting faculty at Symbiosis, Bharati Vidyapeeth, Pune College, DSM College, and Rajiv Gandhi Institute for Biotech, Pune. Sir has also worked as associate professor at SICSR Pune and as head for Center of Excellence in Data Warehousing and Data Mining at SICU Pune. So has done multiple research in the field of agro-information systems, design of experiments, analytics, databases, commitment schemes and DES, artificial neural networks, packet classification algorithm, e-pedagogy and many more. Searle has published more than 60 research papers on various topics such as design of experiments, information system, database system, engineering computations, education and research, agricultural economics, medical informatics, natural language processing in national and international journals. We are honored to have you with us, sir.
Thank you, Sobia. Now, I would like to request Dr. H.S. Acharya sir to give his opening remarks.
Thank you, Sobia, for a nice introduction. Dr. Roshan Kazri, our director, Sanjay Kadam, Dr. More, invited other invited speakers, delegates, my colleagues, students, and ladies and gentlemen. I'm very happy that this is the 5th version of something which we started in the year 2011 as a series of events to bring together teachers of MCA colleges, students of MCA and MBIIT, because somewhere around 2011 MBIIT was just coming up. Now MBIIT has become quite popular. Bring them together, encourage them to write research papers, encourage them to initiate research. And I know most of the participants are from MCA colleges who are teachers who would like to do research, and students who are totally targeted, because initiating students into research was a very tough job in the years 2003, 2004, probably because the job opportunities in the market were so high and everyone was attracted with. I mean, software development was the only thing people could think of during those days. Analytics became very popular and people started realizing the importance of analytics. Before that, analytics was taken care of by mainly statisticians like me, mathematicians, and few people with background in physics. You'll be surprised to know that the very senior analysts are all having very, unbelievable backgrounds, which analytics had a pattern during those days. It was basically dry computations, most of quantitative methods using lots of statistical algorithms. But once the experts from IT field have entered into it, the thing has changed. Now analytics starts with do it yourself attitude. You have lots of tools available with which you can begin your journey. It is take data, learn how to handle it, create visualizations, try to interpret. You'll definitely make mistakes because still you don't have adequate experience of maybe quantitative methods. But you learn quantitative methods as you progress. So first visualization comes, and then interpretation comes. So there are two branches which are opened very heavily. Within this domain of information technology, people who learn, who create machine learning, who create artificial intelligence have a big role to play. But there is another large chunk of people. See, after all, the degree we give is Master of Computer Applications. You have to make the computers do something for the common man. And Master of Computer Applications is learning all these things and thinking about possible applications in the common world. It is the ultimately it is the common man who has to benefit, and the whole thing has to change. Now everybody talks about artificial intelligence, but then how do I in the same thing which I was doing some 5 years back? Can I introduce artificial intelligence into those transaction processing applications which I have written? I think it is possible, and the people who will be actually delivering lectures and the technical content which we actually give you should really help. As I told you, the very purpose of NCDM was to encourage people to write. I have a few success stories. I know a person who started as a very small network teacher, and now he is an experienced and recognized Dell trainer. And what has changed his life? When he came to us, he was simply a network Cisco trained person. When he started thinking applications, and he actually combined analytics with his own knowledge, the things changed. One of our faculty started his life of research as a image analyzer for the common pan which we eat, bit leaf. But that was the experience with which he started, and NCDM gave him opportunity. Further, we had a lot of interactions with us, and now he is one of the most recognized machine learning algorithm writer. He is a recognized artificial intelligence application generator. In my introductions, someone told that I have interactions with the biotechnology students. Biotechnology students learn programming at a very later stage. It is their idea of biotechnology, which is very important in the beginning. But once they accept analytics and they learn programming, they become very useful application generators for this the community. See, you must have recognized that in the last 1.5 years, analytics has played a tremendous role in how healthcare is handled. So medical healthcare management and medical informatics was one dominant area which actually we started with when we started with the idea of NCDM. Of course, there was another reason for choosing this area, because at that time all other fields were so saturated, and very big companies actually taking part into it. So healthcare informatics was the natural least competition field in which we could applications could be written and we could have actually entered. So we started with healthcare and management and medical informatics as our core. I'm happy to announce that one of the research scholars in this research center has written a chapter in one of the international publications on healthcare analytics. And now she's almost internationally known. Healthcare analytics was the requirement somewhere around 2011, 2012, and now it has become one of the most dominant areas where artificial intelligence is required, decision making is required, remote control is required, virtualization is required. One of the reasons why we suffered during the pandemic was The patients who were there in the ICU could not even contact their relatives outside properly. They could not even complain that I have not got my lunch. It's since half an hour I'm waiting for it. They could not even communicate this to their relatives. Once they communicate that to their relatives, huh? And then relatives can do something about it. But in the ICU, they were all stuck. Communication between the patients and their relatives was hampered. And you think of it, it must be a very simple application. So there are lots of opportunities, and anyway, e-commerce is a thing everyone actually has experienced. You try to buy something, then you will find an advertisement coming below saying that those people who purchased above are also have also purchased this. So it is almost as if you are talking to a salesman. The life has changed. Artificial intelligence has entered, but artificial intelligence cannot enter into any application without analytics playing an intermittent role. Lots of transactions took place. Analytics does something. It passes that information to the designer and he brings in artificial intelligence to it. Of course, development of small cameras, the other devices, electronics has contributed a lot. But there is a role to play for those people who do a lot of analytics. They are the people who actually act between the real developer and the consumer. And you know that I've just given you the purpose of this particular conference, and over the years we have seen that lots of such people have benefited of it, and most of our academic MCA and now of course MBA IT staff, they find a platform where they can present, and we are happy that we received more than 20 papers, around 10 faculty members and nearly 10 students who are willing to present. And there is a slight change even in the student community. Earlier it was very difficult to actually enter the student community to write, because unless you write once, see, analyst has to also talk to people. Analyst has to explain what he has done. He has to interpret it and present in front of the HR managers. He has to present it in front of the finance managers. He has to convince them that this is a better approach. So so you can actually, what otherwise would give you so much profit can give you more profit. And one domain which requires service of analysts very far dominantly is insurance. Risk management is something which has to have analytics as the component. And nowadays practically transactions take place on computers, and the inference is visible to the managers on computers. So somewhere analyst is sitting on that volcano of data which may explode at any time. It's increasing. But then life has become very simple. Very simple means I don't mean very simple, but it has become simple for analysts because they can start analyzing first. They can use visualization tools. They can learn to interpret, and slowly learn more and more of basic statistics as the life progresses. So the role of an analyst, role of a developer, and role of a person who can talk to others. So it's a combination of three types of people put together that the real application into the day-to-day world. So not only contributing computers to computer world is important, so is computer applications important. See, one of the important associations we had over the last 2-3 years was with CSIR. We have people who are actually analyzing the data on patents. So we can be very proud of saying that we are the only people who have such association with national laboratories. So I would like to conclude here. Somewhere in the afternoon we have paper presentations, and you have some invited speakers on machine learning, deep learning, R language, and you will be waiting to meet them, listen to them. So I thank the organizers to give me having given me an opportunity for giving the opening remarks for this particular conference, and wish you a nice journey. Uh, Happy 2 days. Please enjoy what you. Well, web scraping is something which is very important, which I've added to our collection of topics. Thank you so much.
Thank you, sir.
An important agenda for this e-conference is to encourage academicians and researchers for paper writing and publications. We are pleased to announce that we had received competent research papers for the national conference, and we received a positive response from budding researchers across the country. A proceeding of abstracts of papers selected by the desk review committee has been printed. We would like to release these abstract proceedings at the hands of the honorable dignitaries who are with us today. I request the dignitaries to kindly switch on their cameras and release the abstract proceedings.
Thank you to all the research contributors.
A link is circulated in the chat box and YouTube Live, from where you can download the copy of this abstract proceedings. Thank you, everyone.
Thank you.
With this, we come towards the end of our inauguration function for NCDM 2021. Now, we will be starting with the sessions from our eminent speakers. But before that, I would like to request Professor Javed Khan sir from MCA department to propose vote of thanks for this session.
Good morning all. Honorable guest of honor, respected director sir, our most valued invited guest speakers, ladies and gentlemen. It's my pleasant duty to present vote of thanks for the inaugural program of NCDM 2021, which is the 5th National Conference on Data Mining and ICT. I, myself, Professor Javed Khan, on behalf of Alana Institute of Management Science, would like to express our gratitude and thanks to Dr. Haridasa Acharya sir for joining us as a guest of honor for this inaugural program, that is 5th National Conference on Data Mining and ICT. Dr. Acharya sir, thank you very much for gracing for this inaugural program and encouraging us with your valuable thoughts on data mining and ICT. Sir, it is our great pleasure to have you with us and guiding and mentoring to all of us, including our faculty members, research scholar, students since last 10 years. We all are very grateful to you, sir. Thank you once again. I would like to express our gratitude and thanks to Dr. Roshan Kazi, sir, Director in charge MCE Societies, Alana Institute of Management Science. Our sincere thanks to you, sir, for guiding us with a wonderful speech and opening remark. Thank you very much for granting all the permission to conduct this conference. Dr. Roshan, sir, thanks for briefing about the NCDM 2021 conference and explaining us the benefits and application of data mining and data analysis. Sir, thank you once again for encouraging to all of us in this inaugural program.
Thank you,
We are also grateful to Dr. P. Inamdar, sir, President MCE Society, Mrs. Abida Inamdar, ma'am, for providing all the facility and their continuous support and encouraging for conducting such programs. We are grateful to all the trustees of MCE Society also. Let me express our thanks to organizing team, technical team, MOCs for nicely arranging this inaugural program. On behalf of Alana Institute of Management Science, MCA department, permit me to mention our appreciation and thanks to all the invited speakers, especially Dr. Sanjay Kadam, sir, Senior Director, SIDAC Pune. Sir, welcome, sir, and thank you for being present here in this inaugural program. Very soon we will have sir's session now. At 10:30 we will have sir's session. I think we are lagging behind. So within a 5 minute we will start a technical session from Dr. Sanjay Kadam, sir. Let me recognize and appreciate the presence of Dr. Ajit More, sir, Director MCA IMET Bharati Vidyapit. And also I would like to appreciate the presence of all the faculty members, research scholars, and all the participants. We are also having many dignitaries and many participants from Oman, from Germany, from Aurangabad. I welcome all of them in this NCDM conference. We are delighted to see the online presence of many delegates from the industry, from the IT industry, from the manufacturing industry. I welcome them all and I appreciate their presence in this inaugural program. We are also happy to see the online presence of all the MCA students, and we are also delighted to see the online presence of all MBA students and PhD scholars from Alana Institute of Management Science. So please enjoy NCDM 2021, 5th National Conference on Data Mining and ICT. Thank you one and all. Thank you once again. Thank you very much.
Thank you, sir.
Good morning to one and all. I, Nooreen Dikuna, welcome everyone to the first session of NCDM 2021. The topic of this first session is Machine Learning and Overview, and the honorable speaker for this first session is Dr. Sanjay Kadam. I now request Sobia Khan to once again introduce today's guest speaker to the audience who have joined in now for Sir's session.
Thank you, Noori. It's a great pleasure for me to introduce our first speaker for the day, Dr. Sanjay Kadam. Sir is currently associated with SIDAC Pune as Senior Director. He has a PhD in Computer Science from University of London, UK, MTech in Computer Science from Indian Institute of Technology, IIT New Delhi, MSc in Mathematics from Pune University. He has been a recognized PhD and MPhil guide at Savitribai Phule Pune University and has successfully guided several MPhil, MTech, MS, and PhD students in computer science and scientific computing. His, his research interests are in high performance computing, image processing, neural networks, and machine learning. He has several journal and conferences publications in his name, and he has also delivered talks in the above mentioned areas in several workshops and conferences at various institutes and organizations. We are honored to have you with us, sir.
Thank you, Sobia. Before going ahead, some general instructions for the participants. The conference is managed and monitored by the college officials, so please maintain the decorum. Whenever you are interacting with our guests, it is expected that your cameras will be on. If you have any doubts or questions, then you can enter your queries into the chat box, and at the end of each session, the answers will be given by the resource person collectively. Now I would like to request Dr. Sanjay Kadam sir to start with his session.
Hello, can you see the slide screen?
Yes, sir.
And can you see it moving?
Yes, sir, we can.
Okay, so I'll be giving an overview of machine learning. I hope I'm audible.
Yes, sir, you're audible.
Okay. Yeah, so I'll be giving an overview of machine learning. and my session would revolve around these points. So I'll start with introduction to machine learning.
I think sir's voice is very low. If you can increase the voice, please, sir.
Okay, is it okay now?
Yes, little higher. If you can increase more.
Hello. Yes. Is it okay now?
Yes, now it is okay.
Yeah, so I'll be discussing different machine learning models, like the popular ones, which are popular ones which are on Kaggle. So if you see the Kaggle website, I mean, so the most popular ones are as given here. So it is the logistic regression, decision trees, random forests. Then currently the most used is gradient boosting and also XGBoost, that is extra gradient boosting. Naive-Bayes, which is conventional algorithm, and on the SVM, which is very popular. So these are the algorithms which I'll try to cover in whatever time I have been allocated, and we'll take the question answers in last 5 minutes. Yeah, so we'll start with machine learning. So machine learning essentially is getting computers to learn and act like humans do. I mean, and that is done by feeding them data in form of observations and real world interactions, and improve the learning over time in autonomous fashion. So as you can see in this cartoon diagram, without machine learning, what we essentially do is we basically write a program and do the needful. But with machine learning, we feed the machine the data, and the machine will build a model which will help us to do something like predict or classify. In the context of artificial intelligence, so this diagram, which is on the internet as well, so you can see that artificial intelligence is essentially developing mechanisms or developing computer models or programs which behave like human beings. So if you have heard of robotic automation, like the transactions we do on the internet, like suppose we want to purchase some product on Amazon, or whether or we like to do some banking transactions. So all these processes are automated. So that constitutes the artificial intelligence. There's a term for it, which is called as robotic automation. Machine learning is a subset of that, which essentially involves training computer models for prediction and classification using large data. And deep learning is a subset of machine learning, which essentially involves use of artificial neural networks, artificial neurons, to do the learning. So how do you, this is a process of building a ML model. This is a typical process. So we start with the data collection and preparation. So we collect and format the data. So there is the data cleaning that happens, and we get the data in a form which is identified, by which you can train a machine learning algorithm. Then using the data, we extract important features, because we cannot use the raw data because it will be a huge thing to do. So we extract important features from the data, and if there are a lot of features, then or if the features are correlated, we reduce that correlation, and we also reduce the dimension of the data. So we perform dimensionality reduction, that is using principal computer analysis, if it is required. So once we prepare the data for machine learning, the next job is to train. So we use some appropriate machine learning algorithm with the features that we extract from the data. And the third thing is, after you train some machine learning algorithm, we evaluate the model and see how well it performs. So to evaluate, we use a test data, or we use some validation set to evaluate the trained machine learning algorithm. And finally, we fine tune the model to get the maximum performance. So typical characters are like, we shouldn't be doing overfitting. So we need to check whether the model has been appropriately trained and we have not overfitted that model. So these are the steps typically involved in machine learning model. So I'll just summarize again: data collection, data preparation, model fitting, model evaluation, and hyper parameter tuning. So there are two ways in which you can do the learning. One is supervised learning, where we present the features as well as the class labels. So for example, we have this flower here. So this is an iris flower, and there are three categories, that is setosa, versicolor, and virginica. And these are the four features as you see on the table. So we take the sepal length, sepal width, petal length, and petal width. So there are four features, and we have the target, that is the class labels. So for example, in the first row, the class is 0. The second row, for the second row features, the class label is 2, and so on. So we feed the features as well as the class labels to the machine learning algorithm, and then we train that machine learning algorithm to get these associations between the input features and the target. So that is what sorry. So that is what is called as supervised learning. In unsupervised learning, we don't present the target levels. So we just input the data, and the model will find the clusters within the data based on some similarity measure. So the popular machine learning algorithms are as shown here. So we have the ones in supervised category, that is naive-Bayes, KNN, decision trees, and so on. And then the ones in unsupervised category, that is k-means clustering, a priori algorithm. Then we have what is called as ensampling technique, where we combine a lot of machine learning algorithms and do the classification or prediction. So we have bagging with random forest, and we also have what is called as boosting. So the typical algorithms are ADA boost, gradient boosting, and XG boost. And then we have neural networks. So we have shallow networks as well as deep neural networks, which can be trained in supervised and unsupervised fashion. And finally, we have reinforcement learning, which is different from the above ones, that is supervised and unsupervised. So in reinforcement learning, there is an environment and there are some actions. So based on correct action, there is a reward, and based on incorrect action, there is a punishment. So based on this mechanism, the learning happens. So as I said, if you visit Kaggle is basically a community where you can basically get, you can share your own machine learning code that you have developed for some application. You can get the data sets. So there are around 50K data sets for different domains, like bioinformatics, image processing, and so on. And there are then of course you can register for different courses, machine learning courses, and there are competitions on Kaggle. So if you want to develop some machine learning algorithm for some domain, like say image processing, so you can do that. So it is a community. So if you see the popularity index of different machine learning algorithms, it is as shown here. So the most popular is logistic regression. So this is basically it was basically this is the data of I think so last year. So the logistic regression is the most popular one, followed by random forests, decision trees, ensemble methods, gradient boosted machines, neural networks, the Bayesian techniques, SVMs, and so on. So we'll be discussing the most popular ones in this session. Okay, so we'll start with the first one, that is logistic regression. I hope I am audible.
Yes, sir.
Okay.
Yes, sir.
Yeah. Yeah. So logistic regression. I mean, it basically involves predicting categorical classes, like the prediction values are discrete, like student passing or failing. So whether a student will pass or whether a student will fail. Unlike in linear regression, where the values are continuous, like if you want to predict rainfall, so that is a contiguous variable, so like rainfall in centimeters. So in logistic, it is a categorical a variable that gets predicted, like someone has a disease or doesn't have a disease, and so on. And for that, we use a logistic function to perform the binary classification. So for example, event y occurs is denoted by 1 and not occurring denoted by 0. So here there are two diagrams. So y is equal to 1. So the red dots basically indicate the categories. So y is equal to 1 is class 1, like suffering from disease, for example. And y is equal to 0 is probability of that disease not being present. So not suffering from a disease. So if you try to fit a linear regression, it doesn't quite work. I mean, the line doesn't quite fit the data points because there are just two categories of data points, yes or no. So what we do is we fit a logistic regression, which is an S-shaped curve or it is a sigmoid curve, which gives the probability of a data point belonging to either of the two classes, either it is class 1 or the other class. So there are two entities involved in this. So one is the logit function, which is basically log of the odds ratio, and other is the logistic function. So let's go to the first one. So the log of odds is basically which is as given here, that is log of p upon 1 minus p, where p is the probability that the event y occurs. So it could be disease occurring, like the probability that a disease occurs in a particular person. So y is equal to 1 means it certainly occurs, and y is equal to 0 means it doesn't occur. So that p is that probability, and 1 minus p is of not occurring. So p is basically probability of occurring, and 1 minus p is a probability of not occurring. So we take a ratio of that, that is p upon 1 minus p, which is called as odds ratio, and we take a log of that. So that is what is called as the log odds ratio, and or the logit function. So logit function essentially correlates x with log odds ratio y dash. And once we get y dash, we can get back the probabilities. So it is simple rearrangement of the terms. So from this, that is log of p upon 1 minus p is equal to y dash, which is this. We can rearrange the term, that is we can so this will be e raised to y dash is equal to p upon 1 minus p, and then you can find p. So that is what is the logistic function, which is this S-shaped curve. So it gives predicted probability associated with any particular value of x. So it will tell you what is the probability of x belonging to a particular class, that is the binary class, either class 1 or the other class. So let's take an example. So here we have a table where in the first column denotes x values, that is the medication dosage, that is 20, 30, 40, and 50. So that is in ml. So this is the amount of dosage given to the patients. And based on the amount of dosage given, the patient's cured. So for example, if you give 20 ml of dosage, then the patients cured are just 1, and these are the total patients. So 1 out of 5 gets cured. But if you increase the dosage to 30, then 2 patients are cured out of 6. If you increase it further, then 4 get cured out of 6. And for 50, 6 get cured out of 7. So this y is the probability of patients getting cured. So if you divide 1 by 5, you get 0.2. So it is the number of patients cured upon the total patients observed. So these are the probabilities of patients getting cured. And then we have the odds ratio. So this is 0.2 upon 1 minus 0.2. So that is the odd ratio, that is cured versus not cured. And we take the log of that, that is the logit. So now what we do is if you fit a linear regression, that is ordinary linear regression, where the x-axis is the x values, that is the dosage, and y is this probability, that is probability of patients cured. So we get something like this, which doesn't quite fit well. So what we do is instead we use a logistic regression where there is less error between the prediction, what is getting predicted. So what we do is in logistic prediction, we basically do a regression, that is regression of x versus y dash, where y dash is the log of odds ratio. So this column gives a log of odds ratio, and we fit a line using simple linear regression. And once we do that, then we map y dash to the corresponding point in the logistic regression. So in the logistic regression, it is x versus y. That is a probability p of cure versus of the that is a probability of patients getting cured given some dosage. So we map this point and get the actual probabilities. So let's take an example again. So assume that we want p, that is a probability p for dosage value of 10. So how we go about it? So x is 10. So we compute the y dash, that is the log it of 10, which is using this regression. So we just substitute wherever there is x, we just substitute 10, and we get y dash, which is minus 2.7. And then we map that to this particular point here. So we find p of 10. So if you just go back, so what is p? It is e of y dash upon 1 plus e of y dash, or 1 upon 1 plus e raised to minus y dash. So the y dash is the one which we have calculated, which is this minus 2.7. So we put that value and get the probability. So from x, we get the probability of that particular person getting cured. So here it is 0.06. So that's how the logistic regression works. So given x, we find y dash, and given y dash, we find given y dash, we find the probability of that person getting cured or not getting cured. Okay, so this is the discussion on logistic prediction for logistic function for prediction. So we have this logit function, which is a log of odds ratio, and so that is equated to alpha plus beta x, which is this basically the line that we are fitting. And from this, we just get the probability, which is given by this particular expression, so, which is this. Okay, so now the interpretation, the alpha parameter that we predict, so that is basically log of odds of disease in unexposed. Then beta basically controls, or it is associated with being exposed, that is controls slope of the rise, and is the odds ratio, which measures the association between the exposure and the outcome. So here the exposure is x, which could be exposure to different parameters that the person undergoes. For example, if it is COVID, then the x could be different parameters which the person gets exposed, like his comorbidity, then whether he's exposed to people who are infected with the disease and so on. And the outcome is whether he would suffer from COVID or he wouldn't suffer from COVID. So this e raised to beta is the odds ratio, which will tell you the outcome. So it will tell you the odds. So if OR is 1, then the exposure doesn't affect the odds of outcome. If OR is greater than 1, then the exposure is associated with the higher odds of the outcome. So there is a higher probability that he would be suffering from the disease. And if it is less than 1, then there are lower odds that he would suffer from the disease. So this is how we interpret the different parameters and the ratios, odd ratios in the logistic prediction. And then how we find this alpha and beta. So there is a maximum likelihood method which does that. So there is some mathematics here which I won't go through, but the procedure is something like this. So we compute the log likelihood using the observations, then take the partial derivatives with respect to the alphas and betas, then set each partial derivative to 0 and numerically solve on the system of equations to get alphas and betas, and that is how we get the parameters. There are other methods as well. Okay, so this is about the advantage and disadvantage of logistic regression. So it is easy to train and interpret. It makes no assumptions of class distributions in feature space, and it can be easily extended to multiple classes. It has good accuracy, but however, the data set has to be linearly separable. So that is the main constraint. And it can interpret model coefficients as indicators of feature importance, and it is less inclined to overfitting. But if we have high dimensional data, then it can overfit. Amongst the disadvantages may lead to overfitting if the number of observations are less than the number of features. It essentially constructs linear boundaries. So for non-linear prediction, I mean, if the data is non-linear, then it doesn't quite work. And there is an assumption of linearity between dependent variable and independent variable. So non-linear problems cannot be solved, and it requires average or no multicollinearity between independent variables. So if there are correlations in the independent variables, then the results may not be correct. So we need to ensure that whatever data you have, we remove the correlations and then apply the regression. Okay, so that was about logistic regression. So next is we'll discuss about decision trees. So decision tree essentially is basically a tree where the nodes, I mean the root node is essentially some attribute, and the internal nodes also are attributes, but the leaves are the decision. So for example, here on your left we have a decision to play tennis. So there are three attributes which we look, that is outlook, that is how the weather is, and then the humidity condition, and the whether it is windy or not windy. So outlook is an attribute on which we are going to base the decision on, and it has three values. So outlook could be sunny, the outlook could be overcast, that is the weather could be overcast, or it could be rainy, the weather could be rainy. Then humidity could be high, so that is one of the possible values of humidity, and it could be normal. And the wind, it could be windy or it could not be windy. So if the outlook is overcast, then we play tennis. But if the outlook is rainy and it is not so windy, so we still play tennis. However, if the outlook is rainy and it is windy, then we do not play tennis. For the sunny branch, so if the outlook is sunny and if the humidity is high, then we don't play tennis because we'll sweat too much. And if the humidity is normal, then we play tennis. So this is how the decision tree helps to come to the decision. On your right, we have another tree to drive a car. So if your age is less than 30, then you can drive a car. But if it is a sports car, no. If it is minivan, yes. If you are above 30, then you can certainly drive a car. So this is how the decision trees work. So I'll repeat again. The nodes are the attribute values. The nodes are the attributes, different attributes like outlook, humidity, windy, and the branches are the attribute values. For example, this branch is sunny, so outlook is sunny, then this branch is overcast, so the outlook could be overcast, and the outlook could be rainy. So the branches are the attribute values and the leaves are the decisions. Okay, so with that, how do you form a decision tree? So there are two methods. One is using Gini index and other is by using entropy and information gain. Now all these things you may not be required to know, but it's always good to know how the inside of any algorithm. And the reason for that is you can fine tune the algorithm, and you can, so once you know how the algorithm works, then you can play with its parameters. So although you may use ready-made libraries in Veka or in Python, where you don't know, where there is no need to know how the algorithm works, but there is certainly a need to fiddle with the parameters to get the best performance. And to fiddle with the parameters, you should know how the algorithms work or what the parameters stand for. Okay, so there are two ways to build a decision tree. One is using Gini index, and Gini index is nothing but given a training set, It is 1 minus the summation of the sum of the squared probabilities of each class from 1. So let's take an example. So here we have a training class where there are two samples. One is plus and other is the circles, the shaded circles, the blue circles. So we have one sample from class 1, that is plus, red plus, and we have 12 samples from the other class, that is shaded circles. So what is the Gini index? It is 1 minus the probability of each class. So the probability of plus class is 1 upon 13 because there are 13 samples and plus is just 1. Okay, so there is just one sample of plus. So 1 upon 13 and you square that. And similarly the probability of other classes. So there are 12 of them. So 12 shaded circles. So 12 upon 13 and you square that. So 1 minus 1 upon 13 square minus 12 upon 13 square. So the value that you get is 0.142. So that is a Gini index. So GI basically favors last partitions and it is simple to implement, as you can see here. And the tree that you get is the card type, that is so card is basically classification and regression tree. Then using entropy. So what is entropy? Entropy is basically uncertainty or impurity in the training set. So if you have a training set where all the samples belong to single class, then we say that that particular training set is very pure. So in that case, the entropy would be 0. But if it is half samples of one class and half samples of other class, then the entropy is maximum, or the uncertainty of classifying any data point is not certain. So essentially it is given by this expression here, that is pi log pi, where pi is the probability of the ith class and summation of that. So again, let's take an example. So here we have one training sample where there is just one pattern from one class and 12 patterns from the other class. So what is the entropy? So you take the probability of each class, that is pi. So pi for plus is 1 upon 13 and you take a log of that at base 2. Then for the second class, the pi, that is the probability of the shaded circles. So there are 12 of them. So 12 upon 13. So total 13 samples we have. So 12 upon 13 into log of 12 upon 13. And what we get is 0.391. So the entropy is less. Why the entropy is less? Because if you randomly pick up a sample point from this set, it has more probability of belonging to the blue shaded circles because there are many of them. So we say that the uncertainty of classifying any point in this class is lower. If you take the second example where exactly half samples are from class 1 and half samples are from the other class. So in this case, if you randomly pick up any sample point from the training set, what is the probability of it getting classified in either of the classes? It is 50-50 because 50% of the samples belong to one class and 50% of the samples belong to other class. So we say that there is large uncertainty to classify the sample points, or we say that there is a lot of impurity in this class, in this training sample. So here the entropy is 1. So it will be 1 upon 2 into log of 1 upon 2 minus 1 upon 2 into log of 1 upon 2, which will turn out to be 1.0. Okay, so having understood the entropy, the information gain is the entropy at the parent node and the entropy at the child node. So in the decision tree, when an attribute splits a training set based on its attribute values, so the training sample would be split across the branches. And so in that case, we see the entropy, or we calculate the entropy of the parent and we calculate the average entropy of the child, and the difference of that is information gain. So larger the information gain, better is the attribute for differentiating the training samples. So we pick up that attribute which has large information gain, and that is how we build the decision tree. So information gain favors small partitions with many distinct values, and the type of tree that gets constructed is ID3 and C4.4, which you can construct using Wacom. Okay, so let's go through one example, that is creating decision tree using Gini index. So we have this data set here. There are 303 samples, and the attributes are the chest pain. So the value of the attribute is either you have chest pain or you don't have chest pain. So it is a category. Then a good blood circulation is another attribute whose value is the possible values are yes or no. And the blocked arteries again this is a third attribute whose values again could be yes or no. And the class is heart disease, whether a person would suffer from heart disease. Here again the values are yes or no. So there are 303 samples. Now this slide is from StatQuest. So on YouTube there is a StatQuest. There are tutorials by StatQuest, and you get tutorials in all possible algorithms like decision trees. Basically, you have tutorials explaining all possible concepts in machine learning. So you can go through that. So here our job is, given these data samples, how do you construct a decision tree to basically classify a person as be going to suffer from heart disease or not suffering from heart disease. Okay, so for that we use a Gini index. So now which attribute amongst the three to select as the root node? So for that we calculate the Gini index of each and every attribute, and we pick up the one attribute that has lowest Gini index, and that becomes the root node. And we repeat this process at each and every node. So we always pick up that attribute which has lowest Gini index and keep building the decision tree. So now for the chest pain, if you go back, so for the chest pain, if you see the attributes, like if it is no, then the heart disease is no. If it is yes, the heart disease is yes. If it is yes, the heart disease is no. Why no? Because the other attributes would be more significant in contributing to the heart disease. So the chest pain could be yes or no, but the outcome also could be yes or no for the heart disease based on the values of the other attributes. So for the chest pain, the Y, that means the Y branch, if a patient suffers from chest pain, the Y branch would basically divide those 303 attributes in as, so Y is basically for the S value of the chest pain, we would have 144 samples, and for the no value of the chest pain, we have 159 samples. Now amongst the 144, the people who would actually suffer from heart disease are 105, and who won't suffer from heart disease are 39. Similarly, for no value of chest pain, the people who would suffer from heart disease would be S, that is 34, and people who would not suffer from heart disease are 125. So although we have spread in Y end, we still get the mixed values for the class labels. That is because the other attributes influence the decision. Okay, now what is the Gini index for this leaf node? It is basically 1 minus the probability of each class. So it is 105, and total are 105 plus 39, square of that. Again, for this class it is 39, 105 plus 39 square. Then similarly, the GI index for this particular node is 1 minus 34 upon 34 plus 125 and minus 125 upon 34 plus 125. So we get GI of this and GI of that, and then we calculate the GI of the chest pain, which is the weighted average. So here the Gini index of the left node is 0.935, and 144 of them have gone through this branch. That is 144 samples have gone through to this branch. That is for chest pain is equal to S. So we take the weight of that. That is 144, and the total samples are 144 plus 159. So this is a fraction of the samples that go in this particular branch. Multiply by the Gini index of that left branch. Similarly, in this it is 159. So 159 upon 144 plus 159. So that is the weight for this, and multiply by the Gini index of this. So the Gini index of parent is 0.364. Okay, similarly, you find the Gini index of the other attribute, that is good blood circulation, which is 0.360, and for the blocked artery it is 0.381. So the good blood circulation has the lowest GI, which is given here. So that becomes the root node. So this becomes the root node. And then again we take the left branch and right branch and we distribute the samples. So here we have 37 oblique 127, that is 37 SS and 127 nose in the left branch, and on the right branch we have 100 SS and 33 nose for the heart disease interpretation. Okay, now once we have the root node, then we come to the left node and do the same thing. So at this, again we check the attributes. So now we check the chest pain attribute and we check the blocked artery attribute. That is, which attribute should be present here. So we calculate the Gini index of both the attributes and we pick up that attribute which has lowest Gini index. So here it is the blocked arteries. So we expand this left branch and we put a blocked attribute here, and this is the expansion of that particular decision tree. And we keep doing this. So we keep expanding the branches. For example, the blocked, the left branch of the blocked is taken by the chest pain, and these are the distributions. And we repeat this. For this branch, what happens is that the Gini index, when you put a chest pain attribute there, when you try to expand, the Gini index of the expansion is 0.2, whereas the Gini index of this is 0.29. So the impurity is lower if you don't separate the patients using chest pain. So we just leave this as it is. So we don't expand that. Okay. So the final decision tree, when we take the left branch, is as shown here. So at this point, we have worked with the entire left side of the tree and we get this tree here. And similarly, we can work on the right branch and we get the complete decision tree, which is as shown here. So this is how we construct the decision tree using Gini index. Okay, I hope this is clear.
Yes, sir.
Yeah, so this is, we have discussed about the categorical variables, categorical attributes, that is the attributes which have categorical values. So how about handling numeric data? So for example, weight. So we have, for weight, we have what is called as numeric values. So how we take care of that? So for that, we sort the patients by weight in ascending order and calculate the average weights for the adjacent patients. So for example, 155 plus 180. And you take the average of that, that is 167.5. Similarly, for 180 and 190, we take the average, which is 185. And for 190 and 220, we take the average, which is 205. And we calculate the Gini index for this particular test. So we calculate the Gini impurity. So for 167.5. So for weight less than 167.5, again, there are two branches and the samples would be distributed accordingly. So we would have one sample, that is 0 SS and 0 nose. And here we would have 4 samples, that is 3 SS and 1 nose. So we calculate the Gini impurity of this, and we calculate the Gini impurity of the parent node using the earlier mechanism that I explained. So that comes to 0.3. Similarly, we can calculate the Gini impurity for 185, that is weight less than 185. That comes to 0.47, and for 205 it is 0.27, and the lowest Gini impurity occurs for weight less than 205, which is the cutoff. So we pick up that, and so we form a branch of the tree where weight is less than 205. So we have a left branch and right branch. So this is how we do for the numeric data. Okay, so this basically completes the discussion on how one can use the Gini index to perform the to create a decision tree. Okay, now the other is the entropy based method. So I have already explained the entropy, and now there's a lot of mathematics here, but don't get bugged by that. Whatever I have explained earlier, it is same thing. So it is, so here essentially we have formalized the things. So for example, if you have training set V0 and it gets split, for example, the splitting could be in the playing tennis, the first attribute was the weather. So if the weather is sunny, we have some training samples going in that branch. If the outlook is overcast, then we have some training sets going in that branch. And if the outlook is rainy, then the remaining training samples go in on that particular branch. So the complete training set would split based on the attribute values, and this is what is precisely shown here. So we have V naught, and based on the values of the attribute V naught, we split the training set in terms of V1, V2, and Vn. So entropy is again as defined earlier. So so terminology. So C1 to Cm are the M training classes, and the training set V naught at some decision tree is split by the attribute A into subset, that is V1 to Vn. This YKI, so the first index is the class label, and the second index is the set label, that is V naught, V1, and so on. So YK0 indicates the number of training samples in class 1 in set V naught. Then Y20 indicates the number of training samples in class 2 in training set V naught, and so on. So the entropy is as shown here. It is basically the probability of that particular class over the total number of samples in that particular class. So Z naught is the cardinality of V naught. So it is YK0 upon Z0 into log of that particular entity, and summation of that. And so summation of the samples in that set V naught over all the training classes. So again, you can refer to the examples to understand the things. So for the 2-case problem, it is just this. For if there are m classes, it will be n of them. If there are m classes, there will be m such terms there. So this is for V naught, and this is for the general Vj. So once we calculate the entropy, then we calculate the information gain, which, as I said, it is nothing but the entropy of the parent and entropy of the children. So let's take an example here. So we have 30 instances, that is 30 samples in the training set. So there are just two classes here, that is plus and the shaded disks. So they get split. So we have 17 instances for class 1, and we have 13 instances for the other class. So in this also, again, the class labels get split. So this branch, that is basically the value of the attribute. So it could be S and the other branch could be no. So when the training set is split, again we get a mixture in the split. So again, mixture means again the samples would belong to different classes. So we calculate the child entropy, which is given by this expression here. So it is 13 samples of pluses divided by total number of instances are 17. So 13 by 17 and log of that minus 4 samples of shaded circles. So 4 upon 17 into log of that entity. So it is 0.787. And similarly, we calculate the entropy for this, which is 1 upon 13 log of that, then 12 upon 13 log of that, which is 0.391. So once we calculate the child entropies, we also calculate the parent entropy, which is given by this particular expression here. So the information gain is the entropy of the parent, which is 0.996 here, and the weighted average entropy of the children. So what we do is, because there are 17 instances here, so 17 by 13, so 13 instances have been split. So 17 upon 30, that is a weight for the first child, and 13 upon 30 is the weight for the second child. So where this 13 number comes, that is a total instances at the parent, out of which 17 have gone to the first child. So 17 upon 30 is the weight for this child. So that weight into the entropy of that particular child, and similarly weight for this is 13 upon 30 into entropy of that other child. So we get a weighted average. So now information gain is entropy of parent minus entropy of children, which is this. So we can use the information gain to select an attribute to build our decision tree. So that is one way. Other way is there is what is called as information gain ratio. So, but for that ratio, we need to find this SAV naught, which is nothing but when V naught splits the training set into these subsets. For example, here this attribute, some attribute would split the training set into 17 instances and 13 instances. So here V0, V1, Vn are essentially nothing, are essentially this. So this is V1 and this is V2 and this is V0. So we simply find SA V0, which is nothing but Zj upon Z0. So Z0 is the total number of samples. So in this case, it was 30. And Zj, I mean, it is basically 17 for class 1 and 13 for class 2. So it will be 17 for class 1 and 13 for class 2. So that is the SAV note. And we divide the information gain by this SAV note. And that is what is called as info gain ratio. So instead of using info gain, we use the information ratio, which is better than using infogation, which helps to build a decision tree more robustly. So the aim is to maximize the information gain. So let's take an example. So we have this training samples, so T1 to T8, and these are the attributes. So the attributes are habit, eats, and footwear. So habits basically is the possible values are Gabby, quiet. So Gabby is basically a person who talks too much. So it is that is what is called as Gabby, and quiet is the person who doesn't who's quiet. Then eats is a person eats either baked food or roasted food or fried food. Then the footwear is the person wears clogs, sandals. Okay, so there are two possible values. And the class. So if the class is either student or professor. So if the student, if in some sample, if the habit is Gabby and if that person eats baked food and if he wears clogs footwear, then the probability that person is student. Okay. But if the person is Gabby and if he eats roasted food and if he wears sandals, then that person is probably professor. And so this is how the class labels are given. Okay, so this is our training set. We use which attribute we use at the root node. So it could be either habit, eats, or footwear. But then to do this, to get this decision quantitatively, so we use the information gain ratio. So the information gain ratio for footwear for habit is 0.0047, which is calculated by all these things. Like you need to do you need to take that attribute, see it split, calculate the child entropy, and calculate the weighted child entropy, and subtract entropy of the parent minus entropy of the children, and then divide by this entity here. So that's how we calculate the info gain ratio for the habit. For training set V0, so V0 is the complete training set, that is T1 to T8 samples. So that is 0.0047. For eats it is 0.3233, and for footwear it is 0.360. So we pick up that attribute which has maximum information gain ratio, which is in our case it is footwear. So that becomes the root node. And so T1 to T8, so all the samples, and footwear has got two possible values, that is clogs and sandals. So if you take the clogs values, so we go to the footwear attribute and see wherever there is a clog. So here we have clogs, so that is T1. Then here we have clogs, that is T5. And here also we have clogs, that is T8. So T1, T5, T8, all these training samples have value clogs for the footwear attribute. So they come to the left branch. And the remaining attributes, that is T2, T3, T4, T6, and T7, they have value sandals for the footwear attribute. So they come to the right branch. So this is how the training sample gets split based on the values of the attributes. In this case, it is clogs and sandals for the footwear. Okay, now in this T1, T5, T8, they are essentially students. So there is no need to divide this branch further, because once you come to this branch, we know the label of that particular sample. So that is basically students. But here it is a mixture. So here we need to split the decision tree. So again, which attribute to take? So we need to, since there are only two attributes left now, so we see the info gain for the each attribute, which is info gain ratio for the each attribute, which is 0.6377, and for the habit it is 0.0202, 0.0208. So which attribute we pick? We pick the eats attribute to split. So eats has possible value as baked, fried, and roasted. So the training sample, which is T2, T2, T3, T4, T6, and T7, that gets splitted as follows. So we get T3, T6 for the baked value, then the T4, T7 for the frieds, and T2 for the roasted. Now at this point, it is student, so there is no need to split that attribute because all those training samples are belong to student. In this case, it is professor, and in this case, it is professor. Okay, so this is how we construct the decision tree, and then given an unknown sample, we just fall through the decision tree based on the output values, and when we come to the leaf node, whatever is the decision at that leaf node, we infer that for that particular sample. So this is how the inferring happens. Yeah, so this was a short discussion on the decision trees. So you can create decision trees using Gini index, and you can create decision trees using the entropy based methods. In that, we can use the information gain, or we can use the info gain ratio to build the decision trees and do the interpretations. I hope people are following me. I'm just going on and on. I cannot see any hand raising because it is the whole screen is occupied by the slides. Okay, so we'll continue further. We'll discuss the ensemble classified methods. So ensemble methods, basically, instead of using one classifier, you use many of them. And the reason for that is the accuracy. So essentially, we want to increase the accuracy. So the accuracy got by using one classifier would be lesser than using many of them together. So that is the basic hypothesis using ensemble methods. So we combine predictions of multiple classifiers, and the motivation for that is we reduce the variance and reduce the bias. So these are the two concepts which you should be familiar. What is bias? So bias is basically overall error for the training samples. So if you train a machine learning algorithm to learn those samples, and then after that we find the error for the training samples. So overall error for the training samples is the bias. So it should be so your machine learning algorithm should be good so that it gives less error for the training samples. And that is the aim of the learning. Variance is basically the error got for samples in the training in the testing set or the validation set. So we should also have low variance. That is for the unknown samples. For the new samples, the trained machine learning algorithm should give less error. So that is a variance. So ideally, we should have less bias and less variance, which is not the case, because if you have less bias, then what happens is the training samples are learned by heart by the machine learning algorithm. So that is a disadvantage. So we say that, if it learns by heart, then we say that, or it usually means that we have overfitted the data. So overfitting has a disadvantage because overfitting would lead to less prediction or more prediction errors. So for the newer samples, it may not, the trained network may not, the trained model may not predict well. So we should have very crisp training. That is, we should stop at a place where there is a reasonable good error, bias error for the training samples, and reasonably good error for the new samples that it predicts. So that is how the machine learning works. So there is a validation set where you stop at appropriate place, where you don't overtrain the model. So these are some of the methods by which you need to fiddle with in order to do the training. So again, this bias and variance concepts have been explained on StatQuest. So he explains it very nicely. So the methods for ensemble classification is bagging and boosting. So bagging is as shown in the schematic. So we create many classifiers using a subset of the training set, and we use those classifiers, multiple classifiers, to do the prediction or classification. So we take a vote of those classifiers, n classifiers. Boosting is basically a linear combination of the classifiers, where the subsequent classifier attempts to reduce the error of the previous classifiers. So it is a linear combination of the many such classifiers with some weights. So we give weights to different classifiers, and some classifiers would have more say in the decision, and some would have lesser say, based on how much errors it basically gives for prediction or the classification errors. So again, I'll repeat, bagging is about creating many classifiers and taking the majority vote, and boosting is taking the linear combination of different classifiers. So this is what the ensemble classification is about. So bagging is, I think so I'll explain it with the diagram. So we have these n samples, and we bootstrap the n sample. That means we pick up one sample and put it in class S1, and we put back the samples in that bag. So we pick up n such samples, always putting back the sample that has been picked. Okay, I'll just repeat again. So we pick up one sample, put it in S1, and put that sample in the bag. Then we pick up the second sample, put it in S1. So now S1 will have two samples, and put that sample again S1, put the sample in the bag. But in that process, we would have picked two samples, although those two samples would have been put in the bag again. So that is what is called as bootstrapping. That is picking up the samples by replacing them again in the bag. Why we replace them in the bag? So that we have complete set of samples from which we can pick the remaining samples. So we create a subset S1 from the complete training set. Similarly, we create a subset S2 from the complete training set, and S3 and so on. And for subset S1, we create a decision tree. For then for S2, we create a decision tree. For subset S3, we create a decision tree. And we use this n decision trees to do the classification. So this is schematic. Okay, I'll just do it again. I'll explain it later on. So once we do that, then we use this n decision trees to perform the classification. And how that is done? So given an unknown sample, decision tree C1 would classify that into some class. Decision tree C2 would classify into some other class or same class, and so on. So all the n decision trees would classify the unknown sample in some classes, and we take the majority class. That is, what is the majority class which has been given by the n training samples, and then we say that that particular sample belongs to that particular class. That is a majority class. So that's how the bagging works. So bagging with random forest is we take the complete training set, we take a subset of that, and while building a tree at each node, we don't take all the features. We take a subset of these features to build the decision tree. So for example, if there are n features, we take a small subset m to decide which feature to use. So instead of using all set of features, we use a subset of features to build a decision tree. Again, that is using by Gini index or using the info gain or info gain ratio. Okay, so algorithm is something like this. Given a training set S, for build a subset Si by sampling with replacement, that is use a bootstrap. So this is, for example, as shown here. So we have one bootstrap here, another bootstrap, and third bootstrap. And at each node, we choose the best fit from random subset of F features instead of using all the features. So each tree grows to the largest extent with no pruning. And then once we do that, once we create the decision trees, we will take the majority decision to get the overall decision. So that's how the random forest works. Boosting, as I said, it is a linear combination of the classifiers. So if we have HTX, where T is the classifier index, as a weak classifier, we combined a lot of weak classifiers to build a strong classifier. So for example, AdaBoost is one which is used in the face detection. So whatever boxing that you see in your image in the camera, in your mobile cameras, or in your full-fledged cameras that the DSLRs or compact cameras. So that algorithm basically is the one which is proposed by Boyle and Jones in 2001, so which is a popular algorithm. So that algorithm works by order boosting. So here, what we do is we have these rectangles. So we have these rectangles which are exactly divided into two halves. So one half is consists of black pixels, the other half consists of white pixels. So we subtract the values. So we overlay these rectangles over an image and sum the pixels in the black rectangles and sum the pixels in the white rectangles. That is image pixels, which basically overlay under the black area portion and which overlay the under the white portion. And then we take a difference of that, and that is the feature. So we have many such rectangles and we create many such features, and based on the features we classify whether a particular region belongs to face region or it doesn't belong to a face region. So we have this classifiers. So it can certainly say that particular region underlying a rectangle is non-face, or if it is a face, then it can say with some certainty but not with 100% certainty. So if it says that okay, it is a face, then that that region is passed to the another classifier. That classifier would certainly say that it is non-face if it is really non-face. But if it is a face, likely face, then it would say yeah, it is it is likely to be a face. So the likelihood of a face is basically that decision is passed to many classifiers. But if the face is if the underlying region is not face, then that is certainly concluded by any of the classifiers. So we do that, and finally n classifiers would classify the face as certainly a face and basically non-face. So that's how we classify the faces, the face regions, and we collect many such face regions and form different bounding boxes, and then we found a overall bounding boxes to enclose that particular face. So that's how the boosting algorithm works. So the most popular one, let me see the time now, it is 12 o'clock. Okay, so I am officially supposed to go till 12:15. So since I started half an hour late, so I will basically discount 15 minutes. So I'll take 15 minutes less for each lecture.
Yeah.
So is it okay?
No.
Is it okay if I go till 12:30?
I think not an issue.
Okay.
No problem, sir.
I will try to finish, by 1:45, maximum 2 o'clock.
Yeah.
So 1:45 is the official time in which I am supposed to finish both the lectures. So I'll take 15 minutes extra in that case. Is it okay? So 2 o'clock I'll finish positively.
Yes, sir. Are we giving some 5 minute or 10 minutes break?
Yeah, after
Yes, sir. You can
after this lecture.
take 15 minutes, I
After
think,
this
and then
session.
we'll take a break.
After this session.
We will have a break.
So
yes.
I will go till 12:30 this session, and then or maybe 12:20. Yeah, 12:20. I think we'll fix 12:20, and then I'll give a 10 minutes break, and then we'll start the next session at 12:30. Okay.
Yes, sir. Yes.
Yeah. So 12:20 I'll go, and whatever I'll cover, I'll just cover, and then I'll just leave the remaining as it is. Okay.
Yes.
So gradient boosting with an example. So this is a very popular algorithm which people use. So gradient boosting and edge boost. So these are the algorithms which people currently use. So let us go through this. I mean conceptually. So I think so. I can just discuss this, and I think so I need to stop probably after this. Okay. So the aim is to train a model using 3 input features and output features. So here again we have this input features as height, favorite color, gender of the person. And the output is the weight. So based on the height, the favorite color, I mean, it may not be related to the weight, of course, but anyway, for example's sake, it has been given here, and the gender. So based on that, based on 3 features, we find out what could be the possible weight of that particular person. Okay. So how do you do that? I mean, we start with an initial tree, which is a single node with an initial guess. Okay, I'll repeat the problem. The problem is given these features, the problem is to predict the possible weight of that particular person. But for that, we need to create a decision tree based on the training samples, and these are the training samples which have been given. Again, this is from the StatQuest. Okay, so from the training samples, the initial guess is we take the average of all the weights, which is 71.2. Okay, and then so this is the average weight, and we can say that given any new sample, the average weight is 71.2, so the probable weight is 71.12. So we can do that and stop there. But then we want to be bit more better, bit more accurate. So what the gradient boosting does is it will calculate a residual tree. So it will attempt to reduce the residuals, that is the difference between the actual output and the predicted values. So here the predicted value is 71.2 for all the samples. So we see the difference between what is predicted and what is observed. So now we take the difference, that is 88 minus 71.2 for the first sample. So the actual weight is 88 and the predicted weight is 71.2 by this node here. So we are starting just with one node, that is one tree. We're having just one node, and the predicted weight for by that tree is 71.2. So now we construct a new tree with using the input features and the residuals. So essentially we are trying to predict the residuals using the decision tree, that is the second decision tree, which could be strange, but that's what the gradient boosting is about. So we calculate the residuals first. So for the first sample it is 16.8. For the second sample it is 76 minus 71.2, it is 4.28. For the third sample is minus 15.2, is 56 minus 71.2, and so on. Okay, and then we generate a decision tree. And how we do that? Using Gini index or using the entropy based methods. So we create a decision tree, which is as shown here. Now what this decision tree shows is the first attribute is gender. The split is on the gender first, and then when we take the left branch, the split is by the height. So height less than 1.6. So we have seen how we split using the numerical values. And then on the left branch, the split is using the color. So color not blue. So it is, so left branch is always yes and right branch is always no. Okay, so what we get, gender is F. So we take all the F patterns here, and height is less than 1.6. So we take all the F, that is all the patterns which have gender as F and whose height is less than 1.6. So what are the training samples here? It is 1.5 and so that is 1. So this is the last row is the training sample, which basically satisfies this criteria. So what is the residual there? It is minus 14.2. Then there is another residual which maps to the same node, which is minus 15.2. So okay, if we go through this, so the height is less than 1.6, then it is female, so gender is F. So we go through this, and the residual there is minus 15.2. So we have two residuals which map to that particular node. In this right branch here, we have just one, that is 4.8. Okay, then similarly for color not blue, that is S, we have two of them, which two training samples which map there, and on the right hand side we have one training sample. So the leaves are the weights, which is what we wish to predict. Okay. Okay, so now since there are two of them, so we take average of that and put the average there. So now for an unknown sample, if you fall to this node, so what would be the possible weight that would be predicted? It would be what would be the possible residual that would be predicted? It would be minus 14.7. And for this, the possible residual that would be predicted would be 4.8. So that's how we build the decision trees. Okay, now how do you predict? I mean, how do you predict for this? For example, you want to predict the weight for this particular sample. So it is what the starting prediction, which is 71.2 plus some weight, and the residual predicted by the decision tree that we have just formed, which is this. So we make this pattern fall through this decision tree. So it goes, so gender is basically M here, so it will go through the N branch, that is right branch. Then color is blue, so it will go to N branch here, so it is 16.8. So what is the weight now? It will be 71.2, that is the initial weight, plus the weight for this decision tree, it is 0.1, that is actually the learning rate, into the residual that has been predicted by this decision tree, which is 16.8. So what the predicted weight is 72.9, which is better than 71.2. So what have we achieved by this is we have done a better job at prediction of the possible weight. The possible weight is 88, but the one which you have predicted is 72.9. So it is a small step in the right direction. So this person, that is Jerome Friedman, or the one who invented gradient boosting. So according to him, we should take small steps in the right direction. And this, so we have taken the first step. So again, with these two trees, that is this plus this, we predict the weights, and then we predict the residuals. So for the first sample, it is 88 minus the predicted weight, which is now 71.2 plus the learning rate into the residual, which is so what we get is some weight, and then we subtract that. So 88 minus whatever weight gets predicted by that by the two decision trees. So we have new residuals, and then which are smaller than the earlier ones, as you can see here. So what we do is we again construct another decision tree in order to reduce this residuals. So using this new residuals, we construct another decision tree, which is as shown here. So again, we have two samples mapping to the node. So we take an average of that, and the final decision tree is this. This is for the new residuals. Okay. So now how do we calculate the weight for this? So starting with the root node, that is 71.2 into the weight as declared by the first tree, modified by the parameter, the learning parameter. Then again here we use the same learning parameter, that is 0.1, and we use the second decision tree to calculate the average weight. Okay, so here now if you use these trees, it will be 71.2 plus 0.1 into 16.8. Then we use the values of this basically sample to fall through this decision tree and come to the leaf. So here the leaf is 15.1. So we take 15.1 and multiply that by 0.1, and the predicted weight is 74.4, which is another step closer to the observed weight 88. Okay, and we continue this. So we take the average weight and we use the first decision tree, second decision tree, third decision tree, and so on. So we use n number of decision trees to calculate the actual weight, and that is how the boosting works. So I'll summarize again. Each decision tree, the motivation is to reduce the errors between the observed, in this case observed weight, and the predicted weight. And the subsequent decision trees basically reduce the weight got from the previous trees. So whatever weights are predicted by the previous tree, they reduce that particular weight. And the overall, so all the trees together, they predict the weight for an unknown sample. So for example, if we have an unknown sample here, so we fall it through the decision trees, that is based on the attribute values, that is height, Faraday color, and gender. So we take the first decision tree, go to the leaf, take the second decision tree, go to its leaf and pick up that value, go to the nth decision tree and pick up the leaf. And then we pick up these values and do the predict the possible weight. So that's how the gradient boosting works. Okay, I hope that is clear. So I have 10 more minutes, so I'll go to the Bayesian classifier. So now, since I have less time, so I won't. I'll just go through the concept. I'll just give the conceptual view. So Bayesian classification, basically it estimates the probabilities of occurrence of different attribute values for different classes in a training set. So given a training set, it finds the probabilities of occurrence of those attribute values for different classes, and based on these probabilities, it will classify test or recall patterns. So there is some terminology here. So if A bar represents the array of attribute values, that is A1, A2, AM. So for example, in the tennis playing case, A bar could be the weather attribute, and A1, A2, AM could be sunny, overcast, and rainy. So those are the three attributes for that particular, three values of the attributes for that particular attribute. Okay, so P of A bar, that is the probability of occurrence of A bar regardless to which class it belongs. P of CK is the known as prior probability, that is occurrence of class CK. So given a training set, we can find this probability. This is a posterior probability which we are required to find. So given an attribute value, what is the probability of it belonging to class CK? And this is what exactly we are trying to find. So that is a posterior probability, and probability of A bar given CK. So given class CK, what is the probability of that attribute belonging to that particular class? That is called the conditional probability. So how do we classify a pattern A bar? So we assign to the class most probable for class A bar. So we essentially try to maximize this. So we find the maximum class for which P of CK given A, given attribute, is the maximum, and that's what is the Bayesian classifier. So there is a Bayes probability theorem which correlates this probability on the left hand side with the expression on the right hand side. So essentially, because P of A is constant, so we can ignore that. Essentially, we are trying to maximize the expression on the left hand side, which is defined in terms of the expression on the right hand side. Now we can actually calculate these values given a training set, but it requires large number of training samples. So essentially, what naive Bayes does is it will assume that the attributes are class conditionally independent. So then this expression will turn out to be something like this. That is, P of A bar CK will turn out to be just product of P of AI given CK. So AIs are nothing but the actual attribute values, and we can calculate the probability using the training samples. So we use this in place of this, and finally what we get is the naive Bayes classifier, where to classify a pattern, we calculate this expression here for each and every class and pick up that class which gives the maximum value for that particular expression. Okay, and so how do we calculate the probability? So there are two methods. One is likelihood method, which is maximum likelihood method, which is given by this. So we, amongst the class CK patterns, we find those patterns which have value Vj for attribute AI. So we just count only those, and then so that is the probability. There is another estimation, that is Bayesian estimation, where so in this case there is a probability that we will get zero values, which is disadvantage in some cases. So in Bayesian estimation we always get a probability which is greater than zero. So in this case what we do is to calculate the probability of class CK, we add 1 to that, and this M is the total number of classes at the denominator. So we do this to get the probability for CK, and so here this expression is changed. So for it is just one addition of 1 here, and at the denominator we add M. So this will ensure that the probability is never 0. Then this probability is basically again for this we add 1 here, and at the denominator we add In, which is number of possible values for the attribute AI. Okay, so let's take an example. Hopefully I can take this. So again we have this professor example. So we calculate the probability of each attribute, so P of professor. So using this particular expression, so we find out how many samples belong to class professor. So how many of them are there? 1, 2, and 3 of them are there. And so this number is 3. Add 1 to that, and the total number of classes is 2. So we add so 8 plus 2 it will be 10, and 3 plus 1 it will be 4. So 4 upon 10, that is a P of professor. So we are using the Bayesian estimation. And then let's take one example. So probability of eats is equal to roasted given student. So now given student, how many patterns are there of students? So 1, 2, 3, and 4 of them. Now in that we find eats is equal to roasted. So we go to the eats attribute and see in how many samples it has value roasted, in how many student samples it has value roasted. Now eats has 3 possible attributes. So In is basically 3 here. So out of 5 student patterns, none has eats is equal to roasted. Okay. So probability of eats is equal to roasted given student is 0 plus 1. Okay. And this IN, the possible number of attribute values is 3. And the total number of student samples is 5. So it will be 0 plus 1 upon 3 plus 5. So that's how you, the probability is calculated. So the probability for the others is similarly calculated. Okay. So once we calculate these probabilities to classify pattern R3, which is this, that is Gabi roasted clogs. So to which class does it belong to, a student or professor? So we calculate this probability, that is probability of professor, so which is this expression here, that is P of Ck into the value of the attribute, all possible values of the attribute and given class Ck. Okay, so all possible values of the attribute, that is P of habit, taking value of Gabi given professor, then P of eats is equal to roasted here. So you just, what is the, so eats is equal to roasted, so we find out that probability. And then footwear is equal to clogs given professor. Sorry, not all possible values. It is basically the observed values for those attributes. So it is basically, so P of habit is equal to Gabi, because the in this it is Gabi, the habit has value Gabi here. For each it is roasted, so we find the probability using this table that we have just calculated, given professor. And then footwear is equal to clogs, so we find, so using this footwear is equal to clogs given professor, we find that probability and put those values and get some value there. Similarly, this is for one class. So for other class, so P of students, so again we go here and it is 6 by 10 here. And then P of habit is equal to Gabi given student. So again we, habit is equal to Gabi given student, it is 4 by 7. And similarly P of probability of eats is equal to roasted given student, and so on. So we get this probability as here. Since this value obtained for student is more than the one which is obtained for professor, so the recall pattern R3 is classified as student. So that's how the naive-Bayes works. So we are almost through now. Yeah, so the performance of naive-Bayes. So naive-Bayes performs least miscalculations in comparison to any other classifier. However, in practical sense, it doesn't do well because the training samples are not adequate and the probabilities that we calculate are not correct. So hence we do not get quite correct results in practical life. And also there is an assumption that the attributes are class conditionally independent, which may not be true. Okay, so the probabilities may not be correct and they may not be conditionally independent. That's why the naive classifier doesn't perform as well in practice, but otherwise it should perform better than any other classifier, because we are classifying the patterns in two classes in which it is most probable likely to be. Okay, so I'll stop here. I wanted to discuss SCM, but I think I'll stop here. Yeah, so we'll take a break and come back. Yeah, any questions?
Any questions from anyone? You all can put your camera on and ask questions, or you all can put it in the chat box.
Yeah, if we don't have any question as of now, we will take the question at the end of the session.
Okay, fine. So when we meet 12:30 positively?
Yes, sir, we'll all take a 15 minutes break and then we'll all join for the second session on deep learning and its application by Dr. Sanjay Kadam, sir. Thank you, everyone. Please join again.
We will join at 12:30, right, Nuren?
12:30, is it okay?
12:35.
Yes, 12:30, sir.
Yeah,
12:35.
Okay.
Is it okay?
12:35, okay.
12:35, yes, please.
Okay, fine. Okay.
Thank you very much.
Okay, okay.
Sir, can we start with the session?
Hello.
Yes, sir.
Hello. Can you see the slides?
Yes, sir.
Yes, sir. Yes, sir.
Yeah. Is my voice okay? I mean, am I audible?
Yes, sir.
Okay.
Yes, sir, you are audible.
Okay. Yeah. So in the next session, I would be covering deep learning and its applications. So I'll carry on this session till 12:55, so that 5 minutes we have question answers session. So by positively 2 o'clock, I'll complete the session. Since actually I'm supposed to do it by 1:45, but as I said, there's a 15 minutes delay. So 2 o'clock, is it okay?
Yes, sir.
2 o'clock I'll complete, so that 2 to 2:30 you still have half an hour for lunch break.
So it's absolutely fine, sir. Not an issue.
Okay, fine. Yeah. Yeah. So in this session, so I'll be introducing the neural computing. So since it is quite an old field, although this deep neural network is top of the town currently. But so we'll talk about some concepts in neural computing and the working of backpropagation algorithm, which is used in the deep learning. Then I'll cover the deep learning. So we'll cover CNN in bit detail. I mean, I hope that is okay. And then I'll give a conceptual overview of how the region-based convolutional neural networks work. I mean, so in that we have a better version called fast RCNN of RCNN, which does things better, faster in a faster way. Then we have even a faster version of that is called as faster RCNN, and we have mask RCNN, which segments the objects. Then I'll be giving a conceptual overview of generative adversarial networks, which are again popular these days, and some applications in astronomy, bioinformatics, and image processing. And question answers for 5 minutes. This session will be 1 hour 20 minutes exactly. Okay, so this slide I flash before starting. So there are three things which, as a human beings, we can do. So one is the recognition of some objects, and that we do by learning through examples. That is learning by examples. So learning by examples is an expression you should remember, because this is what the neural networks or deep learning is about. So whatever problems we wish to solve, we need to create examples of that particular problem. So if it is in OCR, so we need to create different handwritten characters to train the machine learning. If it is recognition of objects, we need to basically create samples of those objects by which we can train the network. So learning by example is one which we learn since our childhood. Then we can classify the object as fruit, even though we have not seen that specific fruit earlier. So this ability is called generalization. So we can generalize whatever we have learned, and then we can do the classification. And finally, even if some data is missing, we can still do things. So we can classify a half-cut apple as apple, or if there is a face of some celebrity, I mean, partial face of some celebrity, we can still recognize that. So although we have some data missing, we can still perform the task. So recognition, classification, and doing things even when the data is missing. So these are the three things which the neural networks are good at. So they learn by examples, they generalize from specific to the abstract, and they can handle noisy data. So they can do tasks even when incomplete or noisy. Okay, so essentially there are three broad categories in which the ANNs work. That is pattern mapping. They can map pattern from one class to another class, pattern classification or recognition, and pattern completion. So there are three general things which the networks do. Okay, now there are two sets of diagrams. So in the left hand side, what you see is the biological network. That is, there is a cartoon of the biological network where we see a lot of neurons. So neurons are nothing but cells in the human brain. So we see a lot of neurons here, biological neurons here, where there is a cell body and there is one long extension of that cell body. So the cell body is such that it has some extensions which are called as dendrites. So the cell typically receives signals from other cells through these extensions called as dendrites. Then it will combine those signals and it will produce an output signal which will pass through this long extension called as axon. And at the end of axon we have again dendrites which are connected to the dendrites of the other neurons. So that's how the biological neural network works. So if you prick a pin on a hand, then the body responds, and the way it responds is the signal would be transferred to the brain neurons, and from there the signal gets transmitted to all other neurons through the axon of the neurons and through the dendrites. So that's how the information flows. In the same diagram, we have what is called as artificial neural network, which is where the shaded circles represent the artificial, the biological neurons, and the lines that you see, they represent the axons or the connections between the neurons. And these are usually divided into layers. So we have input set of neurons, artificial neurons. Then we have then the next layer of neurons, and so on. And finally we have the output set of neurons. So at the input set of neurons, we apply the input to the neural network, and at the output set of neurons, we read the output produced by the network. So I'll repeat again, we have what is called as an input layer through which we feed the input to the network, and we have an output layer through which we read the output produced by the network. In between the input and output, we have what is called as hidden layers, which are not directly connected to the outside world. Okay. So this is the schematic of an artificial neural network where we have the input layer neurons, and as you can see that there is an input pattern or features that we feed to the neurons. So each neuron would take one value of some feature. There is a value of some feature. So if there are n features, you would have n neurons in the input layer. Similarly, output basically neurons represent the class categories. So each neuron would basically give output if that particular pattern belongs to that particular class. So for example, if there are three classes here, so the first neuron will fire for class 1. So that means it will output 1 for pattern belonging to class 1, whereas the other two neurons would output 0. So 1, 0, 0 represents class 1. 0, 1, 0, that is when the middle neuron fires, that is it outputs 1, and the remaining other two neurons output 0. Then we say that the pattern belongs to class 2. And similarly, the pattern would belong to class 3 when the third neuron would output 1, whereas the remaining two neurons would output 0 for that particular feature or for that particular pattern of that particular class. Okay, so that's how the input and output processing happens in a typical neural network. Okay, so as I said, there is a comparison between real and the artificial. So this is a real neuron which has, this is a cartoon of the real neuron which has basically a cell body, and there are these extensions which are called as dendrites, which receive inputs from large number of neurons, other neurons. Then there is this, so the signals come from other neurons at this cell body, and there is this synapse which is called as, which has some strength, which is called as synaptic strength. So what is the synapse? It is basically connection. So it is basically some entity so basically connection between dendrite of one neuron and dendrite of other neuron. So it has some strength. So that synapse would either strengthen the incoming signal or it would weaken the incoming signal. So that is the role of the synapse, and that is modeled by what is called as connection weight. Okay, so now we collect inputs from other neurons modified by the synapse, and we produce an output. That is, the cell would produce an output. That output goes through the axon, and the axon has again dendrites which get connected to the other neurons through the synapse again. So again you see a synapse here. So this is how the biological neural network neuron behaves. So it will get some inputs. So it will use those inputs to produce an output that goes to the that goes as input to the other neurons, and this goes on and on. So that's how the signal gets transmitted. Okay, so we have a artificial counterpart where the inputs are basically x1, x2, xn, which are the inputs which may come from the outside world or from the other neurons. Then the synapse that we have, that is modeled as weight. So each input, that is x1, would be influenced by w1. So if w1 is positive, then that signal would contribute towards the overall output of that neuron. If the weight is negative, that is, weight is nothing but some numerical value. If it is negative, then that particular signal would basically reduce the overall output of that neuron, whatever the neuron produces. Okay, so this acts like a synaptic strength. So the connections that you see are nothing but the dendrites, the modeling of the dendrites with the synapse. So there are three things that happen before an output is produced. One is the sum function, which is nothing but the dot product between the inputs and the corresponding weights or the synaptic strengths. So we have x1 into w1, x2 into w2, xm into wn, and there is a bias term which is added. So what is the role of the bias term? It is basically only when the input, that is summation, is above some threshold, then only the neuron will produce an output. Otherwise, it won't produce any output. It will produce zero output. So this bias term is added for that. So if the output is greater than theta, then only the network will produce some output. If it is less than theta, then it won't produce any output. So you add theta to that, and you check I for it being greater than 0. So always you check if it is greater than 0 instead of checking for some theta, because theta is variable. So we always check if it is greater than 0. If it is greater than 0, then the neuron will fire. If it is less than 0, then the neuron won't fire. That is, if I is greater than 0, the neuron fires. If it is less than 0, it doesn't fire. Okay, so that is a bias whose input is always 1, the x naught is always 1, and the connection is theta, which changes as we do the training. Then whatever I we get, whatever dot product we form, then we apply an activation function or transfer function. So that is, we have f of I and we get value t. And then t is in turn modified by what is called as output function, which is usually the identity function. So most of the neurons do not have the output function, but some neurons do have the output function. So we take y of t, and that is the final output produced by that neuron for the inputs, and that output goes as input to the other neurons. So this is how the working of the artificial neuron does. Okay, so now there are different forms of sum functions, different forms of activation functions, different forms of output functions. So let's see some of them. So the one which we have seen is simple dot product, that is dot product of the inputs and the corresponding weights, which is given by this particular expression here. Okay, but you can also take the product of the inputs and the corresponding weights, that is xi, wi, and take a max of that. So that is called the maximum sum function, a maximum function, or you can take a min of that. So you can take simply pairwise dot product, that is like x1 w1, x2 w2, and xn wn, and take the minimum of that, and that is the value of I. So we have different sum functions, but the most popular is this, that is a simple summation, which is nothing but the dot product of the inputs and the corresponding weights. Okay, now terminology. So these are what is called as incoming connection weights, that is incoming signals, that is the inputs which are received by this neuron from the other neurons, and these are the outgoing. This is the outgoing signal. That is the outputs which are transferred to the other neurons. Okay, for activation functions, again we have different functions, like we have threshold logic. So X here is the sum. So if the sum is greater than 0, we produce, the output produced by the neuron is 1. If the sum value is 0, the output produced by the neuron is 0. If the sum value is less than 0, then the output produced by the neuron is -1. So this is discrete. We have continuous function as well. So where the value produced by the neuron lies between 0 and 1. So, and the expression is given by by sigmoid function, that is 1 upon 1 plus exponential minus ax. A is learning parameter and x is the sum function, value of the sum function. So this is a graph of that. So as sum tends to infinity, the value is limited to just 1. And as sum tends to minus infinity, the value is limited to 0. So the value lies between 0 and 1. So this activation function, they act as squashing functions. So they limit the output produced by the neuron in the range -1 to 1 or 0 to 1. So that is because we don't want the output of the neuron to grow very large. Otherwise, then we'll get we'll get some error in the computer, because we cannot have large values in computer, because then we'll have buffer overflows. So we always limit the value of the neurons. Then we have what is called as a rectifier transfer function, whose value is equal to whatever is the input value, that is 0 or x. So f of x is equal to max of 0 of x. So it is similar to linear function, except that the value is always positive, because this 0, max of 0 is 0. I mean, if x is negative, then the value is 0. If x is large positive, then the value is same as that. So that is the ReLU unit. And finally, we have what is called as softmax, which will give the probability of a pattern belonging to some class. So we'll get the probabilities of the classes rather than the actual value of the transfer function. So as you can see here, if ij is a sum value at this neuron, then E of ij, so E of ij divided by summation of E of ik over all the neurons in the output layer. So this basically gives the value between 0 and 1 and probabilities of each neuron giving an output in a particular class. Okay, so that is softmax. Okay, one example. So here, for example, the input values are x1 is -1, x2 is 1, and your x3, which is the bias, is always 1. And your weights are -1, 2, and 1 here. So -1 into 1, then 1 into 2, and 1 into 1. So that is a summation. So value is 4. So that's how you form a dot product to get the sum value. I hope that is clear. Then neuron output function, as I said, most of the neuron output function is direct. I mean, there is no specific output function. So whatever output is produced by the transfer function is the output produced by the particular neuron. So in that case, we say that the output function is identity function, that is f of x is equal to x. So that is so in this case, the output function is y of t is equal to t. There is no output function. So we say that it's a direct. Then we can also have one highest, two highest. So what we do is in the output layer, we pick up neurons with largest transfer values. So we can pick up one of them or we can two of them. Two neurons which have got larger transfer values, and we call them as winners. So only those neurons would produce some output. Rest of the neurons would become inactive, or their output is initialized to 0. So that is what is called as one highest or two highest. One minimum is same as we take the smallest transfer value and only that neuron will fire or produce an output. Rest of the neurons become inactive or they won't produce any output. One active highest, two active highest is neurons with largest positive transfer value are the winners, and the remaining neurons become inactive. So these are some of the variations of the output values. But for us, it is the direct output. So activation, whatever value is produced by the activation function is the value produced by the neuron. So this is the softmax function which I discussed earlier. So as you can see that we take the net zero, which is nothing but the dot product between the inputs and the weights, and we get different i's, that is some function which are shown here. And then we take the softmax of that, which is as here, that is e raised to I j upon summation of all ij's across this, and we get y naught, yn, yn to yn. So that is a softmax function. Learning rules. So these are nothing but mathematical expressions to change the connection weights in response to the training pattern. So connection weights are nothing but the synaptic strength. So I'll go back. So if you see this network, so these are the neurons, and the connection between these neurons are characterized by what is called as connection weights, which basically model the synaptic strength. So these connection weights get changed when you train the network. So the method to train this connection weights is what is called as learning rule. And there are different learning rules. So one is a Hebron rule, delta, Wittrup, least mean squares learning rule, Cohen learning rule. So Hebb's learning rule is given a connection weight, so it is always between two neurons. So if those two neurons for a connection, if those neurons have the same state, that is, both have positive output values or both have negative output values, then we strengthen that connection weight, that is, we increase the connection weight. But if they have different states, so that is, one neuron has positive output value, whereas the other neuron has negative output value, then we decrease the connection weight. In the delta case or least mean squares case, weights are changed to reduce the delta, that is the difference between the desired output and the actual output of the neuron. So here essentially it minimizes the mean square error of the network for the training samples. So that is the main intention of this weight change. In Cohen's rule, only one neuron with the largest output is declared as winner, and only that neuron and its neighboring neuron update the connection weights, and the other neurons basically do nothing. I mean, their connection weights are retained. So in the Cohen's learning rule, essentially what we do is we cluster the data, that is, we cluster the data into different classes, and for each class there will be one neuron whose weights represent the centroid of that particular cluster. So eventually, as we train the network, we would have, if there are n classes, we would have n neurons, which are called as winner neurons, which would fire for the patterns for that class. So if one pattern belongs to one class, so only one neuron in the output layer would fire, and the weights of that neuron represent the cluster of that particular cluster center of that particular pattern. So that's how the Cohen learning law works. So the most common is the back propagation training algorithm. So here the idea is to find the weights that minimize the total network error for the training samples. So whatever training samples we feed, so it will reduce the errors for those training samples in a least square sense. And this involves repeated application of two passes, that is forward pass, where we apply an sample, input sample, and we compute the outputs of each and every neuron. And using the outputs, we compare the output produced by the neurons in the output layer with the desired outputs. And if there is an error, we use that error to update the connection weights. And we do that using backpropagation. So starting from the output layer, we go backwards to the input layer. Forward pass is going from the input layer towards the output layer via the hidden layers, and backward pass is going from, it is doing the opposite, going from the output layer backwards. So this forward pass is shown by these green arrows. So we go from the input layer and calculate the output of each and every neuron for some sample, for some training sample, and backward pass is shown by these black arrows, dashed arrows. So we go from the output layer towards the input layer, and we keep updating the connection weights as we proceed towards the input layer. Okay, so it is a mean square error that is optimized for the n training samples. So formally, let's define the training samples. So we have, if you have p of them, where we have xk, yk is one training sample pair, where xk is the inputs and yk is the desired outputs. Xk itself is has m components, that is x1k. So the first indice, that is subscript is the component which the pattern has, and the superscript, that is K, denotes the sample pair. So kth training sample pair. So for the kth training sample pair, we have x1k as the first component, xmk as the m component of the feature vector. So we have m features for the kth training sample. Similarly, y1k is the desired output for x1k. Sorry, desired output for the first component, and ynk is the desired output for the n component. So we have n component outputs. So as I said, if there are three classes, then your yk could be having just three components, that is 100 for class 1, 010 for class 2, and 001 for class 3. So we have three neurons. We will have three neurons for three classes, and each class would be encoded in a different fashion. So that is the y case. Okay, now what is an error? So if you see the jth neuron in the output layer, so yjk minus out jk. So for the kth pattern, the network produces out jk for the jth neuron, whereas the expected value is yjk. That is what is expected. So difference between that is the error. That is the error between what is expected and what is expected for the jth neuron and kth pattern. Okay, in the output layer. Now we sum these errors across all the neurons in the output layer. So this is what is happening here. So we get the overall error for the kth pattern. So I'll repeat again. We apply the kth pattern and we calculate the outputs for the kth pattern, and then we compare the value produced by the network and the desired values. So jk's are the values produced by the network, and yjk's are the desired values. So we take the difference of that, square that, and take a summation of that. So this is the squared error for the kth pattern between what the network produces and what is actually desired. And for how many components? N such components, because there are n neurons in the output layer. So this is ek is the error for the kth neuron. And now we have p patterns. So for the p patterns, we calculate the ek errors. So E1, E2, E3. So we sum that. So E1 to EP. So we sum that for the p patterns and divide by p. So we take an mean error for the training samples, for the p training samples. So this is called as mean squared error, because we are squaring the error. So mean square error, and this is the entity which gets minimized when we train the network, and that is the whole thing about. So I'll repeat again: the mean squared error for the p patterns, which is nothing but the error between the squared error between what the network expects and what the user expects and what the network produces, is the one which gets reduced. Now in this case, what are the variables? The weights are the variables. So our job is to find that combination of the weight which will give minimum MSC for that particular combination of the weight, and the whole task is about that we change the connection weights to get the minimum MSC value. And how you find that? So if you consider this as a function of the weights, so essentially we are trying to find the minimum value of the function. And what is the way out? So there is what is called as a gradient descent method. So given a function f of x, if you want to find the minima of that function, so there is a gradient descent method is one way to do that. So for example, the minima is at x naught. So if you evaluate the function at x here, so f of x, so here the slope is positive. What it means that we are away from the minima. That means if you take the f dash of x, okay, if it is positive, then what we should do is, what it means is f increases as x increases. So we should decrease x. So we should decrease the value of the independent variable in order to come to x naught. Similarly, if slope is negative, that is f dash, that is derivative of f. So here f is our MSC. So if it is less than 0, what it means that f decreases as x increases. So we should increase x. And if it is 0, then we do not do anything because we do not change x because we are at the minimum. So this is how we change x. Either we increase it or decrease it so that we come to x naught. Now in our case, the x naughts are nothing but the x values are nothing but the weights. So we should find that weight combination. Either we increase the weights or decrease the weights in order to come to that configuration which gives the minimum value for the MSC, and that's what it is the training about. And that decrement is by delta x, which is given by dot neta del f by del x. So we decrement or increment the weight by this quantity so that we come to the global minimum. Okay, so your weights get changed. So your new weight becomes WGI. New is old weight plus delta WGI, where delta WGI is minus theta del E, where E is the nothing but the mean square error. So del E is this del F by del X, similar to del F by del X. So del E with respect to del WGI. So the weight change is always this is with respect to the derivative is always with respect to some independent variable. Here, because there are many independent variables, so we take the partial derivative with respect to WGIS, where the WGI is the weight. Okay, so this is the formal summary of the delta rule. So if you want to change the connection weights for the output neurons, there is some terminology here. So this is a neuron, and these are the outgoing connection weights, that is the connections through which the neuron output would be communicated to, and these are the incoming connection weights, that is the connections through which the neuron gets the inputs. Okay, so how do you update the outgoing connection weights at jth neuron? So it is by this entity here. So neta, then the error term and value of the neuron at the source. So for this connection, that is WJI, YJ is the source neuron output, AI is the YJ is the destination neuron output, and AI is the source neuron output for YJI. And how do you change the connection weight? Neta is the learning parameter. So we take f dash, which is nothing but the derivative of the activation function at this particular neuron. We evaluate f dash at YJ, that is the output at the destination neuron, and we find the error between what is expected and what is produced by the network at this particular neuron. So f dash of YJ into the error. So that becomes the error term, which is delta J, that is communicated to the previous layer with respect to the output layer. Okay, so neta, error term, and the source neuron output, that is AI. So this is the entity by which we update the connection weight, delta WJ. And what about VIJ? That is the connection between a hidden layer and previous hidden layer or the input layer. So how do you do that? Again, it is the same thing, neta, f dash of AI. So for this connection, AI is the destination neuron output, XH is the source neuron output. So we take f dash of AI. So we take the activation function at ith neuron, we take f dash of that AI into the error term and into XH, same as AI. So for this connection, XH is the output of the neuron at the source, okay, which is XH. And then this basically this f dash of AI and this entity here is the delta I for the next or previous, for the subsequent layer, not subsequent, the previous layer. Okay, now here what was the error term? It was just for the output neurons, it was just what is produced and what is expected. It's just the difference of that. But in this case, the error is calculated in the following way. So we take all the outgoing connection weights and we take the error term at first neuron, that is delta 1, multiply by W1I Then we take the error term, that is delta j at the jth neuron multiplied by wji. We take the error term at delta nth neuron, that is delta n multiplied by wni, and we take summation of that, and that is the error at this particular neuron. So at this neuron, error is simply a difference, but at this neuron it is the product of deltas and the corresponding outgoing connection weights. So that is the only difference. Otherwise, the expressions are similar. Okay, and then we continue this process. So this is how the delta rule works. Okay, so that was a short introduction to concepts in neural network. I'm at 13:10. So okay. Okay, now so I'll just repeat it. I'll just go through the slides. Can you see the changing of the slides? Yes or no? Hello? Can you see the slides changed?
Yes, we can see.
Okay, fine. Yeah, so what have I explained is the back propagation rule, the forward pass, backward pass, and what gets optimized, that is a mean square error gets optimized, and the way to do that is a gradient descent method, and the weight updation rule is the back propagation method, and this is precisely how the weights get updated. Now let's come to the deep learning. So whatever we discussed was about the shallow networks and how the networks how the shallow networks work. So what the deep learning is about, so what can we do with the data? So given images, we can label them. So we can say that this is a scene, or this is a dog and a cat and so on. Given audio, we can do the speech recognition. Given text, we can do the web search on that. So this is what you can do with the data. And how the current AI methods, that is deep learning methods, differ from the older algorithms. So the red line that you see is the performance. So x-axis is the amount of data. So as you go towards your right, you get large data. You have large data, and y-axis is the performance. So for the older algorithms, as the data increases, their performance tends to saturate. I mean, so beyond when the data is increased, you don't get scalable performance or the desired performance. But for the newer AI models, with the increase in data, their performance also increases. Or we say that the new AI methods are good for large amount of data, whereas the older algorithms are not. So they don't give as much performance as desired. But for small amount of data, the older algorithms are still relevant. I mean, you can still use SVM, you can still use the conventional machine learning algorithms. But for large data, yes, you have to use the newer methods. Okay, so deep learning is nothing but instead of having 2 or 3 layers, that was the convention 3 decades back for the neural network, we have many such layers. So many, what is many? I mean, that is again related term. Many is typically 10 layers, 20 layers, and so on. So that is many, or more than 4 or more than 5. So even more than 4 could also be considered as a deep network. So more layers or deep number of layers means a deep neural network. So again, we have the input layer neurons, the output layer neurons, and hidden layers. So we have many hidden layers for the deep neuron. So this is the slide which gives a feel of the traditional method of training a network, training a machine learning, and the deep learning method of doing that. Just for I'll take a break for 1 minute. Sorry for the interruption. Yeah, so deep learning basically it aims at learning feature hierarchies directly from the data. So in the conventional method of machine learning, so what we do is we extract the features first. So for example, if it is images or videos, so we use methods like HOG, that is histogram of gradients, SIFT, LBP, that is linear binary patterns, to extract the features from the data. Once we do that, then we apply a trainable classifier, which could be SVM or which could be bagging, boosting, or whatever algorithms we have discussed till now. And then we get the object class. But in deep learning, we simply feed the raw data, that is images or videos or any other data. And that data passes through different layers. And each layer would would perform or would derive the features from the data. So in the image context, because I work in image processing, so in the imaging context, so image is nothing but set of pixel values. There is a rectangular array of pixel values, where each pixel value has range from 0 to 255. So 0 is black pixel and 255 is a bright pixel. And for grayscale, it is just one band, I mean just one two-dimensional array. But if it's a color image, that is RGB values, so we have three such arrays. So if it is a 5 by 5 image, so for RGB image, we will have 3 5 by 5 arrays of the pixel values. And as I said, each pixel value has just value from 0 to 255. Okay, so when you supply an image here, the first layer would basically extract the edges from the image. The second layer would combine these edges to form object parts. And the subsequent layers would have more and more abstraction of that input data, and the final layer that we would have would be an abstraction of object models. Like for example, it is faces here, so the final layer would basically be in a position to classify different faces. So starting with different face images, we can basically feed those face images to the deep neural networks, and they themselves would get the features and perform the recognition or classification of the face values. So that is how the deep neural network differ from the conventional machine learning algorithms. So I'll repeat again. Deep learning is about extracting the features as well as performing the recognition or a classification task. So there is no need for explicit feature extraction as such. So now there are different types of deep learning architectures. So some are unsupervised and some are supervised. So in unsupervised category, we have autoencoders, we have deep belief networks. So they are unsupervised training of restricted Boltzmann machine to detect features, and we have, so in this we have component to detect features, and then supervised component to which uses a backpropagation algorithm to do the to detect the objects. Then we have commonly, which is quite common now, generative adversarial networks called GANs. So it is called generator discriminator. So these are nowadays used to replicate things. So you can replicate novels, you can replicate paintings of famous personalities, you can replicate news, you can create fake news as well, and so on. So you can create fake photos, fake news, fake novels, fake poetry, and so on. So this is what the GANs do. Then the convolutional networks, which are typically used for image processing. So they can handle image data well, but they can also be used in other applications. Then we have recursive, recurrent or recursive nets, which can handle text processing. So they're good for natural language processing. So they can form patterns in that from the text. Okay, so as I said, we'll discuss the CNN in detail, and the remaining is just conceptual overview. So CNN, as the name indicates, it is a convolutional neural network. So it involves convolutions. So if you have heard the term convolution, so it is basically if you have a signal and then if you convolve that signal with another sub-signal, so what you get is some resultant signal. And the convolution is used in image processing to basically detect edges in the object, or to sharpen an image, to smoothen an image, and so on. So images, most of you, although you may not be doing the field or may not be familiar with the field, but images you deal every day. So on the internet, there are so many images, you download images and so on. So do a lot of things with the images. You can sharpen them, smoothen them, you can brighten the images, and so on. So all these operations typically are done using convolution. So it involves convolution, and it comprises input layer, the feature extraction layers, and the classification layer. So here we have this image here, and then we feed this image to the input layer. So all the pixels, raw pixels, go there, and then we do a lot of convolutions and pooling, and finally the final we have the full connected layer here, and we get the binary classification. So for example, this image could be classified into different categories, like say bird. If it is a sunset image, it would be classified as a sunset. If it is an image of a dog, then it would be classified as a dog, and so on. So this is how the convolution operation. So as I said, it involves convolutions. So how the convolution operation works? So if you have this input data, and there is a so this is a signal, the large signal. Then there is this kernel which moves over the input data. So what we do is we place the kernel at some position and multiply the values in the input data by the kernel coefficients, and whatever value you get, that is the result of convolution. So for example, we place the square here as shown here, and then we multiply this 1 into 1, then 0 into 0 as shown here, and the resultant value is 4. So this is a result of convolution at this particular position, and then we move this at different locations and we get different values. So for example, this diagram that I have shown here, so the kernel is at this place, then we move it one column towards the right, then we form, so the value of the pixel that gets formed is at the center of the is the one which is depicted at the center of the kernel. So we find the resultant value of this particular data point for that particular kernel position in the beneath the data. So we get the value of convolution value of this point, then this point, and this, and so on. Then we move the kernel one row below, and then do the same thing. And that's how the convolution basically works. So given this original data, 6 by 6 input data with zero padding, so we add one row up top and bottom, and one column towards left and right by zeros, and we move the kernel so that the center of the kernel lies at each and every data point, like say at 18, 54, 51, and so on. And we get the resultant output, which is again 6 by 6. So we get same output as the size of the original data, which is 6 by 6. Why? Because we have padded that with the zeros, the 0 rows and 0 columns. But otherwise, we get a reduced sized output because the kernel cannot move at all possible positions in the image. So this is what is the convolution, and the output that you're getting is this. So as I said, convolution.
Sir, your voice is not audible here. Dr. Sanjay Kadam, sir, we can't hear you. Bhushan, are you there? Bhushan?
हाँ सर नहीं आ रही है आवाज संजय सर
तो उनसे कांटेक्ट हाँ शायद नेटवर्क टूट गया होगा
या नेटवर्क इशू लग रहा है
Dr. Sanjay Kadam, sir, we can't hear you. Bhushan, are you there? Is someone contacting Dr. Sanjay Kadam? I tried to calling him, but it is busy. His phone is busy.
सर who was the coordinator? I mean संजय कदम से कोई बात कर रहा होगा?
I am only coordinating, but his phone is busy. I thought someone else is talking now.
No, 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 we are not talking.
Yeah, let us wait. Within a 2 minutes, he will join.
Okay, sir, we are here.
Guys, sir has lost his network at other end. So just give us 2 to 3 minutes. We'll just reconnect with sir and again continue with our session. Within 2 to 3 minutes, we'll just ask sir to rejoin
Okay,
and we'll start.
okay,
Okay, fine.
Hello. Hello.
Yes, sir.
Can you see the slides and can you hear me?
Yes, sir. Yes, sir. It is visible.
Okay. Since when it was disconnected? Since which slide? This one?
Sir, just go further.
Hmm?
Sir, it was that convolution operator 2D filter.
Okay.
This one. Next one, sir.
Okay. Yeah. This one?
No, sir. That 2D filter, which is written.
This one.
Yes, this one. Yes.
सर हाँ ये एक और पीछे लीजिए one more back. हाँ ये हो गया था CNN next. हाँ बस यहाँ पे थे सर आप जैसा you have started this one.
Okay, fine. Yeah, so convolution is you have input data, then you have some kernel, and then you have convolved features.
Yeah, this
and you move the kernel over the input data at all possible positions.
I mean, from here.
At all possible positions, and we get the resultant value. For example, we have placed this kernel at this particular position. Can you hear me? Hello? Hello?
Yeah, sir. Yes.
Yeah. So we have placed this kernel at this particular position, and then we do this multiplication of the coefficients of the kernel by the input data values, which is shown here. That is 1 into 1 is equal to 1, 0 into 0 is equal to 0, and so on. And the resultant value, just add all those together and we get 4. So that is the convolution of the input data with the kernel placed at this particular position as shown here. So then now we move the kernel, say one column at a time towards the right. And for example, as shown here, so the kernel was here, and then we moved one column towards the right, which is here. So we form the convolution at this particular position of the mouse, and then we form the convolution at this particular position of the mouse, and so on. So we move across all the columns till we come to this position, and we can go no further because otherwise we would fall off the input data. And then similarly, we go down, so we go down one row and do the same thing. Go down one row and then start moving towards the right, one column at a time. And that's how we convolve. So convolution always produces lesser volume. So for example, here we have 6 by 6 input data, and if you don't pad by zeros, the output volume produced will be 5 by 5 because you cannot move beyond the first row, last row, first column, and the last column. So you always have one less column based on after that is based on the kernel size. So if the kernel size is 5 by 5, then the output produced will be 4 by 4. I mean, it will be lesser than that. Okay, so the output size is always lesser than the input image size, input data size. But if you want to maintain the size, then we zero pad the input data by rows and columns, and we get the same output as the size of the input data. So zero padding basically does the trick. So here convolution with here it is the convolution with 2D filter where the data was 2-dimensional, kernel also was 2-dimensional. We can do the same thing with 3D filters or 3D data. So we have a volume of data which is nothing but it represents the output of the neurons, or it represents the neuron volumes. So we have H by W by D set of neurons. Actually, it is a set of outputs produced by those neurons, and we have this kernel which is nothing but the connection bit, and so we move this 3D filter at all possible positions in this volume, and we get the output volume. Now the size of the input volume and the output volume is related by this expression here, that is Wy is equal to Wx minus F. F is the kernel size, and P is the size of the zero padding, and S is the stride. So if you move one column or one row at a time, or you can also move 2 columns at a time. So you can just jump to 2 columns or 3 columns. So that is a stride. So stride could be 1, 2, 3 or whatever. So depending on the size of the stride, so this size is influenced. So your W by is this, and H by also is this. You don't have to bother about these equations. I mean, you can just go follow this. So if it is 7 by 7 input volume, so we would get 5 by 5 output volume with 3 by 3 kernel. That is K is equal to 1 and stride is equal to 1 and P is equal to 0 without zero padding. Okay, so this is an example. So now This is a convolution layer. So what happens is that this again, as I said, 32 by 32 by 3. It is basically an input volume which represents the outputs of the neurons in some layer. Now, and we have filter 5 by 5 by 3 filter, which is nothing but the connection weights of some neuron. So here, this is a neuron in the subsequent layer to this. So we have 32 by 32 by 3 layers of neurons in this. That is 32 by 32 by 3. So that so depth is 3. So then this neuron in the subsequent layer is connected to only a subset of neurons here. And what is the subset? It is dictated by the position of the filter. So at whatever position the filter lies in this volume, only those neurons are connected to this particular neuron. And when we form a dot product between the outputs of neurons in this layer and this particular neuron, it is nothing but finding the dot product of the outputs dictated by the position of this particular filter and the coefficients of that particular filter. Here, as you see, the coefficients are 1, 0, 1, and so on. Here, the coefficients are 3 dimensions. So you have they have certain values. So you multiply the outputs. That is, you multiply the outputs of the neurons by the outer volume and the coefficients of the kernel, and whatever output you get, that becomes the output of these neurons in the neuron, one single neuron in the subsequent layer. Okay, and then when you move this kernel to some other position, so that would basically dictate the connection weights of some other neuron in the output layer. Okay, so different positions will be dictate different connection weights of some neuron in the subsequent layer. So when we move this kernel across different positions, what we get is an activation map. Same thing as here, we get this output, which is nothing but 28 by 28 by 1. That is why 1, because we just get there is just one neuron for one kernel. Okay, so we get one activation map. So for a volume of 32 by 32 by 3 neurons and 5 by 5 by 3 filter, we get an activation map which represents 28 by 28 neurons. Okay, for another filter we would get another activation maps. So for n number of filters we would get n activation maps. Okay, so this is the, so for example here there are 6 kernels and we would get 6 activation maps. So for this input volume or for this layer, that is 32 by 32 by 3 neuron layer, we would get 28 by 28 by 6 neuron layer. So these are the 2 subsequent layers in a convolution network, and so the output is produced by the kernels, by applying the kernels. So are you getting it? So that is the convolution layer. So we use different filters for the convolution layer. Now what happens is that when we train a network, it is very slow, because if there are a lot of connections, then it takes a lot of time to train that. So we reduce the layer, that is using pooling. But before that, so feature learning in convolution layers. So what happens is that so this as I said, the features get automatically extracted by the deep neural networks. So this is low layer features in some layer. This could be the mid layer features in some layer. Features are nothing but the output of the corresponding neurons in that particular layer. So these are the mid level features, then high level features, and so on. So this is how the abstraction of the features gets generated in the deep neural network. Okay, then the pooling layer is one which is used to make the representations smaller and smaller, or smaller and more manageable. So what the pooling layer does is, given a size, given a 3D volume of neurons, it will reduce that volume by using pooling. So let's take the 2-dimensional case. So for example, we have this 4 by 4 set of neurons, or volume of neurons, 4 by 4 by 1. Then each two, so what we do is we take 2 by 2 sections. So here we take, for example, here there's a reddish section here. We take 2 by 2, and then we take the maximum value in that. So maximum value is 6. So we just form single neuron for this 4 neurons here, and that similar neuron would have a 6 value. Similarly, we take 2 by 2 neurons here in the previous, in some layer, and we take the max of that, and the max is 8, and that we assign a neuron whose output value is 8. So what we have achieved is we have 16 neurons in some layer, and we have reduced that volume of neurons to just 2 by 2. So we have just 4 neurons in the subsequent layer. So we have reduced the volume of the neurons. And why we do that? Because we want to reduce the computations involved. Because if you keep convolving and if you keep getting large and large volumes, it is difficult to control that. It is difficult to basically do the training in a given time frame. So we reduce the volume, and so that things are manageable. So we add a pooling layer to the convolution network. So the convolution network typically consists of the convolution layer as well as the pooling layer. And the techniques for pooling is max pooling. You can as well perform average pooling. You can take the average of all these neurons and outputs of the neurons and assign a neuron with the average. So there are a lot of ways to do that. So pooling is nothing but downsampling. So we downsample some array into a smaller array. Okay, so that essentially explains the ingredients of the convolution neural network. So we have pooling, we have the convolution, followed by pooling, then we have convolution, followed by pooling, and so on. So we have many such convolution pooling layers in a typical convolution layer, which is as shown here. Okay, so this is an example, LeNet is an example of CNN, which is used for character recognition. So here it has different convolution layers and different subsampling layers or pooling layers, and all it does is recognize a handwritten character. So there is a live demo at this site, so you can go through the site and see the live demo. So you can just feed image of some character and it will give the class of that character. Okay, evolution of convolution networks. So the convolution networks actually it started by neocognitive network by Fukushima, that is 1980. Then we had LeNet by these authors. So it uses gradient-based learning applied to documentation recognition. And then we have AlexNet, which is popularly used. So it is used in ImageNet classification with deep convolution neural networks. So there is this ILSVRC competition, that is ImageNet Large Scale Visual Recognition Challenge. So here the task is you label an image, that is given an image of a cat. You should say that it is an image of a cat, or you should say that it is a cat. Given an image of a dog, your network should say that it is a cat. It is a cat. Cat, dog. So whatever category image you have, you should correctly label that. Now there is what is called as file label prediction. That means you predict file labels, top file labels, and at least one label should be correct in that. Then you say that it is correctly predicted. Or correctly predicted the label for that image. So that is called as 1 in 5 accuracy. So this ImageNet classification, that was a challenge in 2012, and people were told to develop their own deep convolutional neural networks to get the best performance. So ImageNet, so there was this, in 2014, there was this VGGNet proposed by this, and its error was 11.2%. That means its accuracy was quite good compared to human beings. Compared to the actual accuracy, and that was top 5 error. Okay, so that means it used to predict at least one label correct amongst the top 5 labels it predicted for any image. Then there was this GoogleNet in 2014. And it entered this competition, and its accuracy was 6.7 for top 5 error. Then the ResNet in 2015 it gave an accuracy of 3.6. Okay, so so this is basically the characteristics of CNNs. So over the years, we had more and more complicated networks, that is having more large number of layers. They perform 5 times slower, but they are more accurate, but 3 times more accurate. The accuracy was more. So now GoogleNet in 2014 had 16 convolution layers. This is VGGNet in 2014. Sorry, the VGNet in 2014 had 16 convolution layers. GoogleNet also had 16 of them. No, 50 of them. Then the latest one, that is ResNet 50, it had 50 of them. And ResNet 152, it had 152. It has 152 convolution layers. Okay, so how deep is enough? It depends on how much accuracy you want and how much time you can spare for it to get trained. So how do you go? How do you enter this field? So there are different different deep learning libraries that are available that you can use. So there is CuraNet, there is KEF, then Torch 7 for MATLAB, then Theano, and then there are scripting. There are TensorFlow based libraries. There is a Python library as well. So PyTorch is one library that you can use to create your deep neural networks and train them and test them. But otherwise, TensorFlow is the one which you should go, because that is so that is basically a library where you can create a network layer by layer and train it and test it. Keras is built over the TensorFlow, because TensorFlow may be a bit complicated to some. So they have built library functions over the TensorFlow, and so popularly many people use Keras. So Keras, TensorFlow are the two popular libraries, but currently PyTorch is the one which you can use. So that is basically a library of functions which will allow you to create deep neural networks. Okay, then there is Veka as well, and finally there is this Django Python-based library for deep learning in genomics. Okay, now this is a slide which is basically I just put to give a feel about how to do it in MATLAB. So you can create define a layer in MATLAB, and you can train you can create a CNN layer in MATLAB and you can train it. So for example, here layers is equal to image input layer. So image input layer, it comprises 28 by 28 by 1 neuron in the input image. In the first layer, there's input layer, and the input image also is of the same size. So the input layer has the same size as the data size. And then we have the next layer as a convolution layer, which is basically it uses filter size as 5 by 5, and there are 20 filters. Then we have ReLU layer, which is a activation layer, activation function that this layer uses. Then we have max pooling layer, which defines max pooling. So it defines the first pooling is a max pooling size, that is the first argument, and second is the stride, by how much you want to jump. So 2 by 2 array would be max pooled. 2 by 2 will be converted to 1, and stride is 2, so it will jump 2 columns or 2 rows. Then there is a fully connected layer having 10 layers neurons. There is a softmax layer, which is the activation function, and finally there is a classification layer. So this is how you define a layer. And for example, this is a code for digit recognition, MATLAB code for digit recognition. So I'll skip this now for want of time. So you can go through this. So this code basically creates a network. So define a network, specify the training option, train the network, and test the network using the test label, and see the accuracy, which is 0.98 for the digits. And this is a Python code, Python and Keras code. So you get the corresponding libraries, load the data, flatten the image into 6784 vector, then create the training data, normalize the input data, encode the data, and then define the baseline model, compile the model, then fit the model, and evaluate the model. So that's how we do in Keras and Python. Again, there are a lot of blogs which will explain you in detail how to use this code. This actually is from the blog which is given here. So there are a lot of blogs which will help you to learn Keras, learn TensorFlow, and so on. Applications of CNN. So they find applications in a lot of things like object detection. So given an image, they will detect different objects and label them. So for example, dog, label with just certainty. So how certain they are, how certain the model is with respect to labeling. So this point here is 0.99. That means 0.99 is the probability of it being a dog. And so they also give the category of the class, the object and its certainty. So object detection, segmentation, then classification. This is that challenge that I have mentioned. Semantic segmentation, and then text detection and retrieval. Image captioning. So, for example, here you detect different objects and apply some natural language processing to get some meaningful sentence in that. For example, two young girls playing with Lego toys. So we can caption that particular image using NLP and the object detection. Or here it is man in black shirt playing guitar. So you can caption that image. Okay, and then face recognition, which is very popular now and which is very well established. Pose estimation, coloring some image, like there's a grayscale image, you can color that. Other applications include translation, and we can translate one language from one to another, handwriting generation, text generation, and so on. Okay, this is an application which we had done to categorize the boats. So we had 15 categories of boats. So we had done this in SEDAC, and these are the results of that particular application. So we have 225 test images and training images, test images were 100. So it could label the boards as well as recognize them. And this is the accuracy that we got. Then these are some of the applications in astronomy. So galaxy morphology is basically to classify the shape of the galaxy. So for example, there is a Hubble sequence classification scheme where you can classify the galaxies as elliptical, spiral, and lenticular. So you can use deep neural networks to classify the galaxies. And it won a Kaggle competition. So there was this competition to classify the galaxy, and it won that competition. And it closely matches human performance. There are other applications in astronomy is basically using use of deep ANNs to classify supernova, or you use GANs to generate fake galaxy images, and for image reconstruction. These are the applications in genomics, so you can understand protein binding sites. So you can classify certain sites as binding, or the ones which can bind. So this is used for precision medicine or detecting binding sites and so on. Epigenetic modifications, you can find out like methylation. So if some cell is infected with methyl atom, like some methyl cell goes and gets attached there, then you can detect that, and so that is used for to check whether a person would suffer from cancer. So if a tumor suppressing gene is methylated, if some methyl gene is attached to it, then that person could suffer from cancer because it cannot suppress the tumor. So you can study this using the DNA sequences. So you can do perform taxonomic classification. You can do the amplification rate classification. Sorry, I'm going very fast. So these are the networks which people have used for prediction in this. Okay, then region-based segmentation. So now I won't discuss this. I'll just skip this. Okay, we have used RCNN for ship detection. So you detect the ships as well as segment them. So we use that. This is not our result because I cannot show you our result because it is confidential. But we have used that. And GANs, basically, there are two components. Okay, I'm almost there now. So there are two components in GAN. One is the discriminator and the generator. So what the generator does is it will generate some fake things. Like for example, if you want to generate fake face images, so it will generate fake images, and the discriminator will check whether it is a real or fake. So if the discriminator network cannot differentiate between the fake and the real, then whatever fake has been generated is almost as good as real. So the discriminator will attempt to catch the generator, and the generator would attempt to create a fake image which is quite real. So they work in unison, and so they try their best to do the things. So this is the celebrity database, the real images, the generator using the noise, it would create fake images. The discriminator would compare these two images, and if there is a lot of difference in that, then you would have discriminator loss, and if there is not much difference, then this loss will be less. Similarly, if the generator would generate a lot of loss if there's a lot of difference between the fake and the real image. And based on this loss, you perform the training. So you perform the discriminated training and the generated training. And this is a loss function for that. So applications are you can use GANs for creating super resolution image. So we have this blurred image and where the details are not very clear, but you can use GANs to make the details very clear, as you can see in this image. Then you can use GANs to translate one image from one collection to another, like translate zebras to horses and horses to zebras, or translate a mono to photo to a painting. So this is the input image, and these are the images generated by GAN by different artists like Monet, Van Gogh, then Cezanne, and so on. So it will generate different images by different as though they are images generated by or created by different artists. Then this is paintings to photos, photos to paintings. This is what the GAN does. Yeah, I'll stop here. Sorry, I just keep the slide in between. I got disconnected, so I lost some time there as well. Yeah, so these are the references for ML, ANL, and DL. So the black ones are for the ML, that is machine learning. This third book, that is the pattern recognition, it gives the basic algorithms for machine learning. And the first two I have not gone through, but they are supposed to be more popular on the internet. Then this is for the neural network, convolutional neural network. So Bishop's book is the one which is used as a standard textbook for the neural network. And Satish Kumar's book also is used as a textbook. And Buddha is popular pattern classification book, book on pattern classification. So these three are conventional books, and the remaining are e-books which you can download from the internet. The third category is basically the books on for deep learning. So there is this book from MIT Press. There is this book on the mining, which is the latest one, and then this is again deep learning with PyTorch, which is again the latest one. So you can refer to these books to do the needful. Okay, so I'll stop here. I'm at 2 o'clock, so I can dedicate 5 minutes for any doubts if you have. There are no messages that I can see. So if you want to ask any message, ask any query, you can do so for the next 5 minutes.
Bhushan, any questions in the box?
So I lost connection in between, so I lost some time there as well.
Yes, sir, just checking out in both the sites, on YouTube Live and on our chat box, just checking for the questions.
Okay.
Sir, meanwhile, I want to ask one thing. Javed Khan here.
Yes.
Sir, you have wonderfully explained machine learning, deep learning, and number of applications also you have elaborated. Sir, on behalf of the student, I would like to know, apart from this algorithm theory, on what tool these MCA or MBA student they should focus for their in current scenario.
Current scenario, PyTorch. PyTorch is very popular. Otherwise, Keras, that is for deep learning. And for machine learning, it could be R, Veka, and MATLAB also is okay. MATLAB is good for machine learning as well as deep learning. But to be professional, for machine learning, R and Veka should be good enough. Conventional machine learning and deep learning would be supported in that. And for deep learning, it should be PyTorch and Keras. And TensorFlow, of course.
For deep learning, Python, you said, right?
PyTorch. It is a library for deep learning.
Okay.
PyTorch. It is a Python library. So PyTorch in Python.
Python.
And Keras.
Okay, okay, sir.
And if you want to go a bit low level, then TensorFlow.
TensorFlow. Okay.
Yes.
Yes.
And yes.
So these TensorFlow are libraries from Python, right, sir?
No, you can actually, they're not from Python. Actually, you can use TensorFlow in Python to create a network. So it is just like C and C++. I mean, it's just like C, I mean, like assembly language. It is a bit more tough to create a network and so on. So they have built a library over that Python, over TensorFlow, that is Keras. So Keras is a library built over TensorFlow, which is more easy to use. So you can use that library to begin with. But PyTorch also is another set of library which you can use in Python to create a network. Okay, so I think so I'm confusing you. So starting from highest level, it could be PyTorch or Keras. Going to lower level, it could be TensorFlow.
Oh, okay, sir. Okay. So, sir, thank you very much for your wonderful session. Bhushan, over to you. Are there any questions from the student or faculty member or PhD scholars?
Checking the same, sir. Just a moment. No, sir. No questions as of
Okay.
now. The chat box. So, sir. Yes. Noreen.
Okay. So since we have no questions, I would like to request Ms. Sania Khan to extend gratitude to Dr. Sanjay Kadam, sir.
Thank you, Nurin. I express my gratitude to Dr. Sanjay Kadam for enlightening our students and participants on machine learning and overview and deep learning and its application. I also thank Sir for sparing his valuable time and being the part of this two-day national e-conference on data mining and ICT NCDM 2021. I'm sure your ideas and thoughts will go a long way in developing us as IT and management professionals. Thank you, sir.
Yeah, thank you. Thank you very much.
Sir, thank you very much. Thank you once again, sir.
Okay, thank you very much. Bye.
Yes.
So now, ladies and gentlemen, we will be breaking for a sumptuous lunch, and let us all assemble back for a very interesting third session at 2:30 p.m. And our eminent speaker will be Dr. Ajit More. Thank you, and do join back at 2:30.
Thank you.
Thank you, Noreen.
Thank you very much, sir. Thank you.
Ajit sir?
Yes. Am I audible?
Yes, sir. Is my voice also clear, sir?
Yes, yes.
Okay, sir. So within next 2 minutes, we'll start, sir.
Okay, okay.
Yes, sir. Thank you.
Thank you.
Aisha?
Yes, sir.
Uh, yes, please go ahead. Start.
Yes. Welcome back, everyone, to the third session of this national conference. The topic of this session is classification based on rough set theory, and the honorable speaker for this session is Dr. Ajit More. I now request Ms. Maria Sheikh to introduce our today's guest speaker.
Thank you, Aisha. It's a great pleasure for me to introduce Dr. Ajit More, who is currently associated with Institute of Management and Entrepreneurship Development (MCA) program as in charge director. Sir is also the BOS chairman Computer Applications at Bharatiya Vidyapit deemed University and BOS member at BMCC Pune. Sir has participated as resource person in more than 15 FDPs at various universities. He has also worked as NAC coordinator at IMED Pune. Sir is the secretary of IQAC at IMED and chairman of the research committee. Sir has also completed ModRob research proposal at IMED and submitted one major project at UGC and two major projects at AICTE. Sir has guided 11 PhD students, out of which 8 students are awarded as PhD and 7 as MPhil. Sir has also presented and published papers at 24 national and 10 international conferences. We are honored to have you with us, sir.
Thank you, Maria.
Yeah.
Before going ahead, the instruction for the participants will remain same as they were for the previous sessions earlier. Now, I would like to request Dr. Ajit More sir to start with his session.
Am I audible?
Yes, sir.
Okay. I will be sharing my screen. Okay. Can you see the screen also? Hello?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Okay. Good afternoon, friends. Today I am going to give a talk on rough seats. First, let me congratulate your institute for organizing this wonderful workshop on machine learning and artificial intelligence. The data mining, data warehousing, this particular theme has been taken by your institute and continuously you are organizing such seminar. So this is my privilege to give talk on this particular topic of rough sets, where since morning I have seen the inauguration. After that, we had a lecture by Dr. Sanjay Kadam, and he spoke about the concepts of machine learning and deep learning. And everything is all about the data. And when we talk about data mining, you know that there are major pillars of data mining. They are classification, clustering, and association. Out of that, we are going to talk about one of the classification method called as rough sets. This particular method, along with neural network, genetic algorithm, or all other methods, if it is coupled and a hybrid model is prepared, then that particular model can give better classification accuracy and the results are amazing. So my approach, my role today is to introduce you to the theory of rough sets. Before that, I would like to tell you a few issues which are there in the real world data. When we are collecting the data from various sources and the heterogeneous nature of the data and the sources creates issues in the real world. These are about uh, basically about the data size, and based on that, when we are going to analyze this data, when we want to make some rules, what are the issues occurring are as follows. First, the amount of data is very high, huge amount of data is available. Then mixed type of data is there, that is the data type of every tuple and the columns within that are vary. There is a lot of uncertainty remains in the data. This is the very major issue in data analysis. Incompleteness of the data, maybe because of any reason, data entry or any other reason, the data remains incomplete. Data changes frequently, that also one of the reason. And for any data analysis, if we have the background knowledge of that particular data, we can do better analysis. So these are the issues which real world is facing today. Now, being a computer science student, we are going to study a method or a model which will help us to address these issues. In this world of uncertainty and complexity, ambiguity, can we have a model which will help us to work on small data set, get some results, design and generate some rules, and use these rules to other system as an input, so that if two different systems work together, a comprehensive result will be much better as compared to the individual system. So these are the real world issues. To address this, the rough set theory was introduced by one of the scientists from Poland, Mr. Pawlak, in early 1980s. This theory was introduced, and then at the initial stage, few people started working on that, and over the period, there was not that much attention given to this particular theory, and it was subsided. But after the year 1996, the scientists, people working on this particular field, they realized that there is some potential in this particular theory, and if we use this theory along with some standard algorithms, then this gives better results. So from that point of view, everybody started working on rough set, and then nowadays it became quite popular in this combination of in hybrid systems. It can be with neural network, genetic algorithm, fuzzy set, or any you consider any soft computing technique. Rough set theory can be complementary to all these theories. Now, here the main goal of today's talk is about, and the entire rough set theory is about the concept of approximation. And this theory, rough set, a mathematical based model, constitutes a sound basis for knowledge discovery through databases. It offers a mathematical tool to discover patterns which are hidden in the data. Ultimately, the entire data mining is revolving around the extraction of the unknown patterns from the data. And can we derive this pattern in time, having some meaningful what you can say outcome of that, and can we use this in our day-to-day work? That is the intention of this particular model. Rough set theory can be also used for feature selection. You might be in our previous lecture, you must have discussed the concept of feature selection, feature extraction, then data reduction, decision rule, and pattern extraction. So all these points which are important from data analysis point of view can be addressed by using the rough set theory. So these are the main goals of rough set theory. As I already told you that rough set theory is basically a model which is a mathematical model which is derived from a set theory of mathematics. And it is, if you are aware and know about acquainted about the set theory, then for you rough set theory is very easy to understand. Here, which are the basic concepts we are going to discuss and are important in rough set theory? These are first the information system. We must know what is the information system or decision system. A computer science people, they are acquainted with the concept of table, where number of rows and columns are there. In rough sets, we are calling it as the information system or decision system. Meaning is same. Then within these tuples, there is some type of relationship, and that relationship is called as indiscernibility relationship. What is that indiscernibility relationship that we are going to discuss? How the records and tuples are indiscernible from each other, that we are going to discuss in this. The approximations of these sets, we are going to prepare different sets as per the requirement and as per the techniques in rough set. These sets will be prepared. Then we are going to find out which are the most important attributes from that particular table. As you all are computer science students, you know the word attribute and table and all this. That is why I am using this. But actually in rough set theory, they call it as a information system and reducts. Then the core attributes of the system, then the membership of the system, how that rough membership is existing in the variables, then the dependency of the attributes on one another. And if we know the dependency of attributes on one another, we can modify the information system, or we can modify the table, and we can organize this table in such a way that we use minimum amount of space for the storing of the data. And finally, we can derive the decision rules from the system. These rules can be further given as an input to some system, which will use these rules and make some predictions and do the decisions. So these are the concepts of rough set theory, which we are going to discuss in our today's talk. Now, from this, I'll be showing you some table. Now you see that, I hope all of you can see the screen. The example of rough set theory here, you can see a table with some attributes. Now here, this table we are calling it as the information system. In this information system, there are certain objects. There are 8 objects you can see, x1 to x8. After that, there are some conditional attribute. And finally, the last column is for the decision attribute. Conditional attribute means the attributes which are there to describe the object are called as conditional attribute. While the last attribute is the attribute which is derived based on the values of this conditional attribute. Based on the study of the conditional attribute, we take some decision, we make some opinion. That is the decision attribute. This particular table is explained with the mathematical symbols and equations, where you see that the entire information system is called as a universe, which has tuples in it, x1, x2 till x8. All these tuples are described with conditional attribute. These are q1, q2 and q3. Namely, this data is about the cars. So car has engine, the size of the car, and the color of the car. So these are the three attributes taken over here. Within these attributes, if you see that what values this attribute takes. For example, if you consider engine as an attribute, this engine will have three types of engine: propane engine, diesel engine, and the gasoline engine. Similarly, the car is available in different size. Car may be a compact car, it can be a medium car, or it can be a full size car. Then colors. The car is available in different colors like black, white, red, gold, and silver. So these are the attributes and their values. And finally, we have a decision whether, based on this particular study, based on after studying the size of the car, after studying the type of the engine, after studying the color of the car, we come to some conclusion that whether it is a good car or a bad car. Okay, it is general opinion. It is not nothing like good and bad, but overall opinion about that particular car is mentioned over there. That is good or a bad car. The entire thing, D is a decision variables and C are the condition variables. Have you understood the decision system or the information system? Can anybody respond if by making himself unmute? Because the thing is that I should know whether you are audible, whether I am audible or not.
Yes, sir, you are audible. Yes.
Okay, thank you. So this is the information system which we are going to discuss now. Now, in this, normally when you talk about any information system, there are some issues again. And what are the common issues? What it means is some or undiscernible objects may be represented several times. There may be few objects for which the value is same. When we say that x1 and x2 both are having the same value, it means that the object is repeated. Two different objects are having same value. And it is also possible that there may be certain attributes which may not be required to describe the object, which can be easily removed. And by removing that particular attribute, there will not be much impact on the information which is stored in that particular system. So these are the issues of the information system and how rough set theory can be used to address these issues that we are going to see in our later slides. Now, from the beginning, we are talking about the indiscernibility relationship within the records or within the tuples. What is it? It is basically when two objects are same, exactly having the same value, then we call as they are indiscernible with each other. We cannot separate out these objects from one another based on the values of the attribute. For example, here when we are having x1, x2, x3, like xr, these are the set of objects. In that, there may be certain objects having the same value for all the attributes. Then we cannot separate out. We cannot say x1 is different than x2 because both are having the same value. So when such type of relationship is existing within the records, then we call that these records are having indiscernible relationship with one another. And this is what exactly we are going to discuss throughout our lecture, that how the relationship within the tuples or records is taken into consideration and how the sets are formed, how where different rules are mentioned, and based on different rules, how we are going to prepare the sets. Now let us see our previous example again. This table will come again and again because I am keeping the table over here to understand the concept. Now let us see the indiscernible relationship within the objects. Now let us consider engine. Yes, based on the engine, we will take only one attribute. Engine is the attribute under consideration. Now forget about the size and color. Size, color, and even decision. Don't worry about that. Just concentrate on the object column and the second column, that is engine. Now, based on the type of engine, can we group the objects together having the same value? And when you group them with this, when we group the objects with the same value, we call it as a equivalence classes. So X1, capital X1, capital X2, and capital X3. These are the three classes we have formed. And in the first class, we have only one object, that is X1, because there is only one engine with propane type of value, where there are three engines having value diesel. So X2, X3, X3, X4. These are the three objects having value diesel for engine. And last X5, X6, X7 and X8. These are the objects having value gasoline for the attribute engine. Now by looking at this, we can see that we can easily prepare the equivalence classes, or we have prepared the sets. First set is with one object, second set is with three objects, and the third set is with four objects. And on what basis we have prepared? We have prepared these sets based on the value for the attribute engine. So here in this, we can say that let us consider the second set X2, in which there are three objects, X2, X3 and X4. We can say that X2, X3 and X4 are indiscernible with each other for the attribute engine. That is, when you consider engine as an attribute, then we cannot differentiate between X2, X3 and X4 because all of them are having the same value. Similarly, in set X3, X5, X6, X7 and X8, these objects are having the same value for engine. But in the first set, there is only one object, X1, because there is only one record with propane type of engine. So this way, what we have done, we have specified some criteria. On what criteria I want to prepare the set. I have decided that on the basis of the value of the engine type of attribute, I want to prepare the sets, and I could able to get the three sets. These are called as equivalence classes. So the objects in equivalent classes are having indiscernible relationship with each other. They cannot be separated from each other. Now, if this particular discernible relationship is required again and again in rough set theory, depending upon the criteria, we are going to prepare the set, we are going to change the sets. Now, there are some important concepts like lower approximation, upper approximation, boundary region, and a negative region. Now, to explain this, I'll give one common example. Let us see that we are talking about elections all over the country. And when you are talking about the elections, then there are certain citizens, they will get the right to vote for this particular election. They can exercise their vote. Who are they? All those who are above 18 age are the people, they can exercise this. Between 0 to 18, they are not considered as voters. So they go into the negative region. Even though they are the part of this, they all are citizens of this country, but they don't have right to vote. So they are in negative region. And assume that there are two major parties, Party A and Party B. They are contesting the elections. Normally, it happens that there are followers of Party A and there are followers of Party B. When we are thinking about the elections, the followers, strong believers of A will definitely vote for the Party A, irrespective of the condition, situation at the time of election. They are loyal to the Party A and they will vote for Party A. Similarly, the followers of party B will be loyal to the party B, and they will vote for party B, irrespective of the situation, the agenda, the circumstances, and all these things. They will not do any change in the opinion of the voter. They will be loyal to the party. So loyal voters for party A and party B are there. So these are called as lower approximation. That is, they are certain. Whatever may happen, कुछ भी हो, they will vote for their party. Party A के party A को ही करेंगे, party B के party B को ही करेंगे. लेकिन if there are many people, they are on the boundary. They don't know. They are not deciding in advance to whom they are going to vote. They are on the boundary region. In every election, they are not loyal to any party. This time they may vote to A. Next time they may vote to party B. They all are in boundary region, and these are the people. They are going to decide which party is going to come into power. Now, converting these people on boundary region into lower approximation of the respective party is the agenda of every party. And this boundary region is always changing. It is not fixed, because these people, these voters in this boundary region are not loyal to any party. At the time of election, that day they will decide, okay, today I want this party is better, let us vote for that. In next election, they may change their opinion. It is obvious and it is possible. So these people are on the boundary region. So what we are going to discuss is that we are going to first identify which are the certain people, voters, and then we are going to study which are probable voters for my party. I will concentrate on those people. So I will try to find out, get maximum people into the voters which will vote to me, and that part is called as upper approximation. So upper approximation minus lower approximation. Maximum how many voters will come to me, because I know that the people loyal to party B will definitely not come to me. So they will not come within that upper approximation. But there are people, those who are in boundary region, I will try to take them into the upper approximation. So this way, there are concept of lower approximation, that is, those who are loyal to the party and they are certain. There is another group called as upper approximation. They are probable voters for my party. That group, I will call it as a upper approximation group. And the subtraction of lower approximation from upper approximation, which is a boundary region on which I need to concentrate during my election campaign. Okay, that group is called as a boundary region group. And there are certain group, they are definitely not going to vote me. They are negative region for me. That is age group less than 18. They will not be part of election, even though they are the citizens of the country. Okay, so this is the way this is the example I'm going to use it, and on this basis I'm going to find out the approximations. Let us see that how we can calculate the approximation for our example. Here is the pictorial representation of the approximation. If you see that the innermost square, a blue square, light blue square, is a certain set, that is called as lower approximation, and the yellow square is called as the upper approximation. And within that, we need to find out which are the people. How can we see that the upper approximation and the lower approximation the size will be same, so that I can immediately find out. But in real life, it never happens. There is always a lower approximation, there is always upper approximation, and there is always difference. So this type of situation will remain in real life. Practically, both will not become same. Theoretically, it may be possible, but practically, in real life, it never happens. So this is the pictorial representation of the approximation of states. Then further, I'll explain you with some example, our previous example. Now let us prepare this state, lower approximation, upper approximation, boundary, and negative region with some data. Again, with our example of car data, let us consider that we are concentrating on the, let us see the first object only, engine, and the decision good. These two attributes will be under consideration. Now what I have to see is that I'm interested whether can I make these sets for good engine and bad engine, okay, from the objects available with me. So first thing is first state X1, that is good engines. How many are there? X1, X5 and X6. These are the good engines. These are the good cars based on the engine. Now if I see that X1, X5 and X6 are the good cars, X1 with value engine as propane, there is only one record, so there is nothing to compare because all engines with propane type are good. That is what my conclusion is. But if I go to the second one, that is X5 and X6, these are gasoline. And there are some other gasoline engines also, but they are bad. In my data set, if you see that, there are some other gasoline engines, they are bad. So, while taking the upper approximation, I have to take all the objects of lower approximation plus all the objects where there is ambiguity. So as far as gasoline engine is concerned, the ambiguity is there because just because engine is gasoline, I cannot say it is good or bad, like propane. So I need to consider all the objects of gasoline engine. Therefore, my X1, X5, X6, X7 and X8, that becomes my upper approximation. Now when I subtract lower approximation, that is X1, from the upper approximation, I get boundary. That which is the boundary? X5 here. If you see that this is the boundary, can you see the cursor? Mouse cursor on the screen?
Yes, sir.
Yeah.
Yes, sir, we can see. Yes.
If I subtract the lower approximation from the upper approximation, I get the boundary. That is X5, X6, X7 and X8. These are the four objects. They are ambiguous. We cannot say that whether they are good or bad based on the value of engine, because we can see the table. Gasoline, 2 are good, 2 are bad. So ambiguity is there. They are not certain. They are on the boundary. We want to take decision about that. We want to decide about this particular cars, whether they are good or bad. So this becomes the boundary region. This is the area under consideration. This is the area of our concern, we can say. And finally, which are negative? The entire universe from which the objects which are not under consideration, that is, they are negative. That is, we are going to subtract the upper approximation A bar X from the universe. We will get the negative region, that is X2, X3 and X4, because these are the cars which are bad cars. Okay, which are bad cars and which are certainly bad cars because they are not in our upper approximation. Are you getting this thing? In upper approximation, we are X7, X8. Even though they are bad, we are considering them as a upper approximation because they are having the engine gasoline. And in gasoline, 2 cars are good cars. So there is an ambiguity line. Those who are ambiguous, we have taken already in the upper approximation. So here, universe minus upper approximation is the negative region. So the decision class that is good is rough, since the boundary region is not empty. When the boundary region of the class is not empty, we can say that it is a rough class. It is not 0 and 1. It is not certain. There is ambiguity. As ambiguity is there, it is called as a rough class, or rough set has some role to play in this particular data, with this particular data. So that is what it says, this approximation says. Now this approximation is shown in this particular format, in this figure. X1 is a certain, that is lower approximation. X2, X3, X4 at the top, they are negative region because that is not a good car. But in between, two sets, X1 with one object X1, another set with object X5, X6, X7 and X8. They are of our concern because they are in upper approximation. In upper approximation, all the objects of lower approximation comes plus the ambiguous objects. So this is the pictorial representation of the sets which are available with us. I hope it is clear how these sets are prepared. Now, the next concept is the accuracy of approximation. How will you calculate the accuracy of the approximation? We have certain cardinality, that is, approximation is calculated by cardinality of the lower approximation divided by cardinality of the upper approximation. That means the number of records in lower approximation, okay, divided by number of records in upper approximation. You can see that in lower approximation there is only one record, 1, which will get divided by 5. So definitely, certainly the value which you are going to get is between 0 to 5. 1 divided by 5. The result will be between 0 to 5, 0 to 1. So obviously the cardinality is lying between 0 to 1. And as it is between 0 to 1, we can call it as a rough membership. Okay, it is rough member as respect to the attribute A, that attribute under consideration. If it is exactly 1, then we can call it as crisp, that is clear-cut classification is possible. When clear-cut classification is not possible, then we can call it as a rough membership. And we are going to consider on these ambiguous elements in the data. Now the next concept, as I have discussed with you, is about the redux. What is reduct? As we know that any object is described with certain number of attributes. And while describing the objects in classification, normally what happens, we go on taking the attributes. And afterwards we come to know that these are some trivial attributes which are not required. We can remove them. Even in all of you are the students of computer science, you know that while even in designing the database tables, what we do normalization. In normalization, what we do, the redundant attributes we remove, and the attributes which can be further calculated, which we can calculate by using another attribute, okay, having some dependency, those are also can be eliminated from the table. In normalization, first normal form, second normal form, third normal form, we do all these things. So same thing here, we identify the redux, that is most important attributes from the table. These are called as redux. And these attributes, when you call correct from the table, we call it as a redux. There may be n number of sets of redux. Okay, maybe if we are in our previous diagram, there are 8 objects. First object may contain 3 attributes. Second object may contain 2 attributes. Depending upon the algorithm which you are going to use, these type of objects will be, or redux will be, the number of redux will vary. So calculation of the redux, identification of the redux itself is a very big challenging issue and problem in rough set theory, because this is one of the NP-hard problem. I hope that you are aware about the NP-hard problems in computer science. NP-hard problems are the problems which are very complex and difficult to calculate. Like, for example, calculating the identifying the value of pi. Value of pi 3.14. We are assuming, but it is not exactly value of pi. So likewise, complex problems are there in the universe. These are the problems which are very challenging for computer science, and these problems are called as NP-hard problems in computer science. Okay, now we have calculated redux. From the family of redux, okay, there are certain attributes which will be there in all the redux. that is intersection of all the reducts is called as core. Here I have shown it with the example, with the formula that or equation, that intersection of all reducts is called as core. That is the attribute which is coming in all the reduct, we are calling it as a core attribute. There may be one or two core attributes, or maybe n number of core attributes, depending upon the type, number of reducts, number of occurrences of that particular attribute. Course attributes are identified. That is the most important attribute. Okay. Now, how to calculate it? For that, I will give with another example. Let me just take a break for 1 minute. Yeah. Now, I'll take another example here. See, let's just see the table on the left side with 6 objects. Data is different this time. It is all about the data about the flu, a disease flu, have certain symptoms like a person suffering from flu. He may have headache, he may have muscle pain, he may have temperature, and based on the value of this, we are going to identify, we are going to make a decision that whether he is having flu or not. So certain objects are given to you, U1, U2, U3, U4, U5, U6. These are the objects, and in which 3 condition attributes are there: headache, muscle pain, temperature, and 1 decision attribute, final column, that is flu. Now, we have been provided with the information system on the left hand side. Now, our objective is that we want to remove unnecessary attribute from the information system. I want to see whether there is any redundant attribute is there. I don't want that particular attribute. I want to remove it. But how to remove and how to calculate, with how to confirm that whether it is redundant or not. So we need to calculate the reducts. Calculation of the reduct, as I have told you, is one of the NP hard problem. There are different ways, different algorithms available. Some of the algorithms are called as heuristic algorithm. We are going to see how the heuristic works for that. But before that, if you see on the tables on the right hand side, there are 2 tables. The topmost table here, it says that what I have done, I have removed 1 attribute, that is headache, from this original table, and after removing the headache, I tried to make the groups based on the values, similar values. Then I could get U4 and U1. They are similar when I remove headache, because both are having muscle pain, both are having temperature normal, and both are the patients, they don't have flu. So I have made a set of these 2, U1 and U4. U2 is unique. U2 doesn't have any other record having the same value. While U3 and U6 are same, their value is also same. You can see from the table itself. And U5 is also unique. Now, when I got this right hand side table, I can see that my original table is distorted. In my original table, every object was separate, and I could able to distinguish separately every object. But in this table, the entire table, the originality of the table has been lost. This is not expected. So we cannot say that, from this we can say that I cannot remove headache symptom from my original table, because after removing headache, I got the distorted table, which is not expected. So let us try with another table. In the other table, I have removed muscular pain, the second column from the original table, and I tried to group the records. When I removed the second column, second attribute, muscular pain, I got this table which is at the bottom and which is same as our original table. All objects are distinct, U1 to U6. I can easily separate out, but the new table is similar to my original table. All the equivalence classes are same as my original table. It means that by removing the second attribute, that is muscle pain, my original table doesn't lose any information. So I can easily remove muscle pain. I can say that headache and temperature, this is the reduct I calculated from my table. So these are the important attributes. Headache is important and temperature is important. If I know these two symptoms, I can say whether the person is having flu or not. Okay. So most important attributes I have calculated by this particular way. But see that this table looks simple because we have only 6 objects and we could be able to easily design a new table. But in normal life, in real world, our table size is not small. The number of records are huge. The number of attributes are huge. In that, it is very difficult to find out the readers. So there are certain techniques, there are certain methods which are called as heuristics-based method. I will show you the one of the heuristics-based method that is called as discernibility matrix. See at this matrix. Look at this matrix. From our previous table, I have prepared this matrix in which U1 to U6 rows are there and column heading is also U1 to U6. What I am doing, I am comparing each object with all other objects, including itself. And only difference, if there is different value is there for a particular attribute, then only I am storing that attribute. So U1, when you compare with itself, U1, both are same, so there is no difference. So that cell will be blank here. But when you compare U1 with U2, you see that U1 is compared with U2. Then you see that there is only one attribute different, that is temperature, because U1 is having value normal while U2 is having value higher. These two are having different values for one attribute, that is temperature. And then I will store only that particular attribute T. Likewise, I will compare U1 with U3, U4, U5, U6. I have compared all and then I have put only those attributes name where there is different value. So in this process, I could able to minimize the size of my table. But still, I could able to preserve the information. And by looking at this discernibility matrix, I can say that here only those objects will come, those attributes will come which have more separation power, which are good in, which we can use, which are very important. Only those attributes will come here. Then I have count at the bottom. Headache is coming 10 times in the entire list. If I count H, it will come 10 times. I will count T. T will come 12. That is 12 times T is there. And M is coming only 5 times. So I have to decide a threshold value. I have to decide. I can decide that if out of 12, okay, if 6 times, if the count is 6 and more, then it will be important for me. So looking at this, I can say that temperature is most important thing in flu. Temperature is must. Then second is headache. Person must have headache. That is 10 of the, it is occurring 10 times. While muscular pain is not that much important. So if I know temperature and headache, then I can classify that particular patient whether he is a flu patient or he is not a flu patient. So this way I can identify the patients. I can classify the patients whether they are suffering from flu or not. And here I could get the reduct also, because more than 6 means only 2 attributes are there, T and M, T and H. This is what precisely we have calculated here, headache and temperature. These are the reducts. So this reduct is calculated by using this discernibility matrix. So this discernibility matrix is based on the heuristics. In computer science, heuristics methods are the methods which doesn't have that much proof. Which doesn't have any solid proof, but still they gives the correct result. They are called as heuristic algorithms. So based on that, we could able to identify this. Now finally, what we have to do is that last topic we are moving to last point, that is the decision rules. How we are going to prepare the rules from the table. Again, coming back to our original table, that is our information system, that is cars data. Now look at this. We have two types of car, good car and bad car. That itself makes two different classes, Y1 and Y2. In Y1, there are X1, X5, X6. These are the good cars. In Y2, there are X2, X3, X4, X7, X8. These are the bad cars. These are the two different sets prepared. Good car का एक set हो गया, bad car का another set. Now, let us see that. Consider engine and size. By considering engine and size, let us consider only on two attributes, engine and size. What we see, propane and compact, only one object is there, X1. Then diesel and medium, there are two objects, X2 and X4. Another set is prepared. Now this, which attributes to be taken under, which attributes are under consideration, it is our problem. We have to decide based on the results. Then third one is only one set, X3, diesel type of engine and medium size. Only one record is there. Sorry, diesel type of engine and full size. Only one record is there. Then another set, gasoline and compact. There are two cars, X5 and X8, gasoline and compact. And X6 is alone, X7 is also alone. So likewise, by considering engine and size, we could able to prepare these many sets, 1, 2, 3, 4, 5 and 6. These sets we have prepared. Now from these sets, we can make the rules. From these sets, we can make the rule. Because we know the values of X1, we know the values of each stage. What rule I can make? If engine is propane and size is compact, car is good. Based on this data, I can say that. Okay. Second rule, I can say that if the engine is of diesel type and size is medium, the car is bad car. Because all the records with diesel type of engine and medium size are bad cars. There are these certain rules. If you remember our lower approximation now, this is what we were talking about. These are the certainly engine with propane and size is compact is good based on our data. If the engine is of diesel type and size is medium, it is a bad car based on the data available with us. Always remember that as and when the data goes on adding, as in the size of the table goes on increasing, the rules may vary. That type of precaution always rough set theory takes care. So that way we can derive many other rules like engine only with engine type. Propane engine, all propane engines are good. All gasoline engines are good, but depending upon the other attributes. So there are certain deterministic, that is certain rules are there, and there are some uncertain rules are there, that is non-deterministic rules are there. What is the L11? That is all propane engines are good engines because it is deterministic. All the table, all the records you can see in car with propane engine is good always. But you see the second rule, 14, L14, engine gasoline, it is saying good, but it is non-deterministic because here all gasoline engines are not good. There are gasoline engines, there are cars with gasoline engines, but these cars are bad cars. Okay. Likewise, we can prepare the deterministic rules and non-deterministic rules. As and when the size of the data increases, the nature of rule also changes. And these rules which are derived from the table, from the data set or from the information system with us, we can use these rules, we can give these rules to the expert system and the expert system will take its own decision based on the rules provided to the system. So ultimately, by using rough set theory, we could able to find out the rules, and these rules are the input for other system. When this hybridization happens, the results are much better as compared to a standalone system. So this is the final topic of rough set theory, and now we are going to see certain applications of rough set theory. How rough set theory is applicable and where it is applicable. It, as many people have used rough set theory in many areas, they have worked on various data in different areas. Here, these are the few examples. In medicine, rough set theory is used for treatment of duodenal ulcer, then diagnosis of pneumonia patient, and preterm birth prediction. These are the three applications where rough set theory has been applied. The decision has been taken, decision rules are generated, and these rules found correct. These rules are very good help for classification of the patients under this category in medicine. Similarly, in economics, finance, and business, also rough set theory is widely used. Bank credit policy, how to give the credit policy for the customers. There also rough set theory is used. Customer purchasing behavior pattern is studied by rough set theory. Then discovery of strong predictive rules for stock market. This is one of the very popular application. Every day you know that stock market data, a continuous, a volatile market is there. Continuously data is changing, and we have only fraction of second or very few seconds to take some decision whether to buy a share or whether to sell a share. In our day-to-day intraday trading, these people are very fast. They have to take the decision very quickly. In that case, they have used rough set theory widely to make their decisions faster. In environment also, drawing premonitory factors for earthquakes in this geochemistry, that is used global temperature stability. You know that today, nowadays, we all are talking about the global warming, and we know that how the environment is changing. We heard about the news in Canada. All these type of things, lot of cases are there in real world where rough set theory can be used and predictions and decisions can be made in early stage so that we can avoid major crisis. And finally, in engineering also, the filtration and coding of audio, assessment of concert hall acoustics, and image analysis. Acoustics and image analysis, you know, image processing. Lot of applications are there. While preparing the hall, concert hall, how to manage, how to prepare the acoustics. Acoustics means to avoid the echo. How to design that particular hall. That is the application of rough set theory in engineering. So these are the various applications of rough set theory in various fields. This theory nowadays become very popular because people have used this with other theories, and it has become complementary to other theories, and this hybridization is giving better results. So I had given 1 hour of time till 3:30. My time is over. Last minute is over there. So I conclude my session here. If you have any questions or doubt, queries, I'm here to answer it in last 1 or 2 minutes. Thank you. These are the applications which I have shown there. Thank you. With this, I have concluded. My talk is over. Thank you very much.
Good afternoon, sir.
Good afternoon.
Sir, I have a question.
Yeah.
When should we use fuzzy set theory and rough set theory? Is there any clear-cut line of difference to use them?
Okay. See, fuzzy set theory and rough set theory, they are as I have discussed in my topic also. Both are complementary to each other. We when to use which theory, it is really a challenging thing. Nobody can make a certain rule that rough set theory must be used on this type of data, fuzzy set must be used on this data. But in general, we can say that when the data size is small, when there is a lot of ambiguity, when there is a missing data in the system, then rough set theory is better to use first. And then, when in opposite to that, when as per the requirement of the fuzzy set, size of the data and the data is complete and all these things, then we can use fuzzy set there. So rough set theory, we can say that when the data is ambiguous, incomplete, small, then rough set theory should be used. Have I answered your question?
Yes, sir. Thank you so much, sir.
So my talk is over. Thank you all for patiently hearing and asking the questions.
Thank you, sir.
Thank you.
Aisha?
Thank you so much, sir. Now, I would like to request Ms. Harsha Senyapan to extend gratitude to Dr. Ajit More.
Thank you, Aisha. I express my gratitude to Dr. Adit More for enlightening us students and participants on classification based on rough set theory. I also thank Sir for sparing his valuable time and being part of this 2 days National E-Conference on Data Mining and ICT, NCDM 2021. I'm sure your ideas and thoughts will go a long way in developing us as IT and managemental professionals. Thank you, sir.
Thank you very much, the organizing team, for inviting me for the talk. I wish all the best and great success for this conference. Thank you.
Sir, thank you. Thank you very much, Dr. More, sir.
Thank you,
It's
sir.
our pleasure to hear you and such a wonderful speech session. Thank you, sir.
Thank you, sir. Okay.
We will now have our fourth session of this national conference. The workshop of this session will be on art programming, and the honorable speaker for this session is Mr. Titus Newton. I now request Nazmina Halyal to introduce our today's guest speaker.
Thank you, Noreen. Sir is a senior technical trainer and research scholar having an overall experience of 12 plus years. Currently, Sir is pursuing his PhD from Savitribai Phule Pune University. Sir has his passion in data science and his areas of interest are in Python programming, R programming, machine learning, deep learning, and AI. Sir has also worked on multiple projects which were related to IoT, that is Internet of Things. Until date, he has trained 1,500 plus students on his technologies. We are, we are extremely happy to have you with us, sir.
Thank you, Nazmina. Before going ahead, the instructions for the participants will remain the same as they were for the previous sessions. Parallel to this session, we are also starting with our paper presentations as well. Those who are presenting their papers today, they have to join in a different meeting as per their schedule. And once they are done with their presentations, we request them to kindly join us back after their session is over. So you all can join your session now and you all can join back again. Now I would like to request Mr. Titus Newton, sir, to start with his session.
Yeah. Thanks, Noreen and Nazim.
Titus, sir? Sir, yes. Is the volume fine, sir?
Yes.
Okay, sir.
Okay. Thanks a lot. Yeah. Are you able to see my screen?
Yes, we can see your screen. Welcome, Titus Newton, sir.
Welcome, welcome. Thank you, sir.
Please proceed.
Yes, yes, sure. Okay, so I hope you have all installed R Studio, and yeah, can you see what I type? Yeah, is the typing visible?
Yes. Titus, sir, it is visible, but a bit small.
Okay, I'll just zoom it. Okay, now is it visible?
Yes, sir. Fine, sir.
Okay, okay, good. Okay, so now we are going to see about R programming. We have to install first R, and on that we have installed this R Studio. So this is how your screen would look. Might be different because I have just customized it so that for the training purposes. I have kept here the script where we would be typing the script into it, and this is where you will be able to see the outputs into it. Now you can see this is the prompt into it where your outputs will be displayed into it. So I'll just clear this console by pressing Control L. What happens is your outputs will be visible here. I have just minimized this window over here, like environment, history, connections, files, plots, packages into it. That's all. Okay, so these are the two main windows we have. We will be writing our script over here, and once we have written the scripts, we can execute it either by pressing Control Enter. So a line by line, the script's output will be displayed over here. You can also work along with me as we are going to have an hands-on. So the more you work, the more errors you get, the more learning would take place. Okay, first of all, what is R programming language? R programming language is a language where we can program the machine, and most widely it is used for the statistical analysis purposes into it. Now recently even your machine learning can be done with the help of R programming languages into it. It's also as popular as Python programming languages. Python is also very simple to use. R comes with a bit of restrictions into it, set of rules and regulations, as it's functional based mostly, and it's not object oriented based into it, right? So everything in R that you will be dealing with will be always functions, right? So we'll see shortly what is functions and all as we dive deeper into the basics. Okay, so let's see what is are we trying to deal. We are trying to deal with something that is called as data. Into any programming language we are trying to deal is we are trying to deal with data. What is data? Data is just a piece of information where we would try to manipulate it, or we are trying to store it into a memory so that we can process and we can transform a data into it. So basically on the outer line, what happens is this is the basic process into it. You get input in terms of data into it, and we write the code or a program, or we say it as process into it to display something that is called as the output. A simple example of it can be, for example, if I'm trying to have 5 as an input and the objective of my program is to find out a square of a number. So now I would write a process into it in which the R language understands or the R compiler understands, and we would get an output, and the output that will be displayed as something that is called as a 25. So we have input, we write a process to transform, and we get an output that is displayed as, for example, 25. So now basically text data is all what information you can type from the keyboard. Maximum information inputs we give from the keyboards into it. So keyboard has two things into it. One, we call it as text, and second, what happens is we have something that is called as numbers into it. Now, how does an R compiler or a programming language classify it between text? We call it as strings in terms of computing. They are all not represented as text, they are represented as strings. So strings you can represent by something that is called as using quotations. So you can use either a single quotes into it, and you can also use double quotes into it. The only thing to remember, if I start with a single quote, I need to end it with a double quote. And if I'm starting with a single quote, I need to end it with a single quote. If I start with a double quote, I need to end it with a double quote into it. Is the pace and voice clear? Are you able to understand, grasp what is happening?
Yes, sir.
Okay, thank you. Now, so therefore I can store a value, whatever value, if I want to store it in the form of strings, or in R programming we call it as characters into it, I can use single and double quotes into it. So let's see, how do we say, for example, I'm creating a variable. Let's say a variable, I'm creating it as name. Name is equal to, I'm saying, for example, Alana Institute. Now to execute it, now you can see I've used a single quote, started it, and I can even have a single quotes that I have ended it. So this is a character that I'm trying to store in a variable. Variable is just a placeholder where my values will be stored in the memory. And I can access to this value that is called as Alana Institute by just calling by its name into it. So the compiler takes care of allocating the memory, storing the value, retrieving the value, everything that is taken care by your R compiler. So to execute it, I'm on line 8. My cursor is currently blinking on line 8. I'm just pressing Control Enter. You can see the instruction gets copied over here, and what instruction I have copied. Out of all this information that I have typed, I have executed only number that is called as line number 8. So this is called as even line by line execution. If I want to execute multiple lines, I can select multiple lines and then execute it by pressing Control Enter. Now let's write, for example, name into it. Now what output it would give, you can see if I execute it. Now you can see it gives you output as 1, and the output of it is what, as Alana Institute. Now you can see again quotes are there into it. So the data is string. So now we need to classify data into various forms in which it can be stored. So this data that we are storing our string into it, so R would consider it as something that is called as characters. So now you can see use a function. This is how you use a function. Name of the function, an opening parenthesis and a closing parenthesis, and the circle bracket into it. Inside this, I can write what I want to search. So now, for example, I'm passing just name into it, and when I execute it, it would give me its class that is called as, it is of the type that is called as character into it. So this string is a data of a specific data type, we call it, and this data type that we call it is called as something that is called as a character into it, right? So why do we need to classify, or why does a programming language need to classify it? So that what operations can be performed. I can perform some operations on characters. I can perform all the mathematical calculations that can be done with something that is called as numbers. But those operations that I can do with numbers, I cannot do with something that is called as a character, right? And the way they are also stored into the memory differs. So therefore, they are all called as different data types into it. So R comes with different data types into it. We have like vectors into it. We have list into it. I'll just jot it down so that you also remember. So we have vectors into it. We have list into it. We have matrices into it. We have arrays into it. We have factors into it. And we have data frames into it. Okay, the next is what we have numbers. Numbers are again classified into three types. One is, for example, your integer into it. Second, we have float, or in R it's called as numeric. In other programming languages it's called as float. And the third that we have is complex numbers, which has a real part and an imaginary part into it. So we call it as complex. Now just let's look at an example of this. Let's say, for example, I have number 1. So I'll just put it as num1 into it is equal to, for example, I have 10. And now when I execute it, and again, as usual, if I see the class of it, and if I say as num1 into it, you can see it gives you as numeric. Now what happens is numeric, we already said is float. Now if I want to, now difference between integer is what? Integer is a whole number. In short, to remember, without fractions, whatever number I have, that would be considered as integers into it. Wherever I have points into it, decimal points into it, would be considered as numeric. And wherever we have the real part and the imaginary part into it, like for example, 3 plus 4i, mathematically as we say, these are all called as complex numbers into it. Now, if I want this number 1 to be as an integer into it, I need to suffix it with the capital L into it. If I suffix it with capital L, now what would happen? It would become as integer. And now when I execute it, and now when I see by the up arrow key, I can, sorry, in this screen, console screen, by the up arrow key, I can again revisit whatever instructions I have executed. Everything is being stored. So this is what we were trying to execute the class. And now you can see we get it as an integer, where previously it was something that is called as numeric. In the same way, we can even go for the complex number. So I just say it as cnum is equal to, let's just copy the same thing, 3 plus 4i. And when I execute it, and now when I see, for example, class of cnum, now you can see that it gives you something that is called as complex. So the numbers are classified into these three types into it. Either it can be an integer or a numeric or something that is called as your complex into it. Again, we can have type cohesions into it. Type cohesions are converting from one form to another form. If now I have number 1 in an integer form, I can convert it into a numeric also by saying it as dot numeric. This is again, we have a function into it. This auto completes are helpful in R Studio, and that is why we use R Studio into it. So as dot numeric, if you type, and then if I pass num1 into it, And if I assign it back again to some other variable, let's say as num2 into it, no spacings are allowed while you're declaring a variable. So you can see all are being connected, right? I cannot have num space 1 into it. Now when I execute it, and now if I see what is the class of num2, you would get it as something that is called as numeric. Whereas we had already seen num1 was integer, and now what happens? So these are all converting from one form to another form into it. So similarly, if I want to convert it to a character, what I can do is if I say as character, now what happens is your number also will be treated as character into it. Now if I execute num2 again, and now if I see what is the class of num2 into it, you can see now it has got converted into a character. Now the reason why we already said is now, for example, if I'm trying to add two numbers into it, if I'm just trying to add two numbers into it, for example, if one is a character and one is a string, now what happens is the operation addition is not allowed into it, because we cannot, it does not make sense in adding a number and a character even in the real world. So that also is not permitted over here into it. Now I'll say, for example, we have num1 which is integer, num2 which is an integer. Now if I say, for example, results is equal to, if I say as num1 plus num2, and if I execute this, you see you get an error into it saying as num1 plus a non-numeric in argument to the binary operator, right? So this kind of operations are not possible. Therefore we say knowing the data type in which a value is being stored is very, very important into it. Any confusion still here? So far, is it clear? Any doubts? Or shall we proceed further? Okay. Now we have again another type into it, which is called as bool, which is represents values that is called as trues or false into it. So we say, for example, let's say yes again is a variable is equal to, now I can have it as something with all capital letters into it. And when I execute it, now if you see over here, if I see what is a class of it, now it would be something that is called as boolean into it. Boolean will have just two values into it, either true or false into it. Okay, logical over here. So this is logical. Logical means either it can have two values into it, either it can be true or either it can be false. Now you can have false, again that would be in all capital letters. And now when I execute it, and again when we see the class of S, we would get it something as logical input. So these are called as the primitive data types onto it, because till now we have seen, we have just stored a single values into it, either it is num1, num2, or whether it is cnum into it, or it is logical into it. Now based upon this are your other data types that we have discussed, is your vectors, list, where I can store multiple values into it, and that is where your data comes into the picture. So whenever you are having a data, it would be in either of these forms. Either it can be a vector, a list, a matrices, arrays, factors, and it can also be something that is called as data frames into it. Now, let's see one by one what is a vector into it. Vector is whenever I want to have a multiple elements into it, it can be a vector of integer, it can be a vector of numeric, complex, or it can be a vector of strings into it. Any one data type, it has to be there. If I have a mix of it, R will by default convert it into any one of the data types into it. You cannot have one integer, one numeric, one complex. Though you write it, R internally would convert it into a single data type into it. So let's say, for example, let's go with the vectors into it. Let's create a vectors called as colors is equal to, now I need to use this function that is called as C. C stands for combine. Combine, why? Because multiple values we are going to combine, so therefore we see it as C into it. Now I can put a quotes into it and say, for example, as red, let's go with the primary colors into it, let's go with green, and let's go with blue into it. Now if I execute it again, you can see over here, and if I see the class of colors into it, you can see everything is a character, but because we have three values into it, red, we have green, and now we have blue. So this is how we have stored three values in the variable, same variable name, that is called as colors into it. Previously we had seen we had stored only one single character into it. Now we have seen three colors that we have stored into it. So how can I have an access to it? I can just give the name where it is being stored, and by the position of the elements. So this is at position 1, this is at position 2, and this is at position 3. So by position, now I can say as 1, and if I execute it now, I could get something that is called as red out of it. Similarly, if I go with position 2 into it, I would get color something that is called as green into it. Similarly, if I go with 3, now I would get blue into it. And now if I say 4, what would happen? As there is no element that is present at in position 4, I would get an error into it. It's okay. Saying as not A means it's not applicable. There's no element that is being present in 4 into it. So index, we call this in the programming terms as index. So this is at index 1, this is at index 2, and this is at index 3. I can also use print to print on the output console. I can say it as print. So anything that I want to print on the output console, I can use the function that is called as print, execute it, and now you can see it prints red, green, and blue. And this is the first one is the red, second, third. If there are multiple lines, more colors if I had, it would span multiple lines into it. At that time, what happens is every start of a new line, it would give you what is the index position of that element. I think even if I shrink the screen, that would take place. Now you can see, now suppose if I execute it again, print colors. Okay. So what happens is when it spans multiple lines into it, and everything in the second line would be the index position of the element that is present into the vector. Now I can even say print to get the class of the vector. I can say as class, and we can say it as colors into it. So this is how we get the class of the vector that is called as character. Now let's say we store this same colors into it. We are just having name it as colors into it. Now let's have a value into it, which is an integer, and let's have a float value into it. Let's say, for example, 17.9. And now if I execute it, now you see we have one character into it, one new integer into it, one numeric into it. And when I see a class of colors into it, now you can see everything will get converted into character, as character cannot get converted into an integer. So therefore what happens is integer gets converted into character. So this is implicitly R does it if you are having different data types into it. So now if I just remove this class out of it, and if I print colors and see the difference, now you will be able to see, you get a quotes into it saying that the numbers are no more numbers now, they are characters into it. If I want to see a particular this, I can even say as class of colors, and in the square bracket I can give an index position to it and then execute and see. Now it would give of this element what is the class of it. So you can see it's a character. So this is all about your vectors into it. The next data type that we have is list. This is very, very important before we go on to an interesting topic that is called as data pre-processing, that is using machine learning into it, right? So we'll just have so these are the data types that I need to know, so that how do I process it and how does the machine learning works in R. We'll just have, if time permits, a simple use case, and then we'll see the practicality of it. Okay, then we have lists into it. List again is an data type in R, which can have different type of elements inside it. Now I can have a vector inside it, I can have a function into it, I can even have another list inside it, or any things that I can have. Different data types can be there into a list into it. So let's say, for example, we have list, and the easiest part into it are Python. Why they are so famous in the industries are what? Due to their documentation into it. If I want to see how does a list works, directly I can just put a question mark into it, and if I execute it, now you can see on the help, you can see this tab on the help, how is it, this is in what package is the list available. You can see it gives you our documentation into it, list, and then this is how the documentations are available. So it says functions to construct, course, and check for both kinds of R lists into it. I can use, this is how list, and I can pass multiple values into it. The dot 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 represents passing multiple values into it. If I want to convert some other thing into a list, I can do it as dot list into X, and it says what are the parameters it accepts. Hash is nothing but it's a comment that is not executed by a program. So you can see now what does X means, what does all dot names means, what does sorted means. So these are all the things that we can pass as an argument to the function that is called as list. And finally, you would get an example also. You can see now this is how you get the examples, and you can see PTS again is a variable. This is the old style of R programming. You had to use the left angle bracket and then this. Now also you can use it, no problem, but nowadays it supports equal to also into it. So therefore we use equal to as other programming languages we use. So you can see we have cars as the data set into it. Y is equal to cars, again the data set into it. So these are being stored into it. Plotted, how do you do that? So if we want, we can just copy this same thing and we can paste it over here to execute and see. Now we have PTS into it, cars are a data set that comes preloaded with your R, right? So therefore there is no need to it. So we are creating a list out of it. X, we are extracting the first column into it. That is one that is being set into it. This we'll see in more detail when we come to data frames into it. This is the second column. It is an tabular data into it. Therefore, we are extracting all the rows into it, comma. This is the first column and this is the second columns into it. So let's execute it. Anywhere on the line, I can have my cursor. Control Enter. Now will give me the PTS into it. Now I can even look at, suppose if I want to look at the first 10 entries or 11 entries or 15 entries of the PTS, I can say it as head, and I can pass the PTS into it as a first argument. Second, how many entries I want to see is the number that is into it. So I'm saying of the data set PTS, I want to see the first 10 entries, first 10, that is why I'm writing head over here. So now if I execute it on the console, I'll just minimize this help. Okay, on the console, you can see we have two variables into it. One is X and one is Y. And how I can access this? PTS $X, I can access this all elements over here. PTS $Y, again by the index positioning. Now you can see 1. This is the index position of 4 into it. 18, this is the index position of 13 into it. 35, this is the index position of 18 into it. Right? So now if I say, similarly 1, 13, 25, so these are the index position of 2, 20, 26, 46 and 120. So we have 49 and 120, right? So I can even say, for example, PTS $Y, because it is in the Y, and I can pass what variable I want. I want the 49th index. Now you can see that would retrieve 120. That is the same. We do not have any other 120 entries over here. So a little bit of observation, if you do, like how the output is being coming and everything, you can make analysis of how you can extract the data through. Again, we have, if I want to see the last 10 entries of it, I can go with the option that is called as tail, and I can pass PTS. By default, it will return 6. Now, if we see the class of it, now if I say as class of PVTS into it, now you can see it gives you the type that is called as list into it. So if I say PTS $X, now I would get, again, it's in case sensitive language. The capital X and the small x are different into it. If I say as PTS $, and now you see you get an auto completion from the R Studio that we have two variables into it as X and Y into it. But now if I say it as small x into it, okay, that was a small x into it. Now if I say as capital X into it, and then if I press execute it, just let make it as capital. Now you can see it gives you as null, as no values are being returned into it because there's no variable called as capital X into it. So it's case sensitive languages. Small and the capital makes a lot of difference into it. If I write small x, I'll be able to retrieve all these things into it. Now, similarly, I can even use plot PTS. By default, it would take x in the x-axis and y on the y-axis, and it would give you a plot which would look like this. I can even click on the zoom, it will open in the new window into it, right? Okay, so far clear? Any doubts till now?
No, sir.
Okay. Next, we have the matrices into it. The matrices would consist of your tabular format, like number of rows into it and number of columns into it. So now I can go for even a matrix into it. Again, I can say, for example, M is equal to, again, a matrix. And if I want to have more than one element always, I need to use the function that is called as combine. And I can go as 1, 2, 3, 4, 5. Let's go for 6 elements into it. And let's say a parameter into it. I need to say is what should be the number of rows into it. Number of rows is equal to, let's say, 2. So there will be 2 rows into it, and automatically I would have 3 columns into it. So 3 by 2, 2 by 3 matrix would have 6 elements into it. Now if I execute it, now you can see a matrix is being created. Just clear it. And now if I see print M into it, now you can see we have 2 by 3 matrix which has 2 rows into it, and this is the columns into it. So if I want to extract the first column, that is 1 and 2 into it, what I can do is I can say as M, and in the square bracket, comma 1 I can write, so that if I do not pass anything into this comma means all the rows into it. So now when I execute it, now you can see you would get values that is called as 1 and 2 into it. Similarly, if I want the second row full, this second row, if I want, what I can do is I can say as M, again 2, comma, now this says only the second row, and if I do not specify anything means all the columns into it. Now you can see you can extract 2, 4 and 6. Now if I want to extract 6 into it, now that is on the third row, on the third column, on the second row. So now I can say row goes first. So I can say as 2, comma 3. Now I would be able to extract 6 out of it. Now you can see by default it has placed by row is true into it. That is called as default behavior. If I do not want it by row to be filled, I can say it by row is equal to false into it. Everything in caps, false. So now if I execute it, now what would happen is I would get a matrix, again M, which would be filled column wise into it. Now you can see here we had 1, 2 into it. Okay, I think I need to say true into it. By row is equal to true because it has filled it by columns. Okay. And now if you see what is there in print M, now you can see we get 1, 2, 3 into it, and then we get 4, 5, 6 into it. So row wise, it starts filling the elements. Here what happened is column wise, it started to fill the elements into it. So if I want to change the order of it, I can change the order of it into it. So by default, it fills column wise. If I do not want it to fill it column wise, I can even say it as row wise into it. So this is how you create a matrix in R, a data type into it. The next two that we have is your arrays and factors and data frame into it. Okay. Arrays is what? Again, matrix are two-dimensional into it. Arrays is what? A matrice inside a matrices, right? So it is a combination of the matrices into it. Like for example, we have your RGB values that each pixel element has an R value and a G value and a blue value into it. So those are all an examples of something that is called as arrays. So the information that is being stored by what should be the color of a pixel. So each pixel has three values into it, like red, green, and blue. The combination of the red, green, blue is what you get the color of the pixel into it, right? So those are all the examples where we have multi-dimensional. So those are all called as what? Arrays into it. So again, we can create arrays using, again, let's say ARR is just the name of an array into it. Again, I can go with, for example, the function. Let's create C and then pass values into it. I can say it as blue into it. I can say it as green into it. And I can say, for example, red into it. And I need to pass dimension into it. Let's say the dimensions I want to pass is I want to have how many values do you have? 3 values into it. Okay, so let's say, for example, we want to have 3 rows, 3 columns, and we want two dimensions, two copies of it. Let's say, for example, we can say as dim is equal to, and then I can say a combination of, again, let's say as 3 comma 3 comma 2 into it. Now if I execute it and if I look at what is there into arrays, now you can see we have red, red, red that is being there into it, green, 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 blue, blue, blue. So we have 3 by 3 matrix, and this is the first matrix into it, and this is the second matrix into it. So if I say, for example, again 3 over here, now what will happen? I would have 3 copies of it into it. So you can see we have red, green, blue. This is the first matrix. This is the second matrix, and this is the third matrix into it. Again, how can you access it? If I want to access the first one into it, for example, I can say as ARR square bracket, comma, comma, and then let's say we want to access the third matrix into it. Now you can see we get into it. Now in the third matrices, if I want to access the first into it, what I can do is I can say as, and then again I can put a square bracket into it, and then I can say 1 comma, and I would get the red, red, red into it. If I want to access the red into it, again what I can do is say as 1 comma, I can put column 1. Now you can see you get the access. So each individual elements can be accessed. What data type you are storing into it is very, very important into it. Yeah, is it clear? Clear. So moving on to the factors, or is it too fast?
No, sir, it's clear.
Okay, good. Now this is how you can create again a factors into it. Factors are some, for example, we said when we are going for a machine learning into it, we want the data that would have is in the format of a tabular format where we would have rows and columns into it, right? Like this red, green, blue, these are all now not numbers into it. What we are trying to do in the machine learning is trying to figure out a mathematical model that would relate to the whole data set into it, trying to find out a relationship into it, trying to extract some insights from the data into it. We'll see it shortly. Yeah, so now this type of data that we have, like red, green, blue, such type of data are all called as categorical data into it. Categorical is because you can't do any processing with a red, red, green, green, blue, blue. No such processing can be done into it. So in R, such type of data are all considered as something that is called as factors into it. When we go into data pre-processing, we'll see when we have a data set which has such kind of values into it, how do we handle it? That we'll be seeing in the data pre-processing part, right? Okay, so now we have this into it as factors. So we can say, for example, let's say f is equal to, I can go again with factors, autocomplete comes into it, right? Now I can have, let's again go with the combo of c is equal to, let's so I just have two copies of it, each are having two values into it. Can I have anything into it? Before that, just let's not store it as a factor. Let's say it as f is equal to, we are just creating a vector. And if I see what is there in f, now you can see we have red, green, blue, red, green, blue. So these are all characters, but stored in the format of something that is called as a vector into it. So now you can see we have 1, 2, 3, 4, and the 5 I already said is the index position of the screen into it. Then we have 6 into total things into it. So now let's consider this into a factor into it. So let's say, for example, factor underscore color is just the variable name into it is equal to, I can say as factor, and I can just pass the f, the vector we have that we have. And now once I've executed it, again I can see what is there into factor color into it. Now it's, you can see it gives you as red, green, these are the values into it. Now you can see it gives you as levels, and there are only 3 levels into it, that is called as blue, green, and then that is called as red into it. Because all the other values are just the repetition of something that is called as blue, green, and red into it. I can even check the levels out of it. I can say as n levels, and I can pass the vector that we created f into it. Sorry, the factor color should be passed. Now you can see there are 3 levels into it, that what it says. So we had blue, green, and then red into it. Now coming to the data frame. So this is where most of your data set would be in this format, that is called as your data frames into it, because basically this is how the data are being represented in the R programming language. Now, mostly whenever you get a data into it, either it might be an Excel file or a CSV file, or you're retrieving it from a database. So now what happens is all tabular format data in R will be represented by a data frame. So mostly you would be getting the file for the analysis in tabular format, and in this tabular format, R would consider it as a data frame into it. Now let's take an example. How do we create a data frame into it? Let's say, for example, I'm having the body mass index, let's say BMI. Let's go with the old style of programming R and BMI. This is whatever is on the right, assign it to a variable that is called as left into it, right? So similarly, I can have values over here. Let's say, for example, now let's say, for example, A, I can say it as 10. This means store 10 inside a variable that is called as A. So I can say, similarly, I can say B. Now instead of B over here, I'll have the value that is 11. 11, store it in the variable that is called as B. So at that time I can use this right hand side arrow pointing type into it. So now when I execute it, now you can see we have A executed without an error. This also got executed with an error. And the third style is what usually used in all the programming languages. I can say as C is equal to 12. So all the three are one and the same into it. So if I print A, I would get 10 into it. If I print B, I would get 11 into it. And if I print C, I would get 12 into it. So here we have the value over here to the right and the variable name to the right. Here we have value to the left and the variable name to the left and the value to the right. And this is what you can use also. Okay, so now coming to data frame into it, suppose now I want to create BMI and let's say is equal to, now I'm creating a data dot frame I need to say. So this is how you can access it into it. So again, in the opening brace and the closing brace, now let's say we want to have a variable called as gender into it. This will be the column now, is equal to C of, for example, let's go with male, comma female, comma female, comma male. So this is one column into it that is called as gender. Again, separating it by column, comma. Then I can have another column that is called as height is equal to, I can go with C of, again, let's put the height in centimeters. Let's say 150, comma 170, comma 160, comma 165. So these are the four heights of people responding to the same thing into it, right? So four observations in terms of machine learning, we call it as. Then I can have weight of a person. This is another column. Weight is equal to, again, I can have combinations of into it. Let's say go in kilos. For example, let's say it's 65 kilos, 67, any value randomly we are putting. We are not creating any data set over here. And then I can even have the age of a person. And now I can say age is another column into it. And I can say as C of, and then I can put some values into it. Let's say 34, 21, 45, 67. And now these are the 4 into it. Now if I execute it, now you can see this multiple line strings because we have put it all in multiple lines, not in a single line for readability. Now plus 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 it combines and it executes this opening and the closing bit, and then it knows that it is being complete, and then you get the prompt into it, right? If I do not have this opening brace now, and now if I try to execute it, BMI, and then if I press Control Enter, now you can see it is waiting. Now I can execute this line. Now you can see it took height, weight, age into it, and now there is no closing brace into it. Now if I put a closing brace and if I execute it, okay, now it is waiting for a plus into it. Now I can execute it. Okay, I think I need to put it in the console. Okay, here if I put a closing brace, now you can see it gets released into it. Okay. Now if I check what is there into the BMI, now you can see we have columns as gender into it, height, weight, and age, and this 1, 2, 3, 4 are called as what? Observations. This is the first observation of a person whose gender is male, height is 150, weight is 65, and age is 34. Similarly, we are going to have a second observation who is a female, height is 170, weight is 67, and then the age is 21 into it. The third observation who has gender F and height and weight and then the age. So these are all called as observations into it, and these are all the columns that we are having as height. And so this is the format that most of you times whenever you're doing in statistical analysis or a machine learning into it, what happens is your data will be in the format of rows and columns into it. So such type of data are being treated as data frame into it. So if I see again the class of BMI, you can see it gives you as it is a data frame. Yeah, is it clear so far? Before we move on to the data pre-processing part into it and the machine learning?
Yes, sir.
Yeah. Okay, so this is how we have data types, various data types where your values can be stored into it. Now, the data that you are going to get, the information that you are going to get always to do an analysis into it is in the form of something that is called as a tabular format. That is either it might be your Excel sheet into it, or it might be a CSV format, comma separated values into it. So in any of these formats you can get. Now, are you people also having and working on R, or are you just active listeners, participants, or doers also? Okay, do you have a machine? R is installed onto it so that I can give you a data set so that we can do it together, or else then I'll just proceed with the presentation. Yeah, Bhushan, can you help me out with it? How is the process going to be?
Hello, sir.
Yes, Bhushan.
Yes, sir.
Yeah, are students also having R, or the simultaneously working, or just should I proceed with the presentation?
Sir, some are simultaneously doing also, and some are just taking down the notes.
Okay, okay, okay. Yeah, but people
Yes.
who are doing it, so how do I share the file?
So you can just share this. Who is doing it? You can just copy it and paste it in the chat box.
Okay, right.
You can just paste it in the chat box. So from there, they can copy it and they can have it on their systems also.
Oh, okay, okay, sure, sure, sure.
Yes, sir.
Yeah, thank you. Okay, so now let's go on to the data pre-processing part, which is the first step into the machine learning into it. And let's look what is machine learning and exactly a small glimpse of it. Everyone is on your screen, right? On the screen, if you zoom, if you click on the CC, you can see automatically when I have you turned on the caption into it. Now you will be able to see as I speak the words that are being translated and it is being displayed to you as a script. Yeah, are you able to see that? So this is also an example of machine learning into it, where we are trying to convert a speech into text. So it's also a solid example. Its script is not loaded previously. It is as you are trying to speak, what happens is the script is getting generated into it. So this is an example of a machine learning also into it, right? So let's look into what is machine learning, what are the categories into it. The same thing also takes place on the YouTube also, right? Whenever you're watching a YouTube video, previously you need to load the script file, but nowadays there is no need to load the script file. Automatically words are being generated as you speak, and the accuracy of it is also good, like 95%. What happens is the file is accurate, right? The words that you type are correct into it. Okay, so the first part into the machine learning is, what is machine learning? Machine learning is trying to identify some insights or patterns from the data where I can make analysis onto it based upon the future customers or on the future behavior of the customers or something. That is where your machine learning is being used. Machine learning is nowadays widely used in all the domains, right? Like medical field into it, image analysis, everywhere now what happens is machine is being doing into it. So what happens is, like now we have seen the programming into it, where we have the input, the process is what we're trying to write out the rules, like how a file has to be transferred, uh, how a file has to be transformed into something that is called as 25. So those rule I need to figure out, like saying a is equal to, now I need to say it as 5, and then I need to write the result is equal to a star a, right? So this is what I'm trying to write the rules to the machine, and the machine is trying to figure out what is going to happen. Then I'm going to display the output, and I'm going to say as print result into it. This is what we call it as traditional programming. So where we have a value a is 5, where the result is a star a into it, and then we have print result into it. So just a small example we have taken. Now when I click execute it, for example, now I can get the output that is called as what? 25 into it. So this is the input we had, this is the output, the rules that we wrote, and this is how we are displaying the output into. Similarly, now in the machine learning, what happens is we have the output with us. For example, every observation that we saw over here, for example, is an observation into it. Suppose if I had one more column into it, like the BMI rules into it or something, right? So what we are trying to do, given a person's gender, height, weight, and age, what is the BMI of the person? Second observation also we have, third observation also we have, and fourth observation also we have. the values into it. So we are passing this as an input, like for example, as we have passed a is equal to 5, and we also have the output of it. Like for example, we might have another column, and we might be having values of BMI for all these persons into it. So that is the result into it. Now, having this, as the machine's power, processing power, storage speed, the storage capacity, all has increased drastically, and a drop in the price, the machines have become more powerful. Now what we are trying to do is this output and this input that we are saying the machine to figure out this rule. What is the rule that is being between this, we call it as independent variables into it, and what we are trying to predict will be called as your dependent variables into it. Right? So we need to do some data pre-processing into it before we pass this to the algorithm. Algorithm is what is going to figure out this relationship. That is the relationship between the independent and the result is, for example, let's say a mathematical equation, it would give you as like A star A into it. Yeah, so far, is it clear? Have you understood exactly what is happening into a machine learning?
Yes, sir.
Yeah, so this is what we're trying to do. So we need to differentiate what is the independent variable, because the algorithm would not know, right? What are you trying to predict? So I need to segregate, make a difference between the independent variables and the dependent variables into it. There might be some missing values into it that I need to take care. We have some statistical rules into it. How do we handle it and all? There might be categorical variables, like I said, the red, yellow, the red, blue colors we have. How do we convert it also into something that is called as numbers? Because when we are saying some mathematical equation, so everything should be something that is called as numbers into it. And then later on, we can even again map it back to something that is called as red, green, blue or something. So how do we do that? I'll just give you some data set into it.
टायटस सर.
हा
सर स्क्रीन ब्लँक झाली आहे का?
नाही, डेटा कॉपी करून त्यांना देत आहे मी.
बर बर, ओके ओके सर, चालेल.
हा, त्याच्यामुळे okay, on the chat I'm pasting. It's in Tableau. Let's see how it comes. Okay, so have you received it? We have country as the age. If you have a spreadsheet, you can copy it in the same way. So country is the first column into it. Age is the second column. Some columns are having missing values into it. That is kept on purpose. Salary, and then we have purchased. So once I show you how the data set looks, you can confirm it whether it got pasted properly or not into it. Okay, so the first step into it is called as data pre-processing into it. Data pre-processing is where we do all the cleaning parts of the data into it. So therefore we call it as data pre-processing. So there are various activities that has to be done into it. Mainly we have 5 activities that goes in the data pre-processing part into it, right? So the first thing what we need to do is we need to have the file. People, those who are working simultaneously, can create a folder on the D drive or somewhere. name it as R workshop or whatever you like, and make sure the file that you have copied in the Excel, store it into that. So now let's see, if I say get working directory, I would get the current path. Now you can see this is what I get as the current path into it. Now I need to set it to a path where my file that I have stored into it. So in the codes, what I can do is I can just copy that path and I can save it into it. So you can just click on the data file on the Explorer address bar, just click on it, just Control C, copy that path into it, and then you can come over here and paste it. Now, before you execute it, make sure that you make it as all double slashes because of the interpretation of the programming language. You need to say it as double slashes into it. So once you have said that this is the folder where I have my data set, and now what I can see is directly have an access to that data set into it. Now my working directory is being set to this location that is called as R or data set into it. So the first step is what I need to do is load the data to my environment. So I just give a variable to it as data is equal to the file that we are going to save it. When you're saving it on Excel, you can go to file, save as, and in the file type data.csv, right? You can name the file as data, and in the file type you can click on CSV, that is comma separated values into it, right? Now I'll just show you how the data looks over here. So what happens is, because it is in the CSV format, you can see read.csv, and in the codes directly I can write the name of the file. D is capital into it, so capital, I said case sensitive language. Dot, I need to also say the tone thing. So now when I look into it, now if we see, and if I read, see now what is there into the data, I can just type data into it and press enter. It's just a small file which has column countries into it, age into it, salary into it, and then purchased into it. Purchased is what we are trying to predict. This is where we are interested, given the country, given the age, given the salary, whether a person has purchased a product or not. So this is our dependent variable into it, and country, age, salary is our independent variables into it. So we have your independent variables. This is what we need to identify, is your country, comma, age, comma, salary are your things in it. And the dependent variable is what we are trying to predict, is something that is called as purchased. What are we trying to find out? We are trying to find out what is the relationship of this independent variables in this whole observations that we have. So we have total 10 observations into it, and we have 2 NAs are what missing values that R represents. Whenever I have a missing value into it, R represents it by something that is called as NAs. So we have 2 missing values. These 2 missing values we need to handle. This country that we have is a categorical variable like France, Spain, Germany, that has to be handled, right? And then the data has to be, let's see one by one into it. Okay, so first is what? Let's handle the missing values into it. We have NAs over here. This NAs we need to take care of, right? So I'll just write a comment again over here like hash taking care of missing values. Okay, so how do we take care of the missing values? We have 2 values into it. One is called as age, which is having a missing value over here, and the salary, which has a missing value over here. Now, through the statistical methods, we have 3 modes. One is called as either you replace it by a mean, first thing is either you replace it through a mean value, or mean is, for example, like calculating all age observations of all these ages into it, and then divide by the total number of observation, what value you get, by that value you can replace it. Sometimes if your data has outliers into it, outliers means, suppose now you can see our data is in a range from, I think, 27. Okay, we can even have it through the info function. We can say as info, and I can pass data into it. Right here, I think in R it's summary. Okay, summary, and then I can pass data into it. Now you can see this is how you get the summary of it. This is country. There are 4 France into it, 3 Germany's into it, and 3 Spain's into it. So this is just a count of the independent values into it. Age, you can see the minimum age is 27 into it. The maximum age is 40 into it, 48 into it. And there is one missing value. There is 1 into it. The first quartile, median, mean. So you can see the mean is what? 37.44 into it. So this mean is, we are getting a value which is a representative of the data set into it. But if I had an outlier into it, let's say, for example, one observation had an age of 80 years. Now what will happen, as because we are adding all the age and dividing by 10 into it, because of 80, now what will happen is, it won't be 37.44, it will be slightly pulled towards the outlier that is near 80 on the right hand side, right? So it will be greater than 37.44 into it. So at that time, what happens is, when we have outliers into it, what I can do is I can go for something, second thing, that is called as, by plotting something that is called as median. So median does not get affected by the outliers into it. What are we trying to do? We are just trying to sort it out first by ascending order. So 80 will go on the end, and then we take the mid value. Suppose we have 10 observations into it, so the mid value will be 5.5. So we don't have any 5. So the 5th observation value, the 6th observation value, we add both and then divide by 2, and that would be the median value into it. Third is, I can even go for mode. Mode is what called as most frequent. That is appearing more number of times. What happens is, I can go with something that is called as the most frequent into it. So these are the 3 ways, strategies through which I could replace my missing using. Or else I can directly delete the whole observation. Like we had data into it, I can delete this whole row 6 that has missing values into it. And I can also delete 9 that is there into it. But now what happens is, as we are having scarce data, is very few, we have only 10 observations, and if I delete 2, automatically what happens is 2 observations I would do. So the more we say, the more amount of data we have, the more accuracy the algorithm would give you, because it would have more examples to learn from. So observations are just an examples into it, right? So therefore, handling it or taking care of the missing values is a good thing into it. Now, if I had 10,000 rows into it, deleting 2 rows does not matter into it, right? Okay, so how do we take care of the missing values into it? What we can do is, let's say we have okay, so now what we are going to do is, we are going to handle the missing values into it. Now we have data, and in that we have it in the age column. So you can see, like for example, we say the data dollar, right? Sign that we used dollar. Now we can see we get 4 variables into it: country, age, salary, and purchase. What are we interested in? Changing this. So now what happens is whatever changes we do, we always write it on the right of the equal to sign, and those changes we want to reflect it back. So therefore we are saying it is again storing it back into something that is called as data dollar age. So what we can do is use an if else into it. If else is a conditional statement. Now you can see it has three values into it. Test is what is the condition that we want to, and if the condition is true, the value that we want to replace will be yes into it, and if the condition is false, we want the no to be executed, means we want to keep it as it is into it. So what is the condition that we are trying to make access to it is the missing value. So we can say is dot na. Is dot na is what? It will return true or false wherever there is a value that is called as na into it. Where is the column that is being present? This is the column that we want to check. So now I can pass that into this. So now if I say, I'm selecting only this part into it. Now I can just execute this. Now you can see it returns something that is called as false, false, false. Where is the missing value? This is the place where that is called as a missing value. So in this place, wherever we have got false, what happens is we want the no part to be executed. No part is what? The same value that we have in the age value, right? So what we can do, so this is after comma. If it is true, what should happen? If it is false, what should happen? We can say into it. So I'll just put a comma over here, and now what happens is this is the no part into it. So now I can say no part will be what? The same data dollar age value into it. Now this is the S part into it. Here, now this is the true part into it. By what do I want to replace? I want it to replace it by the mean into it. So I can say mean. Again, I have a function into it, and I can pass the data dollar age into it. Now if I execute only this, I'm just selecting this and executing over here. Now you see you get an NA into it. Why we get an NA into it? Because we have a missing value into it. When we have a missing value into it, you cannot calculate a mean into it. So I want to say the compiler that ignore the missing value and give me the mean into it. So I can say another parameter into it. Na dot rm is equal to, now I'll set it to something that is called as false. So I'm saying ignore the NAs into it and calculate the value mean and then return mean the mean into it. Now if you see, if I execute this statement over here by pressing Control Enter, okay, I said it should be true. Now if I execute this statement over here, you can see we get the value that is called as 37.444 into it. Now I don't want this 0.4444 into it. If I want to round it off, I can again use the function that is called as a round, and then I can pass this whole mean and this whole thing into the round function. Now if I just execute it, I would get the value that is called as 37. Now you can see you get the value that is called as 37. So now if I execute this, and now if I look into my data that we have, now you can see this is the place where we had the missing value that got replaced by something that is called as 37, and that is the value that we got over here. Yeah, the 9th one was the missing, and this was the 10th observation into it. So you can see here the rest are all the same values because we have kept it as data dollar agent. Yeah, have you understood how are we taking care of the missing values into it? Is the code complicated, difficult to understand? It's just a normal if else that we use even in the Excel file. If else test is the condition. If it evaluates to true, what has to be done? Replace it by the mean value. If it is false, keep the same value that is there in the dataset. Yeah, have you got it? Okay, similarly, the same way, we have the salary column, which also has a missing value into it. Now, just give a try to it. Those people who are trying, how would I replace it by the mean? The salary column, which is having a missing value into it. The same way, what we can do is just change. I can just copy this as it is, and I can just go with just changing it. Now instead of age, it should be what? Salary. And here also should be what? Salary into it. Here also should be salary because we want to replace it. And here also I want what? Salary into it. So now if I execute this over here, now you can see the sixth column where we have the salary as missing value into it after the 61,000 into it. If I execute this over here, and now again, if I may have a look through the data into it, now you can see it got replaced by value something that is called as 64,111 into it. So now we have taken care of the missing values into it. Now we have, this is the categorical variable into it, which we have France, Spain, Germany, Spain. This are called as categorical variables into it, which also has to be converted into numbers, so that what happens is the mathematical calculations the algorithms can do into it. So now what I can do is represent, for example, we know map it to some number. I can say France is equal to 1, Spain is equal to 2, and I can say Germany is equal to 3 into it. So when I say, for example, as 1, 2, and 3, and when interpreting the results, whenever I find 3 into it, now I can say that it is for the country Germany. If I say 1, it is for the country France, and when I say 1, 2, it is for the country Spain into it. Because interpreting the results, we are going to do the interpretation of the results. It's only going to find out patterns into it. So at that time, we know what as the number we represented this countries into. So let's just again put a comment into it. Let's say as encoding the categorical variables. Okay, now again, the categorical variable is in the country column. So we can say as data dollar country is equal to, now what we want to do is we need to write a code to convert this categorical variables into something that is called as levels, like label it as 1 2 3 or something into it, right? So we have already seen categorical variables in R are treated as factors into it. So now I can say it as factor the data dollar country into it. I can say it as levels is equal to C of, again we have 3 into it, let's say France, comma, Spain, comma, we have the third that is called as the Germany into it. Then we can say it as comma, and then now what I can do is say it as label it as labels is equal to, again I can say as C as 1 comma 2 comma 3 into it. So the France I'm labeling it as 1, 2 Spain, 3 as Germany into it. Now if we execute it, error in data frame. Okay, we have got some error into it. Data dollar country value is equal to integer 0. Okay, here we made a mistake into it. It is capital C and you put a small c into it. That's the mistake into it. Okay. Let's rerun the code again. Now you can see it got executed without any errors into it. Now if I look back again into the data, what happens is you can see the country is being replaced by 1 2 3, 2 for the Spain into it, 3 again for Germany, 1 for France. So total we knew that we had 4 France into it, so we have 4 ones into it, and we had 3 3 into it. So this is 1 2 3, and again we have 3 numbers of 3 into it. So now what we have done is we have replaced the country. Similarly, this has to be replaced the purchased. What I can do is just copy paste the same code and change it to purchased. So I can see it as, and here also let's make it as purchase. And now here we have only 2 levels into it. So let's say it as no as 1 and yes as 2 into it. And here also what happens is we would only have 2 into it. So no would be represented as 1 and 2 would be in the. So we have first entry as no and then yes into it. So 1 and 2 we should get. Then again we should get 1 1 2 2. Okay. So now let's execute this. And now again, if I look back into the data, what happens is you can see we got 1 2 1 1 2 2 1 2 1 2 into it. So now everything that we have into a data frame, we have converted into the numbers into it. Now what we have cleaned the data, pre-processed the data, and this data is the format that the algorithm requires into it. So this is the most essential step required in the machine learning, that is called as data pre-processing. Most of the time 70% of the time is invested in cleaning the data, transforming the data for a missing value. So such things and all have to be done before we can pass it to the algorithm. So this is the format the algorithm requires, so that it can be passed, it can process on it, and it can give you valuable insights. That is what we are trying to, or we are interested in finding out what is the mathematical equation we are going to get. Yeah, is it clear so far? Any doubts before we move into the last two steps of the data pre-processing? No doubt so far? Okay, so now once we have done this part of it, now what we need to do is divide the data set into two parts. One is called as the training part and one is called as the testing part into it. The reason we want to divide it into a training and the testing part, we would say 80% of the data would be in the training set and 20% of the data would be on the testing set. Training set we would pass to the algorithm for the algorithm to learn from it, and with the testing data set we would evaluate what is the prediction and the actual value that we have in the data set. So we make a comparison between the predicted, the model what it is predicting, and the actual values that we had already in the test set. So now what happens is, by comparing, we would be able to evaluate how accurate the model has done the learning into it. So let's go in dividing the data set into it. So let's split the data into train and test. Now here, this splitting the data into the training test, we would give as a thumb rule, greater than 60% can be given to the training, and greater than 40, less than 40% can be given to the testing. But now let's give 80% to the training, so that the algorithm learns. The more the data it has, the more learning it has, and 2 is enough for us to test into it, as we just have a toy set into it. So for that, we would require a library. So this is where you can see the packages where we have. So packages would have all your packages that are pre-installed by, you can see ask, pass, assert, that, backports, and this is what all it comes into with it, right? When you install R into it. Now we'll be using the package that is called as CA tools into it, right? What I can do is, if I want to install it, I can just click onto it over here, or through code, if I want to do, I can say as install dot packages, and I can, in the codes, I need to pass as it is small c a and capital T O O L and S into it. This is a one-time process into it. Once you have installed, then there is no need to reinstall it again into it, right? So what I can do is just I'm installing it. Now you can see here your installation starts. I'll just minimize this screen. Now it would install it. Now you can see the installation downloaded, MD5 checking, everything takes place. And once it has set downloaded binary packages into it. Now you can see we have CA tools over here. Now to activate it, now I'm commenting it because this is just one-time process into it. Now what I can do is to activate it, I can call it as library, and in the bracket I can pass without the codes. Now I can say it as CA tools into it. Now if I execute it, now you can see automatically you will get a tick mark over here. It's a two ways of doing it, one through the GUI or through the code. This is how you can do it. Because as mostly you will be giving a code to your fellow programmer or something. So doing it through the code is the best practice. Okay, so once we have a library into it, let's say we create the proportion that we said 80 to the training and 20 to the thing. So let's say the rules in a variable that is called a split is equal to, I can say it as, and what do we want to split? We want to split the data. So let's say we have a function in it called as sample.split. Yes, so this is the sample.split into it. You can read the documentation into it. Y is what the dependent variable we need to pass into it, and we can pass by default the split ratio is 2/3, right? So it's 2/3 to the training and 1/3 to the testing into it. If I want to change, I can change it, or else if I do not pass anything, by default it will be 2/3 and 1/3. Okay, so let's go with sample.split. The dependent variable is, this is my dependent variable into it. So let me copy it, paste it over here. Now let me give a split ratio, and let me see a split ratio as 0.8 or 0.2 into it, because we are giving data dollar purchase into it. Okay, let's give it a 0.8. It does not matter into it. Okay, so now what happens is when I execute it, what will a split have? A split will have the values that is called as true and false into it. Now you can see we have false over here, and the rest are true. So these are 80% trues into it and 20% false into it. So this false true values will give it to the training set. Let's name it as training set. Is equal to, I'm going to just take a subset. So we are saying it as subset of, subset of data, where now I need to say split, where we had the split equal to true into it. Now I'm not assigning, I'm saying wherever there is equal to true into it, that you place it in something that is called as data into it. So now if I execute it, and now if I see what is there in the training set, you can see we have 1, 2, 3, 4, 5, 6, 7, and 8. I can even check by DIM is the dimensions, and then I can pass the, not the data now, the training set. And if I execute it, now you can see we have 8 rows and 4 columns into it. Similarly, we want to do for the testing set into it. So we can say as testing underscore set is equal to, I can go for a subset into it. And now I can pass again the data into it. Now what is my rule? Only those values in the split which is equal to false into it. Now if I execute it, again see what is there into my testing set. Now you can see we have values. This values is not there in the training set. These are different and that are different into it. So we can see one entry is not there. It is in the testing set because it splits on a random basis. It does not split first 80 to the training and the next 20 to the testing into it. The reason why, because it might be when you're collecting a data set, you might have good samples on the start of the data set and bad samples on the end of the data set. So what happens is it shuffles the whole data set and then it randomly picks whatever into it. So we have this into it. Now you can see 6 is over here and 1 and 6, and here we have all. So now this training set we would pass to the learning algorithm. The learning algorithm would try to figure out equations from this, and then what we would do, as we have the actual values into it as 1 and 2, so this country, age, salary would pass to the algorithm into it, the learned algorithm where it had done, and it would predict something, and then we would check whether the prediction it has given as correct or not with the actual values in the data set. And that is the reason why we need to divide our data set into training set and testing set into it. Yeah, is it clear so far? The data pre-processing parts that we have learned till now. The first is to handle the missing values into it. The second is encoding the categorical variables into it. Third is what we did is splitting the data set into the train and the test into it. So training, we give near about 80% of the data to the training set and 20% to evaluate how well the learning algorithm has done. Now there is only the last part left into it. That is, we need to scale the data set, as because now you can see if you compare your age and salary into it, right? Your age is having lower values into it, and your salary is having a higher value into it. So what would happen is salary would try to dominate the age, because this is very low in numbers. They are less than 47 or some 48, and these are all greater 48,000. They are all in thousands and they are in tens, right? So therefore we need to bring this age and salary on a same scale, right? So to use the function scale, what happens is all your data types should be in the numeric format, right? That is the requirement whenever you're going for a scale. So scaling takes place by two ways. Either we go for a standardization into it, or you go for a normalization into it. Does not matter whether you're going for standardization or normalization. It is just to bring both your age and salary into the same scale into it, right? So it's just applying a formula into it. Your value that is called as 27 minus the mean value of the whole age into it, divided by something that is called as the standard deviation. So that is the formula for the standard deviations into it. We have different formulas for the normalization. Okay, so I'll just write scaling Okay, before that, let's just check the data dollar country and let's check its class. Now you can see it is still treating it as a factor. So because we have as a factor, then what happens is we would get a problem into it. Similarly, even if I check for the purchased into it, that also would be a factor into it. Now that is also a factor into it. The only two things that we are having is your age is numeric, and if you see your salary is also numeric. So what I can do is, let's say, as data dollar country is equal to, as we said, we can convert from one form to another as dot numeric and the same that is called as data dollar country. Similarly, I can go for, just copy this, data dollar purchased, and here also I'll make it as purchased. Now if I execute it, and now if I see all the classes into it, data dollar purchased now is numeric, and the data dollar country was also numeric into it. So now what I can do is, now I can go for scaling. I can say as, again I'm saying the same name, keeping it, scale it and put it in the same name into it. So we can say as training underscore set is equal to, I can say as scale, and just pass the training set into it. So I'll just copy this. Okay, what we did is we put data dollar country into it. What we had to do is training underscore set and here also we wanted, and here also we wanted training, here also we wanted training. And now I can go for, okay, so training is done, and the testing underscore set is equal to, I can go for scale, and I can go for the testing set now. Okay, let this. The same way we need to do also for the testing also. So I'll just copy this. Then we need to say again testing set. Dollar country, here also we need to say as testing. Dollar purchased. And here also we can go for so let's execute this and let's execute. Okay, now let's look what is there into our training set. Now you can see we have the scaled values into it, like the country, age, and salary. So you can see we have country, age, salary, all are being scaled, right? You can see the mean of countries, age. So this is the mean value by which they are being scaled into it. Similarly, if I see for my testing set also, now what happens is I would get the scaled values of this into it. So this is how you perform scaling into it. And once you have scaled the data into it, there is actually no need for the scaling into it. Most of the algorithms takes care of scaling into it, like your linear regression, your multiple linear regression, polynomial regression. So those all take care of your scaling into it. But if it does not take care of the scaling, this is how I need to scale my data and then pass it to the algorithm into it. So this is the step that we need to perform. The first and the foremost important step we need to do is the data pre-processing part into it while we are trying to. Then what happens is we can apply it to the algorithm and we can have some insights from the data set. But now I think there is no time to look into an example into it. Okay, so is there any doubt into this? This is how we do it in R. The same concept remains the same, and the same we also do it in Python also into it. Only the instructions would change from language to language. If no doubts, that's all from my side. Hope you had a better understanding of how machine learning works on the background. Okay.
Sir, sir, thank you for your session. Just checking for the questions, sir, on both the streaming platforms.
Okay, sure. No
Yes,
issue.
just 2 minutes.
Yes, yes, yes.
Yeah, anyone have any questions? Okay, I guess no questions. Okay, Noreen, are you there?
Yes, sir.
Yes, please go ahead.
So now I would like to request Ms. Rida Bhagwan to extend gratitude to Mr. Titus Newton, sir.
Thank you, Noreen. I express my gratitude to Mr. Titus Newton for enlightening our students and participants on our programming. I also thank Sir for sparing his valuable time and being the part of this 2-day National E-Conference on Data Mining and ICT, NCDM 2021. I'm sure your ideas and thoughts will go a long way in developing us as IT and management professionals. Thank you, sir.
Yeah,
Thank
thanks a
you,
lot.
Tina.
The end of the story is a new beginning for many others. And on this note, I, Aisha Haq,
And I, Noreen Tikuna,
on behalf of Harsha Yepin, Maria Sheikh, Nazmeena Haryal, Rida Bagwan, Sania Khan, and Sobia Khan, thank you all for being a wonderful audience, and we hope that we have been a good host equally. And with this, we conclude a remarkable, memorable, and knowledgeable day one of our national conference NCDM 2021. Tomorrow we will resume our proceedings from here itself with the session on Internet of Things by Mr. Munawwar Sheikh starting at 9 a.m. Till then, thank you one and all. See you tomorrow at 9 a.m. Have a good day.